Check.
Assessing computer architecture will be chaired by Professor Venkatesh Raman. Professor Venkatesh Raman is a professor at the Institute of Mathematical Sciences, Chennai.
Thank you and welcome back to day 2 of Compute. So in the morning session, we have an array of speakers, experts, sharing their experience in teaching and assessment of the courses they are experts in. And the first speaker, who is setting it up now, is Professor Himangi Kapoor from IIT Guwahati, and she's an expert on computer architecture, and she'll be talking about pedagogy and assessment of computer architecture as soon as she sets it up.
Good morning. Am I audible? Right. So, first session on architecture, pedagogy and assessment of computer architecture. Just because all of us teach our different disciplines, just to give a recap or set the context, I have included the syllabus. And then because the main focus will be on assessment, how do you define a good assessment? Then we'll mainly go and see how do we design good exam questions at the Bloom's level and so on. Towards the end, I will discuss or may give a list of different architectural educational tools and then how can we conduct lab assessments. So the journey is quite long. I have to finish in next 40 minutes. Yeah, so I have taken reference as AICTE's model curriculum for the computer organization and architecture course. It covers all these different modules, basically the functional building blocks of the computer, data representation, computer arithmetic. Peripheral devices and different programs, processes, pipelining, parallel processors and memory organization. So these are the list of topics we cover in the computer organization course. And the basic course outcomes listed by AICTE say that the student should be able to design combination and sequential circuits, should be able to analyze communication between the processor and the peripherals, design different memory modules, describe the architectures of various processors and analyze the performance of pipeline processors. So 5 course outcomes are listed by AICTE. Before we begin with the assessment, a quick summary about pedagogy or course delivery. So the first one is pick up a good textbook, and all books are good. So the one which suits you is the good book for you. So pick up a good textbook. Main focus is on the class delivery. The more interactive your classes are and the more energetic and enthusiastic you are about your subject, the students will take that much interest. So class delivery does carry a lot of weightage in how students see your subject. Then this is my personal opinion, and in the world of digital, PowerPoint is the norm, but I prefer using blackboards mainly in for the core topics in architecture, because when you draw the designs on the blackboard, the students end up drawing them as class notes and then they learn. While discussing a topic, let it be iterative or an evolutionary process to give a bigger design instead of directly giving a design of a master slave or a JK flip-flop, where as a student even I learned that this is how a JK flip-flop looks, and I had no clue why somebody came up with such a complicated design. So instead of that, if you can make it an evolutionary process, you start with, I'm just taking an example of a flip-flop. If flip-flop is a storage element, and it can be designed using a cross-coupled inverter. So you give a design of a cross-coupled inverter and then say why this cannot be a generic storage component in a bigger architectural setup. Say that you cannot store value, you cannot replace a value, then you go to an SR latch. Why SR latch is not sufficient, and why do you go to a master slave? What fails in master slave, and then the JK. So if you do this evolution, the students also go through how an engineer came up with this design and really appreciates why JK is the best design, or why master slave is a better design than a cross-coupled inverter. So an evolutionary or iterative development of topic keeps the students engaged. Of course, we can make deliberate mistakes while doing something, and the students just to check their attentiveness. Then it also helps how my course fits best in the complete curriculum. Digital design students, first after a week they will ask, why am I studying this in a computer science discipline? So you need to show how this fits well in their complete curriculum, how digital design is important for architecture, how architecture is a basic block for operating systems, and finally to the applications. So if you can give them a complete stack towards a middle of the course, they will see that yes, I am studying this and this has some importance for my degree. Then towards the end, the last week of the semester, I usually follow that we can give them possible research avenues in this area. What more research is happening, or is this the end? The textbook I am following, is that all that exists, or what are the different research avenues in this area? So that also enthusiasts the students. So that was a brief about pedagogy. Moving on to assessment, very bold statement I read in a research paper that assessment drives learning. So students can and do ignore teaching. You might not get 100% attendance, but in exams everybody comes. Why? Because they want a degree. So can I make my exams so interesting and so good that the students end up learning because or for the exam? So assessment should help and not hinder the learning process of the student. So good set of properties of good assessment. Assessment should be able to test the practical skills. Are they skill level assessments? Then we should test what is actually claimed and not what is easy to assess. I like, okay, this is very easy to assess, there are 100 students, let me just check that. No, your assessments should be very authentic. Manageable by an average student. Don't be very ambitious, because if the assessment is too difficult, most of the students will be put off and they'll never finish the work. So let the assessment be manageable by an average student. It should be an integral process. So do assessments early on time, give them feedback so that they get time to improve for their next assessment and prepare themselves. Assessments should be of all different types, written exams, presentations, report writing, so that each student is good in a different way. Some are good in presentations, some are good in written exams, so everybody gets an equal chance to express themselves throughout the semester. So they should be all inclusive. And your assessment have to be reliable. That is, if I am checking 100 answer copies, then my grading style should be same from copy 1 to copy 100. That is intra-assessor reliability. And inter-assessor reliability is if I have a team of evaluators taking answer copies, then everybody should give the same grade to a similar work. So these are essential properties for a good assessment. Then assessment methods, as we say, have to be inclusive. They can be a variety of types. You can have small quizzes, take-home assignments, group projects, self-reading, that is read up a paper, come and give a presentation. So this gives them self-reflection time as to how much they understand the course. Then peer review component also comes into picture, very important. So if I ask them to write down notes about a particular topic, then those notes are put online, and I ask students from their own class, you go and read up that and give your own marks out of 10 to what your friends have written. So this again gives them how other students are writing, how can I evaluate and so on. So peer review aspect comes into that. And finally our midterm and end-term exams. Well, now going to the questions, or exam question designs. First, a quick recap of Bloom's level, 1 to 6 and so on. So we can set question papers at different levels of the Bloom's taxonomy. Exam questions can be generally from level 1 to 4. 5 and 6 are difficult for time-bound exams, so we can move them to course projects, lab assignments and open book exams. So next 2 slides, I've just put some questions from existing papers which I found on the internet about the COA course. Some questions were list various pipeline hazards, what is a virtual memory, give the tag bits given this addressing style. So these are level 1 or level 2 questions. So if you have already a question bank and you want to improve it, you take up a question and then enhance the level. So the first question of listing the different pipeline hazards can be changed to give an example illustrating an hazard, or draw the pipeline design which shows data forwarding or something like that, where the design aspect comes into picture. Instead of asking what is or define virtual memory, you give them a page table, page size and frame size things, and ask them to give a sample page table mapping. Instead of just asking the tag bits which are there for a given cache configuration, you ask that if I change this from a direct map cache to a set associative to a fully associative cache, what changes in the number of tag bits? So eventually they end up calculating the tag bits, and the concept of associativity is also checked in such type of questions. The other popular questions are define spatial and temporal locality in a cache, or what is the role of a memory address register or a memory data register, and so on. Again, level 1 questions, we can change them to the spatial locality question. You can pose that, you give ask the student to write a small C code snippet and say that in this code snippet, what is the aspect which exploits spatial locality and which part of your code will exploit the temporal locality. For the last question, MAR and MDR, give us again a set of small code snippet in assembly language and ask them at the end of this execution what will be the contents of one of these registers. So they need to know what MAR is before they can answer this question. So this boosts up the level of the question. So given a question bank, we can go through such an exercise and improve the type of questions. Next I will go topic wise, discussing how good questions we can make on a given topic. So these topics I have gone through using the course outcomes defined by AICTE. Not the, of course, benchmark course outcome, but we have some milestones which we can use. Okay, so the first one was designing combinational and sequential circuits for digital components. Simple questions: can we draw gate level diagram for the flip-flop, or use K-map based reductions to do the design small basic counters, and so on. So these are simple questions of level 1, 2 and 3. For higher level questions, you can ask reverse engineering type of questions, give a big circuit design and ask what the circuit does. Ask them to redraw the timing diagram. So for example, this is a circuit with 4 flops and some combinational gate in the middle, and you say that if the initial flip-flops are initialized to all zeros, at the end of 8 clock cycles or derive the counting sequence. So to answer this question, they need to first know how a JK flip-flop works, they need to know whether this is a positive edge triggered or the negative edge triggered, and the concept of clocking, every clock cycle what happens. So many concepts go into finding out this, and in one question we can test various skills of the student. A similar question, give another design, give an input sequence and say if this input sequence is given at every clock tick, draw the timing diagram of the output. So at up to 8 clock cycles, draw the timing diagram. Again, many concepts can be evaluated with such type of questions. Another type of question is you give a design and ask that if I want to use this design for a particular task, how do I go about controlling the circuit? This is a picture of a 4-bit universal shift register which has parallel in, parallel out, serial in, serial out. So left serial in, left serial out, right serial in, right serial out, and S1 and S0 are my control signals. So the control signals definition is given in the question paper, that if it is 0, that is hold, shift right, shift left and parallel load. And the question I pose is, if I want to use the circuit to do a multiply by 2 operation, then you give me a sequence of all these control signals and what inputs do I give on all the Q0 or Q3 so that I can execute a multiply by 2 operation. So in this, the students end up understanding what happens at every clock tick, how does the data move, and so on. Yeah, so such type of questions, you ask a complicated operation, how you can perform on a given design. Another one is deriving the clock frequency for a given circuit. We generally ask questions, what is setup time, what is hold time, what is important, and so on. So some simple questions. So instead of that, you give the propagation delay, setup and hold times of various gates as part of the question, and then give a circuit design and ask them what is the maximum frequency at which this circuit will work. So for that, they need to first compute the critical path concept comes into picture, that the critical path goes from the flip-flop B to the XOR to the OR and to the F, and when does the setup hold, in which part I have to use the setup, which flops hold time will be required, and so on. So several concepts can be tested in such questions. So that was combinational. I'll just skip this. Yeah, we'll go to the designing memory units. Again, popular questions or simple questions are define the hierarchy, find the tag index bits, advantages and disadvantages of set associative versus fully associative, list the replacement policies. So instead of that, we can move on to more high level questions asking for the average memory access time, what are the hit rates and miss rates. Then given an address, ask them where this address will fit in the given cache specification, or analyzing a given replacement policy. An example, so this gives a cache organization with different access times. So apart from the organization, the cache hit time, the memory access latency, everything is given. And we ask them to, the first simple question, divide into tag index and word, ask them to compute the overhead of the cache. So for computing the overhead, they need to know how much metadata has to be stored compared to the capacity, and then compute the cache overhead. And the third question is average memory access time, given that hit rate is 95%. So in these three questions, by default, they end up understanding what data or metadata has to be stored, and so on. The other question is computing the hit rate. Suppose this cache is a direct map cache versus if it is a fully associative cache, given these number of capacity, conflict and compulsory misses, what will be the hit rate there and hit rate in the second scenario. For this, they need to know what is a capacity miss. So instead of asking define capacity miss or define a conflict miss, I am utilizing this concept, all three concepts in one question, and again moving them to the associativity concept from a direct map cache to a fully associative cache. What would change? Or rather, how would the hit rate change if I change the cache type? Another question, again, give a cache organization. Don't ask how many tag bits, don't ask the block offset. You give an address. Suppose I want to load this address, tell me the set number and number where you load it, and along with this address, what are the other addresses which I am going to bring. So they need to know whether 8 bytes will come with this, whether this is the top byte, whether this is a middle byte, and all that calculations they end up doing when they solve this type of questions. Then the questions related to DRAM memory organization. So this is again a topic needs to be explained quite well to the students, because just giving a design, I have noticed that they don't get the idea. So DRAM memory capacity is given. You ask them to draw a full block level diagram, the row buffer, the column buffer, all those things. A very good question which can be asked here is asking them to give the number of pins for this particular DRAM IC. So this ends up, because some pins are multiplexed, and that concept would come out if I ask them how many pins will be there for your IC. And we generally get a variety of answers. Half of the students give too many pins for a given IC, whereas half of the class was able to compute the correct number of pins. And the question number C is, given this particular design of a 4 megabyte DRAM, if I want to construct a 16 MB, then you give a block diagram as to how you will club 4 such chips to give you 16 MB memory. This one is related to cache replacement policies. So this Intel 80486 uses a replacement policy which is decided by this decision tree. It uses 3 bits of information. If B0 is 0, then the LRU is either from L0 or L1, that is the way 0 or way 1. If B0 is 1, then the LRU is from 2 or 3. Then it comes here, then it checks B1 and so on. So this is how a LRU is decided by this processor. So the question here is, if this is the algorithm, when the cache is accessed, how would you set the B0, B1 bits so that the particular or exact LRU can be decided? So they need to again think what the concept of LRU is, and then every access should make that particular way as the most recently used, and then equally update the others. So again, thought process is required. Instead of simply asking what is LRU, give a real life scenario where they can really see, oh yes, this processor is implementing, so what I am studying is really important from the real world perspective. The other two are describing architectures and evaluating the performance of pipelined architectures. Simple questions are describe the Flynn's taxonomy, what is VLIW processor, SIMD architectures, water control hazards and data hazards. The other more better questions we can design include asking them to give examples of hazard, or given an assembly snippet, find out the hazards and or the number of stall cycles required to execute a given snippet. I'll go to the second one, where you give an assembly language program and ask them, check if a stall is required to execute this instruction, and accordingly then draw the pipeline diagram. So instead of asking draw the 5-stage pipeline, here they end up drawing it themselves, because they need to know when would R1 be ready to be used by this instruction and so on. So they will insert appropriate number of stalls and then draw the pipeline diagram. Another good question is, give a code snippet and say that if I want to fill the branch delay slot, so this is a branch instruction, and before the branch is resolved, another instruction would come in, or it would be replaced by a no op instruction. So ask them to reorder some of these instructions and fill one extra instruction below this. So in this particular example, it turns out to be this instruction which fills in the branch delay slot. So the concept of a delay introduced by a branch, the concept of data dependencies, all these are getting checked in this code snippet. Okay. Then again, in a 5-stage pipeline, you ask them to write a code snippet such that data dependency hazard cannot be resolved by forwarding. So forwarding is a solution. You give me an example where forwarding will not work. So then they end up thinking forwarding is possible from this stage to that previous stage, from that stage to a stage behind that, and what instruction would not be possible with these forwardings. And then we ask them for an explanation just in case they peep somewhere and copy. Okay. So this is a load instruction is the one which would not be solved using only data forwarding, and then they need to give an explanation as to why it will not be. So load's answer is ready in the 5th stage, whereas any other instruction would need the answer in the execute stage, and you need at least 3 cycles before the reader, after the writer has finished the work. Another similar type of question is, give a code snippet and ask that if I want to execute this in minimal time, so this checks their performance derivation skills, you can reorder the instructions, one option, and along with reordering, can you insert minimal number of stalls. So reorder the instructions and add no op instructions, that is stalls, as less as possible. So I have also written the answer here. So they need to reorder one of these instructions, and the model answer would have exactly 2 stalls and so on. Right. So these were up to level 4, 5. To go to Bloom's level 6, which is create or design questions, as we discussed. These could be part of open book exams or homework assignments. However, if your exams are flexible or you can afford 20, 30, 20, 25 minutes for one question, then we can give some design type of questions in exams also. So I have given 2 sample questions of higher level. One is, this is a small C program, not a very good implementation, but it finds out the difference between 2 numbers A and B. And it just checks if A is not equal to B. If this is greater, reduce that number and increment my X. So X is my answer, which is the difference. So given this C program, the question is draw the ASM, that is algorithmic state machine chart, to implement this. So this gives them a confidence that given a C program, I can now synthesize circuits. So they need to draw the ASM chart, and you need to give, of course, some assumptions that an external input signal S, which is a start signal, will come. When this start signal comes, you assume that A and B get loaded into registers, then do the operation, and then the circuit has to give a done signal out with the answer stored in the register X. Okay? So that ASM chart they will draw. And then do they really understand the concept of registers and so on, we would ask them to draw a block diagram of the data path. Controller is not asked as part of this question, because if we ask the controller design, it is difficult to evaluate because everybody would have a different ASM chart, and it was very time consuming to check such questions. Evaluating ASM charts is simple. Checking the block diagram of data path is also okay. But if you want to check the controller design skills, then you can give a subsequent question with a ready-made ASM chart from another example. Give that ASM chart and say, given this ASM chart, design the controller. So your job of evaluating the 2 concepts is distributed across 2 questions, and also manageable and less error prone, because there will be otherwise reliability issue across 2 students and so on. The other question is, this is about a robot maneuvering on a tabletop. Very interesting question, students really love this. I have this tabletop and I have put a robot on it, and you have to design the controller which sits on the robot, which helps it to move. So the robot takes instructions M for move, L for a left turn, which turns it by 90 degrees, and R for a right turn, which turns it by 90 degrees right, and all these come from a remote control. So you assume these signals reach, so there's no concept of sensors and all at this level, of course, but we assume that the circuit gets these instructions M, L and R, and we expect that when a move comes, depending on its current direction, it will move. So the robot is initially positioned in one corner, and the output of the circuit is the current location of the robot with its facing direction. So the current location is origin 0, 0, and it is facing north. So given this location, now all these instructions will come from a remote, and the robot has to move. Then we need to also give the dimensions. Every move will move it 1 unit forward, so it's not analog but a digital movement. It goes 1 unit and then stops, and at a given point of time, so the dimensions are say 5 by 5, so it can go 5 steps in each direction. Another point of caution to be given is that the robot never falls off the table. So if it is at a corner and it receives a M command to move ahead, and if that ends up pulling it off the table, then the robot is not supposed to move. So that's a security aspect. So all these are there. The student would need 15-20 minutes to figure out what solution is, and then simply ask the ASM chart. Don't make them do the controller design. Draw the ASM chart for the maneuvering, and the block diagram for the data path can be asked. So this question takes for a good student 20 minutes and or 35 minutes who struggle. Some might not, reading the question itself they give up. So a debatable thing, but they get a confidence after doing this that yes, this course I can do such fancy designs. So to summarize, the exam questions can be set at different levels. So you definitely should have L1 and L2 type questions, have some middle level questions, and for higher level questions, if you can afford in the exams, or move it to course projects and assignments. So that was about designing questions. Then a quick set of architectural educational tools. So this is a WinDLX tool, which is online HTML utility. So students can put their, these are 5 types of instructions. You can also say how many execution time cycles does add take, how much multiply takes. So these can be configured, and then you decide an instruction with a set of registers will come here, F1 to F16 or whatever. So you encode an instruction, say add instruction, it gets inserted here, and the tool shows you correctly with a given data forwarding mechanism how many stalls will be inserted. So with this you can ask the students to practice pipeline processes. Another simulator is the CPU sim, which is a Java application based utility. Here students can write an assembly language program and they can see the register contents, the memory contents and so on these other 2 panes and see how the program executes. Two small screenshots I've given, and this is a complete list which is quite useful. So CPU sim I've already shown, so that's the website to obtain the tool. This is a very old but very cute tool which I like, Little Man Computer. However, not many people use it these days. Then computer educational tools are again available on this website. And this is a good paper which gives you a survey and evaluation of all these teaching tools for architecture. This list is more advanced, which has more research oriented features also apart from teaching features. The Wisconsin's website on computer architecture has several lists of tools from interconnect design to processor design. Simple Scaler and Multi2Sim are very easy tools which we can bring to advanced elective level courses in the curriculum. So Simple Scaler, not only similar to the WinDLX, it tells you how the system works, but it also gives you a virtual computer system. You can modify the type of caches, whether you have a blocking cache or a non-blocking cache. Do you want in order or processors, and then do performance visualization. So students can change all these different parameters and find out or evaluate across these 2 designs which design is better in what aspects. And Multi2Sim is also similar. Here it's a multi-core setup also you can do. You can also do GPUs combined with CPUs and so on. So very interesting exercise for the students to try out. And these are some more simulators. This is a multi-core simulator. This is a memory simulator. You want to simulate the memory hierarchy for different cache designs, different associativities and so on. So, and these also come with inbuilt cache coherence protocol, that is the MESI or the MOSI protocol. If students wish to do some changes to that, they can do coding inside the simulator to check. So this is for advanced courses or research level students which use these tools. This is a tool available online from HP Labs, where students can try out the hit time, how much is the hit time for a given cache configuration at a given technology node. So if you change from 32 nanometers to 90 nanometers to 180 micro and so on, so how would same cache capacity, how does the access time change, how does the read and write energy change and so on. So those things they can try out using these tools. If students are interested in on-chip interconnects, then NoxSim is a very good tool. Then power, area and timing analysis, and for temperature modeling, these are some tools. Of course, these we don't use during a normal second year level course, but students, final year students or research students can surely use them. Okay. Moving on to how to conduct lab assessment, because theory, then assignment level, and now lab is actual hands-on. So lab sessions with a large number of students, of course you need a good population of teaching assistants, because it being a hands-on lab, students do need help, so you need good workforce with you to go to every table and find out what students are doing. And so generally what I follow is that every lab session will be evaluated, otherwise students are not so sincere about finishing the assignment. So you have a 3-credit lab, you are supposed to spend 3 hours in the lab, come to the lab and do this experiment for the next 3 hours. End of the 3 hours we will give you some marks about finishing, but it is not an exam type because the students can ask doubts and we do and help them. So the marks are whether they finished it, how much sincerely they did that work and so on. The assignments designed are doable by an average student, so not very ambitious goals, but an average student should be able to do. However, there are very good students who finish the work in say 2 hours out of 3-hour lab session. So what should these students do? So I always go with a question bank of bonus questions and I say that you have 1 more hour, you finish this extra work and get 5 marks more. So this happened over 2 weeks, and the 3rd week I found that before the lab, in the lunch break, students were coming and coming to the hardware lab and doing something. So what are you doing? Ma'am, we are checking our ICs, we are checking the VCC ground connections just in case any problem comes, because we want the bonus question today. Because we did not get bonus last 2 weeks and our group wants to attempt the bonus question, so we are doing the background work. So which was, I was really happy that they are now keen to try out or gain more marks. Then evaluation is of course daily. Then 2 practical exam, because daily it happens in a group and you don't know every student whether everybody is contributing equally. So a practical exam, and then report writing. So report writing about the design, and then what ICs and how did they select an IC, because we don't give that you have to use these ICs. You give a problem statement and a chart of the available ICs. They have to select which IC they have to use, which is appropriate, get it verified from us, because otherwise they would end up doing a wrong design. So the first milestone is you decide ICs, come and check with the TA, and then move on with the work. So report writing, and this checks the other skills. How can they demonstrate? Can they explain what they've done? How they work with a team and so on. So these other skills can be tested during this. And we can of course offer extra lab sessions to weaker students to give them an opportunity to learn. I won't go into details, just some list of lab sample experiments. You can give them a first 2-bit adder, which itself is a big circuit to begin with. Once they have a confidence of this, then you ask them to design a 4-bit triple carry adder. Ask them to do a 2-bit ALU. If they are confident and they finish it, as bonus, ask them to extend this to a 3-bit ALU, which becomes very clumsy on a breadboard. And subsequently, you can ask them to design a 4-bit or a 8-bit ALU using Verilog or VHDL and demonstrate it on a FPGA kit. So they get a feel of both using ICs and wires as well as HDL. Similar questions can be there for sequential design, multiplier design, simple one on the breadboards, and Booth's multiplier can be asked to be synthesized using FPGAs and counters and so on. If there is time, we can ask them to design not a full processor, but in a pipeline processor we have these stages: fetch, execute, decode and write back. So those can be split across 2-3 weeks, and say that in the first week we are just going to load a RAM with some data and you should be able to read a random address. So this exercise was very useful. They understand the concept of write enable, read enable of a RAM, how should the clock be given to the RAM. When the data comes, your clock should reach at the correct locations at the correct time for the data to be latched, and so on. So the fetch stage can be mimicked by such an experiment. For execute, you can say that you preload the RAM with so you preload the RAM with the first address having the value of A, second address having the value of B, and then you fetch the RAM, which you've already done in your first week experiment. Use a ready-made ALU. You already know how to design ALU in your previous week's labs. Today you use a ready-made ALU, do the addition, and the answer you sent back to the RAM. So this is how they can do a read, execute and write of the RAM. Eventually, if students are interested and you get a good team, you can ask them to automate this, all these stages together, incorporating an address bus and a data bus. Well, so to conclude, So distribution of questions across the levels are suggested by various research papers. Some say you should have 20% low level, this much intermediate, that much high. Some say 22 low, this much high, and so on. So there is variety of opinions on the levels of questions available. So it's I would say it's a more guideline given. So distribution of marks and would also depend on the level of study, that is which year this course is being offered, and whether the module is analytical or theoretical will also decide a type of question, whether it goes in a low level or a high level question. So Bloom's taxonomy only serves as a guideline to a faculty, but largely it is left to us to balance out our question papers to get the best outcome and to help students learn. So happy teaching. Thank you so much.
Thank you. Are there any questions? Yeah.
Ma'am, I joined a little late, for your talk, and basically I am from the industry, both in hardware and software. Hello. Yeah, a couple of questions. One is how much students refer the data sheets of the various devices they use, and do they do all the computations with respect to right stream, false stream, the logical levels, so that their designs are robust? Because many a time we can show results, but then if I increase the temperature or decrease the temperature, the results will all go off because of they are not taking the design margins. So do you do that sort of evaluation, whether they have done a very thorough design? And then and the next question is, do they also use some small logical analyzers to show you that all these things are
no.
Okay.
Because logic analyzers are generally not covered in the computer science department,
right.
And as such, to help them understand the effect of temperature on this,
okay.
They need to know the electronics behind that. So if the
right.
instructor is capable enough, yes, possible.
Yeah.
But beyond the point, even I have my limitations that I cannot explain. But related to your temperature and other questions, the
right.
cacti tool which I displayed, that has all these things. You give an technology node, ambient temperature,
okay.
and a cache. It gives you at this temperature, this is the access time.
Okay.
At that, this much it changes. And the other thermal model tools which I said,
okay.
those are also useful.
So
for
that means
modeling.
other than wiring circuits on a breadboard or implementing in FPGA, you also do simulator based,
Yeah, you can give. Of course, these are very high level simulators and may not fit in the course content.
Okay.
But if the students are interested, you can give them offline projects. For example, after this course, I have 2 students who are very interested, so they are exploring all these, are understanding.
Yeah. Students coming out from the universities to industry, they have a big problem with realizing practical circuits, which can work under various conditions.
Yeah, but I would say the problems you are saying are not generally faced by the computer science graduates, but definitely I have no experience of the EE people drawbacks.
Sure. Okay, thanks. It was a great presentation.
Thank you.
Hi. You showed us a good set of questions, but can you tell us a little more about how did you come up with those set of questions? Right, as you rightly pointed out, Bloom's taxonomy is a starting point, but it is very broad. So from Bloom's taxonomy, how can you come up with those such questions for given course outcomes?
Well, of course, the first answer is experience. The second answer is Google. And the third answer is the variety of textbooks. So you can explore. There are many textbooks in digital design, and some of them do have these type of questions. So 1 or 2 I have definitely picked up from the exercises from textbooks. So the more books you explore, you would find these type of questions.
Thank you.
Hi, I'm Prajesh from IIT Bombay. So I just wanted to know, like, can you give examples of how you make the class interactive? So you said that the class has to be interactive because there are a lot of dry topics which students have to learn. So if you could give some examples of how you are making the class.
Okay, so I have to give an example. One I gave about the flip-flop design. I ask them that you have to design a flip-flop, just a storage element. So I give them how will you store data on any electronic device. So some will say, I will store it on a wire. Answers start from there. And then I'll say, okay, let me store, where is the data, how do I read it, will it stay on the wire? Then, no, what do we do? Then they will come up. So I make them do the design. I give them hints in the middle. Okay, now you put an inverter, but the output has reversed. So class coupled inverter will give the feedback and store. Now what is the next? I cannot insert a new value. Whatever value I've put in, that will stay there forever as long as it is powered on. So you have to cut it and put a switch. Then they come up with this. Then they, okay, this switch is required. Then I will close this once, open that, and so on. Then you go to the SR latch. So after the SR latch, you connect two SR latches and show them that if I have to use this at a given clock frequency, when a clock comes, this will load the data, and that will also load the data. So I will not have a data transfer from this cell to that cell. So this cell to that cell should happen provided you are sitting in this room and that door is closed. So you have to close that door when you open this door, and then you leave it to them. Then they will come up. Then we can, ma'am, we can invert the clock for the second box. So these are answers, it comes from the students. So you ask them to do the design, tell drawbacks in their design, and then give them small hints so they come up with their own design. So this has happened. So it's very interesting to have all this. And similar things I do with pipeline design and now recently in the cache coherence protocols and so on.
Okay, we should move on. We thank Himangi again.
I would like to request Professor Venkatesh Raman to please present a memento to Ms. Professor Himangi Kapoor.
Okay, our next speaker is Professor Jayant Haritsa from Indian Institute of Science, Bangalore. Over a two-part series, he is going to talk about database systems, access, design, and internals.
Is this audible? Yeah. Okay. So good morning. I am Jayant Haritsa from the Indian Institute of Science, and I have been teaching the database courses there for close to 3 decades. Unlike IIT Bombay, where they have a surfeit of riches with regard to the size of the database group, in IISc the students have no choice. They just have to take my course. Okay, so they have all suffered through this for several decades. So what I'll be presenting today is basically my own observations that I would like to share with you thanks to this long stint of teaching the database course. And it is quite likely that your mileage may vary, and also that very little, if any, would resonate with you, in which case you have a good opportunity in the session to catch up on your email and your WhatsApp messages. Right? Now, Himangi had clearly done a lot of homework, and I was feeling embarrassed when I was sitting there saying, I haven't looked at the AICTE syllabus, and I have never even heard of Bloom's levels from 1 to 6. I only know Giant's levels 1 to 6. So the questions, I didn't know of this. So please pardon me for not having done this work, and I'll try to give you at a more intuitive level whatever I have imbibed over the course of this teaching stint. So my claim is that it's very important that we teach students in the metaphors that they are used to. Not in terms of the dry books that we usually have and say that go and look up this chapter or read this section and so on. But please, it's important for us to remember that all of us remember the dialogues from Sholay, right? At least those who are born in the previous millennium here would remember those. Okay? We remember jokes, we remember songs, we remember movie dialogues, and we remember emotional experiences. Okay? Very rarely do we remember the textbook. Okay? So given this, if we are able to communicate the information that we had, which is serious technical information, but through this metaphor or this vehicle of analogies which are sourced from contemporary politics or entertainment or sports, you will find that there is a much longer period, there's a period of that the students will essentially imbibe this and remember this for a long time. Okay? So, and what I'll try to do is to try to convey to you that not only database systems, but computer science in general can be effectively taught through these analogies with the real world. And I'll do that through a proof by example, and I'll show you a couple of situations related to database schema design, database transactions, and privacy preserving data mining to cover the spectrum of different possibilities that are there, and to show you how there are real world analogies that usually resonate with the students and which they remember for a long time. Okay, so let's just start with schema design, and we usually, this is with regard to relational databases where you have to design the tables, and we often say that, look, there are data types which have long information in them, and therefore if you duplicate this information, you will have a problem with regard to space as well as with update anomalies and so on. Okay? That's what we technically say, that's the motivation for having integer primary keys as well as normalization. But people usually don't relate to the fact that you can have really long names. And what I usually do is that because since cricket is the religion within the country nowadays, is that I use a lot of cricket examples. Okay? And you can see that, for example, here, this is the famous Chaminda Vaas, whom you would have seen in many of the matches. But actually, his name is much longer. It's Varnakula Surya, Upashante, Patabendige, Chaminda, Joseph Vaas. Okay, I've done this many times, so I can say it off the top of my head. This is 52 characters long. And in fact, he holds the record for the longest name, the player with the longest name ever to have played international cricket. And students not only remember this, they also remember jokes. There's a very interesting joke on the web which says Chaminda Vaas versus James Bond. Okay, everybody loves James Bond. So James Bond and this Chaminda Vaas are sitting next to each other in the same flight, and then Sri Lankans, are extremely polite. So he says that, hello, may I know your good name, please, and so on. And James Bond responds as usual, I'm Bond, James Bond, right? And does that. And then James Bond, trying to be polite for an Englishman, says, and what about you? Okay. And what Chaminda, I am Vaas, Chaminda Vaas, and he keeps going on like this, okay? So in this case, actually, James Bond has to accept defeat and collapses with this. So you might think that, well, these were the longest names and these are actually pathological cases, but that's not really true. There are much longer names, and these are all living cricketers who many of you would recognize here. This is Chanaka Velagedera, Rangana Herath, whom many of you would, was in the Sri Lankan cricket team. Prasanna Jayawardene, this is their actual complete length of their names. Here is Rajita Amunagoma, 104 letters in the name. Okay? And this is my favorite. Okay? This is not made up. This comes from a cricketer in the Fiji Islands. Okay? Once you start here, you have to take a deep breath because you will run out in the middle. Okay? This actually means that this person returned alive from the Nakula hospital at the Lakemba Island in the Lao group of the Fiji Islands. Okay? So they're recording the fact that you actually survived a doctor, which is fairly difficult. And these are real cricketers. You'll find this in Cricinfo and other places. So this forms something that they can relate to and remember for a long time. Okay, now let's move on to something which is more interesting. That is this notion of transactions, which is the USP of all database systems. And the way that we normally teach it is to say that transactions are the fundamental unit of database processing. And they basically allow you to do transfer of money from one account to another, to make your airline or hotel or train reservations and so on. Okay? And typically we show a sample transaction like the one that we see here, which is reduced to its read and write operations because that is primarily what affects the database state. And we say that, oh, if I wanted to transfer 500 rupees from the student's account to the instructor's account, then this is the way that you would specify it to the database system. And here are the various read and write operations. You take the money from A, subtract 500 from it, then you go and add this 500 to B's account. And after the transaction is completed, these operations, you do this notion of transaction commit to make sure that these changes are essentially entered into the database system. Okay? So transactions are justly renowned for the fact that they provide what are called as this ACID properties, that's ACID. A is for atomicity, which means that it's all or nothing execution. So the kind of metaphor that you give is that the transaction either completely executes or doesn't execute at all. Then there's consistency, which says, is this a correct program with regard to the database contents? Then isolation basically says that while you're doing these various operations, although in principle you're taking infinitesimal time, it actually is going to be done over a long period of or duration. And what you would like to ensure is that any of the updates that you made to the database during this process are invincible until it's completely finished. Okay, this is the isolation part. And finally, what durability means is that whatever has been changed in the database remains like that irrespective of any subsequent system failures. Okay? So I'm giving you just a very quick summary of these various properties. And you can look up again the textbooks for the fine technical details. But this is the high level view of a database transaction. And this is why we also say, if you will pardon the chemistry joke, that acid is basic to database systems. Okay? So this is the foundation as to why database systems are so ubiquitously popular and why they cost so much, is because they give you these properties in an efficient manner. Okay, so now let's see, can you see this in the Bollywood movies? Because my claim is that everything was invented in our Bollywood movies. Currently, politicians like to say it was done in Vedic times. I don't think that's true. It's mostly has been done in the last 50 years. And any concept in computer science that you want is already there in Hindi movies. Okay? So let's see whether we can prove that claim with regard to transactions, which seem fairly distant from this the world of Bollywood. So let's assume that you have this usual situation that these gangsters, usually they're called as Ajit and Robert. I don't know why they're always those names. And they're also not pronounced as Robert, but Robert, right? Ajit and Robert have captured Mona. And Mona is the apple of Kishan's eye. Kishan is a good chap who's been a nice Siddha Sada fellow. But after dancing around so many trees, maybe his eyesight isn't all that good, but still Mona looks fairly attractive to him. Okay, after this, what happens is that in order to release Mona, usually the gangsters will demand Kishan that you please hand over a ransom of B slak, right? Because they know that Kishan is a software engineer, and nowadays the rates are much higher, and he has .com expertise. You have to have a minimum level of ransom in order to justify this particular capture that they made. Okay? And then let's look at what happens in the next step. Usually all these things happen on the Chowpatty beach. I don't know why. There's a kind of a standard location where all these transfers are done. Kishan is told to show up at the Chowpatty beach at Theek 12 baje. Okay, for the exchange, failing which Mona will be deposited in a very interesting scientific experiment called Ajit's patented liquid oxygen torture cell. So those of you who are not familiar with these advances in science, liquid oxygen is essentially that the liquid prevents you from living, and the oxygen ensures that you continue living. So you're essentially in this intermediate stage where you're neither living or dying. Okay? That's what is. As you can see, there is quite some imagination that's required for all of this. Okay, and then finally what happens? Kishan would always have been saving all this money, this B slak, for his mother's heart operation, right? And this is the same mother who would have put him through the MTech at IISc by selling pirated CDs in the Majestic bus stand. And he complies with this. After he's saying the obligatory ma, he says, okay, let's give the 20 lakhs to the kidnappers. Because after all, Ma is going to be there only for a short time. Mona is a much longer proposition. We might as well do this, okay? Right. Okay. So now, given all of these things, can you see the transaction concepts already here? Okay? So firstly, for example, if you look at atomicity, it means that Kishan has either the money or Mona. Okay? It's not that he gives the money and then is unceremoniously killed, because then he doesn't have either of them, or that he gets both of them. The atomicity is that either he has the money with him or he has Mona after the exchange is done. So that's the atomicity principle here, that either everything is done or nothing is done. Okay? Then what about the consistency? Typically what you would do is that if you had to give this kind of money, you would go and take the monopoly sheets and then go and try to substitute it. On the flip side, the kidnappers also would want to substitute Mona with somebody else and give it to you, saying that next time round, this is the trial run, next time around I'll give you the real Mona, pass another 20 lakhs instead, right? So it's important, the consistency here of the program is that neither the money should be fake nor Mona should be fake. Then what about isolation? We are always having these sting operations where somebody is watching you while you're doing all these various cases. If you hide either Mona or the Mal at the end of the transaction, then you would be fine, saying just I'm taking a walk on the Chowpatty beach with Mona, or I just like to carry around 20 lakhs in my suitcase because it's good for my health down this beach. But they will not see the intermediate operations where you're doing exchange of Mona for the money. Right? So there is no observation here. And then the durability is that what would any self-respecting kidnapper do? That the moment he gets the money and starts walking off with Mona, he'll shoot Kishan in the back and say, let me take Mona as well again, right? But the important thing here is that Kishan and Mona should walk off into the sunset and live happily ever after. Of course, by now Ma is gone because that's usual is required in the movies. Okay? But these are the various kinds of basic semantic concepts that you can already find existing in the movies. Okay? And you will see even, for example, with regard to isolation, you'll always see that the police jeeps will come in and they will swing like this and slide on the sand and so on, but they always come after it's over. You have never seen a police jeep come in the middle of the transaction, right? Either it's before or after, but never there. Okay? No. So that's what you have here. So in just this movie segment, the basic concepts of database transactions can be understood. Okay? Of course, they are missing many of the technical details and so on, but at least 20 years later, somebody suddenly asks you what happens to transactions, at least hopefully you'll remember Mona and Kishan, if not these various properties here. Right? Okay. Okay. So that was with regard to transactions. Now I'll switch gears to something which is in the middleware, which is data mining, and in particular, a topic called privacy preserving data mining. And the issue here is that often when you are asked for information like, on various web portals, they ask you your name, your gender, your age, and so on, and you're always wondering why they're asking this information. And that's because they are trying to find these patterns where they want to correlate various kinds of demographics, let's say age or gender, with the kinds of things that you are purchasing. Right? And the good thing is that because of this, they can provide you with better service because they know what are their kinds of customers. But often you are worried that if you are trying to subscribe to websites that you don't want your parents to know about, then you would be worried about giving the actual correct information. And typically what we do is that we submit garbage information. We pretend that we are our 80-year-old grandmother. We are downloading rock music or the current mashups and so on. But what we will pretend to do is to say that we are a much older person and have nothing to do with the person actually getting this information. So the difficulty here is that you are submitting in garbage to the data mining tool, and of course the models that will come out from that will also be garbage because they are based on false information. So one of the important things that people have been looking at is that how do you ensure that these models of data, which is what data mining tries to do, which is globally accurate, but is locally private. So the raw atomic data is private, but the overall models themselves, which are statistical summaries of the data that you have, they are accurate. This is what you would like to have, globally accurate, but locally private. But the difficulty is that these are adversarial models in the sense that if you try to increase data privacy, the accuracy of the model goes down and vice versa and so on. Okay? So there's a large body of work over the last 2 decades where people have tried to reconcile these two conflicting objectives and say that how do I simultaneously get privacy for your personal data, but at the same time ensure that you get accurate global statistical models. Okay. So the usual idea that people use here is to say that let me take the user data, apply a distortion procedure here. This is usually a mathematical procedure. Essentially you take a matrix and apply it on the data that you have here. That matrix is the distortion matrix, and you come up with distorted data here. Then you supply the distorted data to a mining algorithm, and then you can do an inverse of this matrix operation which finally results in accurate models. The key difference here is that here you're doing data distortion, here you're doing distribution reconstruction. Okay? So here you're getting statistical truths, here you're getting individual information. That is the difference in what you're doing between this step here, which is the forward step, and the reverse step. The forward step is hiding your data, the reverse step is reproducing the population distribution. So for example, we'll know that in a group of people, let's say that 10% of people have seen the Badla movie in the students group, but I don't know exactly which one of them had done it. I can tell you something about the entire class, but I cannot tell you whether a particular student in the class had gone to the movie or not. Okay, okay. So the usual way that we do this to find out these kind of correlations between various columns in the database is to form what are called as association rules. And basically what it does is that it takes this the entire information that you have in your database, which is in with the column names in this case corresponding to a supermarket, where the supermarket is selling things like coffee, sugar, milk, and bread. These are the columns here. And then there are customers here who are either buying this item or not buying the item. So customer 1, for example, bought coffee, didn't buy sugar, bought milk, didn't buy bread, and so on. Again, I'm not going through the full technical details. You can read it up later. I'm just giving you a high-level view of what is being done here. And subsequently, your goal is that you want to find all rules of this kind, which are statistical implications, and do this in an efficient process. Okay? So now the key is that, what does this actually mean in practice? We'll view the database as a large matrix of zeros and ones. Zeros means you didn't buy it, and ones means you bought it from the supermarket. And usually these will be sparse matrices, because you don't go to the supermarket and say, give me everything that you have, unless you're Mukesh Ambani, but the rest of us will say, just give me a few cigarettes here and things like this, right? Okay, so what do? You independently flip some of the entries in each row of the matrix. That is, you flip a 1 to a 0, saying that you had bought something, but you change it to a not bought, and vice versa, with some probability p here. Okay? And here is an example of this in action. This is the original customer tuple. This happens to be something that Linus Torvald was the transaction that he did at the supermarket in Scandinavia. And you can see that being a hacker has to have buying chips, doesn't have diabetes as yet. Diet Coke is another requirement for hackers. And here is the horror of horrors, that he has bought Microsoft Windows. Okay? This will mean that Linux will tank tomorrow. Okay? So obviously you would like this to be hidden. So what you can do is that you can go and randomly flip some of these items that you see here. And after you do this flipping, you'll see that this 1011 has now changed to 0110 here. Okay? So the big ticket perception here is that, why do we obtain privacy now by doing this flipping operation? The simple idea here is like this, is that you had a small, within your large matrix, you had a small set of real ones, which is where you had actually done the purchase. But what we are doing is that, because we are flipping some of the false ones, that is those which are zeros, and you are making them into ones, you are essentially hiding the small island of real ones in a large sea of false ones. And how did the false ones come about? They came about because the zeros got flipped into ones, like what we saw in the previous slide, making it difficult to distinguish between a real one and a false one. So they're making it difficult to distinguish between, like, for example, real gold and artificial gold. Okay? For most men, it looks the same at even close distances. So these two look identical to each other, and you are therefore you're able to achieve privacy here. Okay? But what I really wanted to get to is that this is not an idea that has come about in computer science and with PhDs working on this. Okay? What is really amazing is that this idea came from illiterate women in Nagpur in 2004 itself. Okay? This is an absolutely amazing thing. There was a small village where there was a local gangster called Akku Yadav, who used to basically terrorize the local people. Okay? So the populace suffered this for almost a decade. And then the women finally decided, enough is enough, we need to take action ourselves. And they went and collectively killed Akku Yadav. Okay? Now what would usually happen after this is that the police went into an investigation, saying that who is the person who has killed this, and we need to haul them up and things like this. Now normally if the police came and asked you, did you murder Akku Yadav? What would you say? Not me, I wasn't even in town, I was attending ACM Compute in Goa, don't ask me. Yeah? The other person did it. That's the typical reaction any of us would have. But what is remarkable is that this completely illiterate woman came up with a beautiful strategy. Okay? All of them went to the police station, there's about 300 of them or so, and said, I alone killed Akku Yadav. Please arrest me, I am guilty, throw me into jail and do this. Now obviously the police know that most of them are lying, okay? Because there's only a few people who actually did the killing. And they don't even have space to hold all of them in the jail. So the police were completely flummoxed as to what do you do in this case. But exactly the same idea that is there in privacy preserving mining is here. The real killer is being hidden amongst a set of false killers here. There's 300 of them. You know there is a killer here, but you can't identify who it is because every one of them looks exactly the same. And in this particular case, each one of them is saying, I am the true killer, please arrest me, I am guilty, take me and let me give company to Chidambaram in Tihar jail. Okay, do that, let's. So this is what is being asked for, and what is amazing is that this kind of a very nice strategy was thought about within a village, and as I said, without having any connection to privacy preserving mining, the basic ideas are being used there. Okay, so I thought that because I was given only half an hour for this session, that I'll wind up here for the pedagogy part, and then maybe after the break, those of you who have survived can come back and we can do the assessment part in the second session there. Right? Okay, thanks. Thank you.
Okay, so we will go for a coffee break and come back in about 15 minutes.
A couple of announcements before we disperse. Invited guests that are leaving today are requested to meet Professor Jarrett at reception desk. And the cruise coupons will be sold till 2 p.m. today. Those interested in purchasing the coupons may kindly do so at the registration counter by 2. Everyone. Now, the session chair for this post-tea session is Professor Madhavan Mukund. He is the Deputy Director and Dean of Studies and a professor at the Professor of Computer Science at Chennai Mathematical Institute.
So Jayant gets to be introduced twice. So this is Jayant. It's the same Jayant.
Okay, so welcome back to this session. If you remember earlier Hemangi's talk, she made a very interesting statement. She said that assessment drives learning. And I would beg to differ, violently differ actually, with that statement. I don't think assessment drives learning. It's curiosity which drives learning, because that's the reason we all go to Wikipedia and start looking at various things, including things that happened in ancient history and so on, because that is a curiosity that you have. And in fact, if you look at the current government model, they love this word called, or this acronym called CCE, which is Continuous and Comprehensive Evaluation. I don't think there can be a worse thing that we have ever done in India. Okay? Because that is the surest way of killing creativity in the students. Because if you are always being evaluated, when do you have the time to learn? Okay? So it was actually quite good that organizations like AICTE will soon be history, along with UGC and so on, because they have systematically killed most of the education in this country, where essentially it has become a road running operation. Right? So as you can see, I'm not going to be getting any positions in government after this. Right? But this is the danger that we have, is that we have reduced things to an assembly line process. And once you do that, obviously the outcome will also be people who are not going to be thinking for themselves. So I'll just move, but since we have to do assessment, because like death and taxes, exams are also a part of life. So let's go on to how we should be doing assessments. I have long been a proponent that all exams should be open book and open time. The reason is that why are we training the students? Because they'll be going out to the industry or to academia after that. And when you go to the industry, it's not that Narayan Murthy says, oh, I'll hide the Sudarshan's textbook from here, now you tell me the answer. He says, can you go and figure out this answer or not? So why is it that we put these unnecessary barriers and restrictions on our students, which starts making them mug up just outside of the exam hall, saying a transaction provides atomicity, consistency, isolation, so they're just by-hearting this process. Instead, if you could have given them Sudarshan's textbook and said, now what can you do with it? That would be a much better use of their time, and also in some sense improve their understanding of the concepts and so on. So I have always been going with open book and open time exams, and when we say open time, it's actually seriously open time. We supply them food to the exam hall so that they don't have to starve while doing the exam. They sometimes take 8 hours, 9 hours and so on. We start at 9 in the morning, give them breakfast, and then say those who can survive till lunch, we'll give that to you as well, and so on. Because the idea is that what have you learned? It's not speed. Speed is okay for IPL. But really what you're looking for is that the ability to understand these concepts. And this is again related to something else that has been done a lot, is that everybody loves hackathons. But I always worry that in a way we are degrading our own discipline by saying that a certain important problem can be solved overnight. If it was so simple, then everybody would have done it. Right? So in a way we are bringing down the caliber of these problems by subscribing to the hackathon notion. Notice that the medical doctors, for example, don't do that. If they said that, I will do 200 cardiac surgeries in one day, would you be willing to be one of those people who are doing that, right? So in that sense, I think we are looking for this very quick fix solutions, and education should not be reduced to a sport, which is what we have done right now with these rankings, which is the silliest proposition that we have ever had in this country. Okay? Is that because you cannot put numbers on education, because it's a process of self-transformation. And saying that IIT Bombay is 1 and IISc 2, the other way around is okay, but not the 1 and 2, is the silliest thing, because they all have their strengths and they're all catering to different groups of people. And the key issue to look at is what is the transformation you did on the students, given what they came in with and what they went out with. That is the real metric. Okay, so now that I've got rid of my gripes about Indian education, I would say that what is important to ask is this question, so this doesn't fall into the Bloom layers. Okay? Just ask them hard questions. They would like to be challenged. Questions should be either what if, questions that are designed to test your concepts, or they should be problem solving, which should be designed to test their ability to solve certain practical scenarios. And certainly should never be the rote repetitions of textbook material, because otherwise they can just say that, why don't you Xerox page number 256 of the textbook and take it as an answer? Why do I need to write it again? Right? Now, one of the worries that people have, and especially those of you who are teaching in the undergraduate colleges here, would say that how do I come up with good new questions every year? Okay? That's certainly a problem. So one of the solutions for that, which is a little bit of a cheating, is to say that you give the questions and answers in the same sheet of paper. That is, there's a question and there's a space for the answer and so on, so that they give it back to you. And later you can keep this so that there is no a continuation of the same questions being passed on from one generation to the next, in case you are worried that people will not actually understand the material but will just copy these earlier questions and then mug up the answers and come for it. So you could do something like that. But still, the overall important thing is that why are we hell-bent on saying that books should be banned from the exam hall? All the other time we are telling the students, read the textbooks, and then you say, don't bring it in here. Okay? It's a very peculiar and ironic situation that we have. Okay? So thankfully Hemangi was not there when I cribbed about the assessment drive style learning. Okay, so let's just look at a question like this on one of the most fundamental features of databases which makes it so attractive is this notion of program insulation. But the way that it's being presented is somewhat different, is to say that, well, there are 3 different applications, and these are all real life applications. There's a stipend account scholarship application. There is a mailing application and a hostel bill statistics application. They're all running on this student database management system. And there is a specific physical layout of the student records, which is roll number, name, address, GPA, the scholarship, the hostel, and the mess bill, and so on. Okay? So a typical relational table is like this. And then you might say that either to improve operational efficiency or for Vastu reasons, right? The structure of the student records can be changed, saying that I will put all the numeric fields in the beginning and all the character fields in the end. So things like the GPA and the SR number and the stipend will come in the beginning, the name, the address, and the hostel name and all will come at the end. Okay? This is a perfectly legitimate change to make. And one of the reasons that you might want to do it is also to make sure that the data fields are aligned according to byte boundaries. Okay? That's the operational part. But otherwise, as I said, it's a free world. You're welcome to also do this change because it might give you a better understanding of the contents of the database. And the question that is now being asked is that, given this change that has been made in the underlying file system where you have stored this table, how do each of the above applications have to be altered in order to operate currently within this new format of the data, okay? The new physical format of the data? And the beauty about database systems is that unlike the imperative programming like a C program that you would have written on this data file, if you had written the C program, you would have had a struct which would have listed the fields in the order that they appear. You would have had to change those order of those fields, recompile the program and run it again. In the database system, you don't have to worry about it at all. There are no changes that have to be made because the database system always goes through the metadata, which is the relational catalogs, to figure out where the data is located and in which order, and therefore the applications can run just as before without any changes being made to them. So the second question relates to transaction recovery, which is one of the foundational aspects of database systems. And in this context, let me also give vent to my other pet gripe, is that most people in India are learning applications. That is saying that I have a database system, how do I use it to provide either a hotel reservation system or a hostel management system or a medical hospital operational system and so on. But they really don't have an idea as to what is happening inside the box. Okay? So the analogy I like to give, again following up on the previous session, is that you can either be a driver of a car or you can be a mechanical engineer designing the engine of the car. Most software groups in India are drivers of cars, saying there is a box and I will drive it. Okay? Most of us don't drive very well in India because we don't know which is left and right. But independent of that, this is the primary goal, is to say that there are boxes that we use. But we have never been able to design our own operating system or our own database system with looking at the internals of these boxes. So for example, can I design a Ferrari engine with a turbocharging being there? There is a supercharging, there's a fuel injection, there's variable wall timing and all that. that knowledge is largely missing in the Indian syllabus, because people teach you driving, but not what is inside the or underneath the hood of the car. So hopefully some of the questions that you would be asking them in your class would also explore these aspects of the database systems. So for example, here it says that you have implemented a log-based recovery manager for your company's database system. And this is where the what if part comes in, is that if the rules of the game change, what happens to the design of your system? This is the one, this kind of questions really test your understanding of the concepts, okay, because they give you an unfamiliar situation, which you cannot immediately go to Wikipedia and find the answer, because this situation not been thought about, is not in common parlance. So here what we are saying is that your manager recommends that you just remove this. It's a waste of time, it's such a large piece of software, get rid of it. Okay? And why is she saying that? She's saying that because she has been given a guarantee by the computer vendor that the computer hardware and software will never fail. Okay? That is, that this database system will be permanently operational. So you are creating a hypothetical situation where somebody gives you a guarantee that the database system will always be working perfectly fine without any problems. Given this, do you really require all this huge machinery that you have, because the code inside database systems is millions of lines of code long? Why do you require this heavy-duty recovery manager? Get it out of the system. Now, assuming that this guarantee is valid, how do you respond to the request? And B, would the answer change on whether the database implemented what is called as immediate updates? That is, the changes made by uncommitted transactions may be transferred from the main memory to the disk. That is, dirty data is going from main memory to the hard disk. Or is it implementing deferred updates where only the good data, that is the changes that are valid after a transaction commit, are being transferred from the main memory to the hard disk. Okay? So here the important thing to realize is that system failures are not the only reason that transactions get aborted in database systems. There are many other reasons as well. For example, it may arise due to concurrency control, especially if you're using a locking based mechanism. So if you use two-phase locking, you can often get into deadlock situations where two different transactions are essentially in a cycle because they're asking for competing data items. Then the way to resolve the deadlock is that one of the transactions in the cycle has to be aborted and then restarted again. So you could have an abort which has nothing to do with the hardware system itself, or it could be due to user actions. Okay, so the user is saying that let me transfer 10,000 rupees from myself to the instructor, and then suddenly decides to drop the course. Then he says, why should I waste the money on this instructor? I'll hit the Control-C on a transaction before it gets into flight on the system. So you may also have something like this. And these are being done on a perfectly operational system. Therefore, you would require the recovery manager is still required to undo such aborts in the immediate update case, because some of the changes that you made, the dirty data that was there in the main memory, may have actually reached the hard disk by now. But if there was deferred updates, where you are assured that only after the transaction is committed, any of those changes are migrated from the memory to the disk, then the recovery manager is not really required, because you know that any of the dirty updates do not reach disk prior to transaction commit, and therefore they can be ignored. Okay? So this requires a level of understanding that of the basic concepts, which enables you to figure out exactly what will happen in an alternative scenario that had not been previously considered or is not textbook material. In a similar fashion, it's possible that you might have a situation like this, that your classmate implements an alternative log-based recovery manager, because everybody likes to do different things, saying that I don't like the ones that are already there in database systems, I'll give you this alternative choice instead. Where what we do is that the log records of any data updates are immediately and synchronously flushed before the corresponding updates reach the disk. Okay? So because databases use this logging mechanism to reflect what are the changes you would like to make before you actually make these changes. So these intention records are being flushed to the log disk prior to the updates being made on the data hard disk. And then at the transaction commit time, you first take all the data updates that are still memory resident, write them to the hard disk, and only then write the transaction commit log record. In the typical database systems, this is usually reversed. Okay, you first write the transaction commit log record, and subsequently at some later time, some of the data updates which should have reached disk will do this asynchronously at a later point in time. So that is meant for a performance reason, is why you would do this. But your classmate is saying that I would like to have my own spin on this. Okay, I am Honey Yo-Yo Singh. I like to make songs in a different way from the past. So this is my remix of this old idea, which is there. So now the important question to ask is that does this still retain correctness in the sense that does the classmate system provide recoverability to you? And usually the most students' answer is immediately no, because I don't trust my classmates. They copied from me. So by definition, the answer is no. But if yes, you need to explain the undo and the redo operations that are made during the recovery process to when you get the database back online. You need to correct all the mistakes that were made where either good things that should have gone from the main memory to a disk had not reached there, and therefore you need to re-implement them, or on the converse side, dirty data which should never have reached the disk has already gone there and you need to clean that up. Okay? So this is how the question is structured. And the important thing for them to realize is that we are still using what is called as the write-ahead logging. That is, the intentions are always recorded on stable storage prior to the data updates being migrated to the hard disk or the data disk, and therefore the protocol provides recoverability. So in that sense, we are still okay. And then during the recovery process, okay, since we are talking about recovery, we went into the failure mode right now. Okay, so during recovery, we need to undo these aborted transactions because the system is allowing immediate updates, which means that dirty data of uncommitted transactions, which could potentially be aborted at a later point in time, have already reached the hard disk and are therefore potentially dangerous. But the interesting thing here is that there is no redo required because of the way you have sequenced the operations. All committed transactions are guaranteed to have every one of their updates. So all good updates will have reached the disk before you tell the user the transaction is committed, which is the advantage compared to the previous slide where I showed you, where I said normally you submit the transaction commit log record first and at a later time asynchronously send the data updates to the hard disk. Because of the reversal, now what you have is that there is no undo is required because all the good stuff is guaranteed to have reached the disk prior to the commit transaction being operated. So in short, this is an undo without a redo protocol. So most database systems have undo and redo. Okay? Undo the bad stuff, redo the good stuff. And this is a new protocol which allows you to focus only on one part of it without the other. The reason that this is not implemented in database systems is that because of this sequencing, then you slow down the processing of the transaction because you have to wait for all these updates to go to disk before you can tell the user it's done. So from a performance perspective, people don't implement this. But from a conceptual perspective, it's an attractive solution because you can get rid of much of your software here. Okay. Then coming to the other aspect of database transactions, which deals with concurrency control. Here again, the usual question that people would ask in most of the undergraduate teaching is to say that state with a neatly labeled diagram the two-phase locking protocol. Okay? And they would duly vomit out whatever they have learned from the textbook on this and produce it without necessarily having an understanding of what these protocols meant and why they were required. So this question tries to put a spin on it similar to what Hemangi is mentioning in the L5, L6 kind of a framework, where it says that you have three transactions which arrive in that temporal order to a database system, and they're all being executed concurrently on the database system according to the read-write schedule that you see here. So here R means read, W means write. The 2 refers to the transaction ID. So this says that transaction number 2, read data item D, then transaction number 1, read item A, and so on. So this is the sequence which is there. And now what we are asking is that we are not asking state the two-phase locking algorithm. We are saying that given this schedule, can you tell me which concurrency control algorithm, if any, from these three well-known genres of concurrency control? One is two-phase locking, the other is timestamp ordering, and the third is validation technique, also known as optimistic concurrency control. So these are the three well-known approaches to database concurrency control. Can you tell me which one of them produced it? Okay. So then the answer doesn't become that obvious as to just stating a particular fact, because now you have to look at the sequences and say which ones could have been produced by any of these protocols. Okay. So what they would need to then do is to produce a temporal schedule like the one that you see here, where they have to align all the operations in the sequence that was given to you earlier, saying transaction T2, first read data item D, then subsequently the control of the processor was shifted to transaction 1. There was a context switch. It read and wrote data item A. Then the control was switched back to transaction 2, which also read and wrote data item A, then read C, and so on. And you can write down the whole sequence of events like this. And once you look at this, you can now figure out that certain things are not possible. Okay? So this schedule could not have been produced by the two-phase locking algorithm because this transaction T2 was, which you see here, this part would not have been allowed by the standard two-phase locking algorithm because transaction T1 is still in its lock acquiring phase where it keeps acquiring new locks, and one of the definitions for two-phase is while you're acquiring locks, you will not release any. So this is in the acquisition phase, which means it does not release the lock. But what this schedule is saying is that T2 went and happily got the lock on data item A, even though it was already being possessed by transaction T1. So this could not have been possible using the two-phase locking protocol. And similarly, you can make arguments for the others as well. This could also not have been produced by the timestamp ordering. In the timestamp ordering, the idea is that the commit order is pre-decided according to the arrival order of the transactions. Okay, that's not necessarily the only way, but typically that's the mechanism that is used, that essentially it's a first come, first commit kind of an sequencing where based on your arrival order, you get the matching commit order as well. So here, T1's write of data item D after T3 has read it, okay, so which you see here. So the operation that is done here, which was done after T3 has read it, would not have been permitted because this would be violating the temporal order that is already predefined. So you can also now say that this could not have been produced by timestamp ordering. But if you look at the last protocol, which is the validation technique, or as I said, more popularly known as optimistic concurrency control. So locking is considered to be pessimistic because it always assumes trouble are there. This optimistic concurrency control is a George Bush style of thing, which says, don't worry, be happy, okay, things will work out fine. So the schedule could have been produced by the optimistic concurrency control because this is a non-blocking protocol. It never stops you. Whenever you want data, it says, fine, you want to write it to your private workspace, but it makes copies of the data, and therefore it allows you to run through. At the very end, you may be in trouble, and then you might have to abort the transaction, but it never blocks you while you're in operation. So that is why that partial sequence that you saw was feasible with only this protocol here. So you can see that a fairly basic idea has been, some additional masala has been put on the problem so that it's not directly obvious. They have to think through these various strategies and these techniques and try to figure out which one is appropriate and whether it can work or not. Okay? Because more important than knowing what works, as Hemangi mentioned earlier also today, is that they should also know why things don't work. Okay? And especially in a country like India where most things never work, right? So you need to have some good reasoning for what is the reason this is not functioning and why something else is a better option instead. Okay, so that was essentially what I had just in a capsule format about both the database pedagogy as well as the assessment. And as I said, that if it is at all possible for you, I know that there will be restrictions from the university, but if it is possible for you to do an open book exam, open time may be harder because of the logistics involved, but please do open book exams, because why do we want to hide this information? We want to see what you can do with the textbook, not what you can memorize from it. So if there's any way to convince your higher administration that this would be an acceptable way of doing the exam, I'm sure your students will also be much happier, because now they're engaging with the problem rather than worrying about amnesia about page 25 of the textbook. Okay, thank you for this. Yeah.
So these days, students don't read these paper books because most of the books are available like online text.
Okay.
So that's the problem I face. So for example, if we say the exam is open book,
okay.
So the people who are able to grab some books from the library,
okay,
they have the unfair advantage.
Yeah, so this is a very good practical problem that he mentioned, that you selectively go and pick books out from libraries so others cannot read it or hide it in places that they cannot find it. But what we allow the students to also do is to bring their laptops itself to the exam. Now, there is a danger here is that they will now have Bluetooth connections between each other saying, hey, what's the answer for question number 3 and so on. There are some practical issues with that, but you can get around them. But ideally, you can also give them, because instead of people bringing so many books or papers, you can also allow them to bring their own laptops. So one of the things that we do is also to do random assignment of students to the in the classroom. Usually they would like to sit close to each other based on a collaborative effort. So we'll have put a random number generator to assign the seat numbers in the hall, so that when they come, they suddenly find themselves way off from their friends. And the TAs are usually aware of who are the groups, so we would have arranged it such that good friends are not sitting close by and are exceeding Bluetooth range. Then it should be okay.
Hello, Professor. I'm Lakshmi from IIT Bombay. Thank you for your talk. There is a rich contextual learning happening during the assessment or whatever exam that you want to call, because they have their laptops which they can refer to, books they can refer to, they have a problem which they have to solve. So there is something like very rich happening. So have you tried to like see how are they able to solve the problem? What is the approach that they take? So any insights on that if you can give us?
Yeah, but ideally I would say that the learning is not happening in the examination hall. That's way too late. It is a learning that they have had acquired before, but may want to look at specific details when they come to the actual exam hall based on the question you asked. So it's more the T and C, so to speak, which they are going to be looking at there. But it's not that they can come and say, let me now start studying, because actually that would be a very smart strategy for a student in open time exam, saying that if you're not going to ask me questions about transactions, why should I study about it? I'll come to the exam hall, now I'll look at the questions you asked and then start reverse engineering the studying that I need to do. But that usually doesn't work very well, especially if you have thought questions like the ones that I showed you. It's because I even had a situation where one of the students came and told me, sir, I know that this is in the textbook, but I can't find it in the textbook. Okay, please let me know where it is. So this is not what they should be using it for, but it's just that they should not get into this mental pressure that I'm forgetting something, and therefore I'll not be able to do it, because in the real world you are always given all the material and then saying what you can do with it. So the exam is only a verification that you had done the conceptual understanding earlier, and now you're given an environment where you can showcase your understanding and grasp of the subject. Right? But you should not start in the exam hall. So that's why, as I said, I completely disagree with the assessment drives learning model of the world. That's a very cynical view of things. Right, so.
Just a follow-up comment to the question he raised. So I allow open handwritten notes. No Xerox copies, no printed papers, because what I found is that if I allow anything open, they tend to, on the day before the exam, waste a lot of paper copying somebody else's notes, Xerox copying somebody else's notes. It doesn't matter. It can be anybody's handwriting. And some of my colleagues have also tried, instead of completely open, one A4 cheat sheet is allowed.
Like a crib sheet, right, yeah.
So that makes them also figure out what is important, what is not.
Correct, right. Yeah, you can have some modulations of this where you don't have to have the entire textbook, but given some summarized version of it. But the key is that students should not be memorizing things, because then it will disappear as soon as they leave the exam hall. They only remember, as I said, the movies. So what's the point of asking them to by heart it for a short period of time and then forget it immediately afterwards?
Yeah, Professor, your talk on the analogy, it was great actually, because the current tendency is, for teachers to make simple things complex. But your sort of analogy, is complex things you are trying to make it simple. And the other concept of what if scenario, that was very relevant, because in the industry, I have seen, for example, I just developed a product called Energy Meter. So when we wrote the software, it was a 10 kilobyte of code base. So when the user came and saw the product, he was laughing. So we were wondering, why he is laughing. So then we found, that there are some 50 frauds which is done on an energy meter across the country. And then when we implemented the code for all the 50 these frauds, we found the code going from 10 kilobyte to 50 kilobyte. So normally, academic settings, we see students only, catering for the function of the product. But when it hits the market, it really gets undergo all the frauds, what you can see in this country. So this what if scenario, we also call FMEA, failure mode effect analysis. This is hardly being taught in the academia. So I think we should really make a sincere attempt to include FMEA.
I think that's a very important point, is that this notion of testing methodologies is often given very bad press within the Indian context, especially because they say that the worst students are going to be put in the testing group. Okay, there's no fate worse than hell than put in testing group, but actually testing methodologies are very interesting to work on. Okay, how to design things to do testing has all the foundations of computer science. There's a wonderful theory, there's wonderful algorithms, there's wonderful experiments and so on to be done in it. So testing should actually be taught literally on day one, because that is the foundation of it. But we tend to kind of give it second class status and say that you write the code. I mean, real programmers write code, some other Jumru has to go and do the coding to do the testing and the correction of the code. That's a bad philosophy, because it means then that you are careless in what you are doing. So I think having a testing course is absolutely essential, and quite a few of the universities do have it and do it well, right?
So I think one last question, I think.
Hello sir, myself Professor Patil from Pune. I just want to make the mention that in the affiliation framework, where the colleges are affiliated to the universities, time is the constraint. So can you put the insight on that, how we can do the informal assessment when we are delivering some session, whether understanding happened or not? So do you have, because database related things, it is very critical. So when we are taking this, it takes time also. But in less period of time, we have to do that assessment also. So
right.
Can you just...
But so I understand in a practical sense that open time may be something too much to ask for. Logistics with regard to room availabilities and students being there and so on. So that's perfectly fair. But if you can just give them a few questions, but say that take the 3 hours, because all the answers are on the ceiling. Keep staring at the ceiling, eventually like the code there. So that's the important thing, is that how much effort are they spending thinking during the exam, as opposed to in a desperate rush trying to come up with some answer that hope will get them a few marks. I'm saying the attitude which they are approaching the questions should be a little more relaxed. Thought questions and say that's it.
But
okay,
that,
like that.
That is related at the end of that semester or mid-sem we are conducting this. But during my lecture, once the concept is over, I want to ensure that through some means. So that may not be a formal assessment, it may be an informal assessment kind of thing. So generally we ask the question and answer, but that is not that much.
That could be done by, for example, when, as also Hemangi mentioned earlier, when you ask about why something additionally was or new was developed, like she went from the D flip-flops to the JK flip-flops and so on, you could also ask them, why do you think you need anything better than this? And if there is some answer to that, that means they've understood the limitations as well, and this gives you the motivation for the next step. So that point that she made is very important, that you need to have a sequence as to what is the progression of ideas and what is the trajectory that was followed, and not saying that these are independent pieces. They need to fit into a larger framework, and there should be a sequential progression of those thought processes. And that's right.
Okay, thanks, Jayant. So in the interest of time, I think we need to move on. Thank you. Jayant, 1 second. You qualify for 1 moment.
After rigorous assessment.
Yeah. But only one. Okay, so we move to algorithms. So our next speaker is Venkatesh Raman. He is a specialist in algorithms and data structures at the Institute of Mathematical Sciences, and he'll talk to us about teaching this subject across various groups of students and non-students. So usually he doesn't use slides.
So I don't know where the slides are.
Just use Abhiram's slides. I think they're fine. There I saw Venkatesh Raman.
Yeah.
No, I think you go to downloads. I don't know.
Clearly need a better algorithm. Okay, so I'm going to follow Jayant's footsteps. No Bollywood movies or anything, but I will also talk without referring to AICTE and Bloom, because I don't know anything about them. So here is the outline. So I want to just start with where I'm coming from. Especially I'm going to share my experience on teaching algorithms, not so much to students of my institute, but at various FDPs and colleges around. I'll say some observations. Based on that, I will list out some minimum expectations, as Abhiram would say, some detailed expectation. And then I'm going to give some sample lectures. So again, I'll follow Abhiram's thing that the first lecture should be really important, because you want to get their attention, you want to make them feel that they're going to learn some cool stuff. And so I will explain my first lecture. So I'll give a 3 sample lectures. They all have been evolved over a long time. And then I'm going to, now that I have the mic and the stage, I will give some proposals which have nothing to do with algorithms, but more about, synergy between, colleges and institutes and stuff. Okay, so this is where I come from. I've been teaching algorithms to all levels of students at Tier 2. It used to be earlier I was teaching the teachers, but of late when campus placement, played emphasis on algorithms, I was also asked to give lectures to students, and I've also taught to moderate sized classes at IIT Jodhpur and IISER Pune. So what I'm going to discount is teaching to our PhD students, where they are a completely different lot, and that's not the experience I want to share here. And I'm not going to talk about assessment. That's left to Madhavan in tomorrow's session. Okay, so here's my observation. Okay, so so this is my observation, doing this FTPs and to students. That most students cannot even write an algorithm to find the minimum of a given list, right? I've heard this from others. I've also done this now. If some of you might feel offended by this, and if your college students are not like this, I've added some exception, right? So you can say your exception there. But this is true, that whenever I start with, okay, how do you find the minimum? The typical answer is, oh, you will compare. Okay, compare. It's good start. What do you compare? I'll compare the first element with the second element, and then the second. So, there is no concept of invariant or loops or something. Another thing actually I found is almost everyone knows binary search, but they don't know that actually it's, you can do it in log n time, right? The typical answer I get is, I run it like, oh, guess the number I'm thinking of a number between 1 and 1000, and you have to ask me yes or no questions to find the number. And, I start with, okay, 1000 becomes 2000, 4000, suddenly n. And the typical answer is 2 power n is the answer, okay? Or sometimes n by 2. And it requires, and these are people who have actually done a course on algorithms, or maybe 1 or 2 courses on algorithms, okay? And I define a graph, talk about adjacency matrix, adjacency list. How do you check whether a graph is connected? Lots of interesting answers, right? Oh, I'll make sure that every row has at least 1, 1. Okay, so no vertex is isolated. And somebody would say, no, I count the number of edges and it's at least, and again, these are people who know BFS and DFS. It's just that they have not connected that this is why we learn about BFS and DFS. This is just to solve some graph problems. Okay, I'll get to this later. So again, most of them think that you can insert and search in a sorted linked list in logarithmic time. And these are people who know about ABL trees or red black trees. They've learnt about balanced binary search trees. They don't make the connections about why we need to go through all the pain in those balanced binary search trees. So the diagnosis is that as is the case with most of the courses in the country, the concepts are learnt, memorized, and there's no connection between problems and what you learn. So to me, some minimum expectations from the course. I expect people to give a complete algorithm or a pseudocode for some problem. okay, for finding the minimum, Dijkstra's algorithm. Everybody, once you say Dijkstra's algorithm, yes, they know it. But how do they know it? You give a graph, maybe they will be able to, find the shortest path. Will they be able to describe using some loops and invariants and the pseudocode? Not quite. And I don't see how they would go to the next step of programming it if they can't even think clearly about the whole algorithm. And ability to analyze a given algorithm, given algorithm, we want them to know how much time it takes. And people have discussed about proof of correctness and efficiency. I would say the minimum expectation is that they have to be conscious that proof of correctness is needed. They may not know the proof, but basically, you need them to distinguish between an algorithm and a heuristic, right? Because often when I talk about NP completeness and a traveling salesman problem, somebody would say, oh, why not I just go from here and take the closest to vertex and move there, kind of thing. And so you want them to be aware that that's not a complete algorithm. It requires a certain proof to say that it works. I want them to understand the power of some basic data structures, more about what they can do rather than how. Because how, as Jayant said, you can look up and it's there. I mean, you don't want them to memorize how to insert in an AVL tree or something, but you want them, given a situation, which data structure should I use, is something they should be able to figure out. And some knowledge of algorithmic techniques. An awareness that there are hard problems and ways to deal with them. Okay, so I mean, this is another often asked thing about NP completeness. Oh, we find this so difficult, and my answer is, look, you can take a mic, go to the world, and say, I don't understand NP completeness, and that's no shame. But please make sure you understand binary search and merge sort. Right? That's important. That's something very basic. Okay, so based on all these observations, I think this is a list of minimum things I expect from the course. So let me start with my typical first lecture, okay? Because again, back to Abhiram's point, this is where you want them to, you want to get their attention and make them realize that the whole course they're going to learn some cool stuff. So the problem I want to start with is, given two large arrays of n numbers, and you want to find all entries common to both arrays. Okay, this is simple enough that I can get them to talk about it, two for loops. In fact, whether I do it in FDP or in college students, I make them write the entire program, analyze it, simple enough that it gets people to talk about it. And I say that n is huge, right? I use Aadhaar cards or Aadhaar numbers or SIM cards. So we are talking about 100 crores database. So people typically come up with the easy n square algorithm, right? Just pick every entry in A, compare it with everything in B, and that's n square. I mean, some of this analysis we take for granted, but this is non-trivial, but it just gets them started. And for the kind of n we are talking about, this is like about 10 power 20 steps. And assuming that a machine takes 10 power 10 steps in 1 second, this is like 10 power 10 seconds, which is about 317 years. Okay, so this is, first of all, dramatic. It hits them that, oh, we think that computers can do everything so fast and so on, but here you're talking about a simple enough problem which is going to take you some 300 odd years, right? So I'll leave it there. We will resolve the knot at the end of the lecture, and then I digress to basically binary search. I think of a number. I want you to ask yes or no question and get that. Again, people don't connect this with binary search. Not everyone immediately gets it. Again, that somebody there in the audience will say, oh, is it bigger than 512? I will ignore that person for now, because there's somebody else who is asking me, is it a palindrome? Is it a prime number? Is it a 3-digit number? It's so much fun to just go through all this, right? And we'll see how many questions, we'll look at the power of the question, which question is more powerful than the other, and eventually we settle down after another 15-20 minutes on binary search and log n. Okay. So now I come back to the original problem and say, I make some stories about, I call this Nandan Nilakarni, who is this Aadhaar guy, and say, hey, I can't wait 317 years to solve this problem. Tell me what should I do? And then he says, I know this problem will happen, so I have kept my array sorted, right? At least one of the arrays is sorted. B is sorted, let's say. So now you can do binary search for searching each element in B. That's n log n steps, but n is like 10 power 10, so you can do 10 power 10 steps in 1 second, so that boils down to log n seconds, and log n here is about 40 seconds. Okay, so this is quite dramatic again, that and a difference between n square and n log n is between like 300 plus years and 40 seconds. Okay, so and there's so much interaction. They learn about binary search. There is the fear of log. They learn about log. It's very interactive. So many of these teachers or the students who are used to just sitting very passively, but here we are talking about we play this game, and is it a prime number, is it a palindrome, so it's all, and at the end of it they're learning something, and it's pretty dramatic. So I think this gets them curious about, okay, we're going to learn some cool stuff in this course, and I know they understand why Google and Flipkart and Amazon ask algorithm questions, because I tell them they can't afford to wait 300 years to solve your problem. They want 40-second solution. Typically this takes me to the end of the first lecture. It's like about an hour. And then I say, hey, how much time did it take to sort B, right? Because B was sorted. If that takes 300 plus years, then all bets are off. What's the point of it? And then takes me to sorting, finding min, and so on. Okay, so in fact, even just finding max and min, I spend so much time. Can you come up with a different algorithm for finding a max? How many different algorithms can you come up with max? And there is a lot of discussion that happens around it. Okay, so that's my first lecture, and how the lectures follow after that. And then my talk, how do I introduce balanced binary search trees? So I say, okay, you've learned binary search. We know how to search in a sorted array, but I also want to insert an element. And how much time does it take? Well, you can do binary search, but you may have to do your moves. And at this point, I'll say, hey, why do we use an array? We use a sorted linked list, right? And most people nod and say, yes, we have solved the problem, right? We can, yes, because linked list has this advantage that you don't have to move things, but then somebody will realize that you can't index into it. But there's so much about array and linked list, such a basic thing they are learning in this whole process, right? Then I talk about binary search tree and pretend that actually we have solved the problem of trying to do it in logarithmic time. Then we realize that over a lot of insertions, it might become a list, and so we need to do balancing. I know why we need balancing, and I stop here actually. This is my luxury, right? I don't have to, because this is like an FTP or some students who already know how to insert in an AVL tree and so on. I don't have to do that. What I spend my time, why do you even need AVL tree, right? So that's my focus on, and that's how it goes about balanced binary search tree. Okay, introducing heaps is a lot more fun. So the point I want to say is typically every lecture starts with some problem, and together we all try and solve the problem with some known solution, and you can go only up to so far at some point, and then we stop and I bring in some fancy thing which you can appreciate. So here is a problem. I say you want to maintain some data. You have a stream of data coming in, and you want to insert and you want to find the min, right? Now, the moment they see min, typically everybody would say heap because they've all done a course, right? So they'll say heap. Now, my answer is no, I don't know heap, okay? So all I know is so far we have learned balanced binary search trees. Why don't I use balanced binary search trees? Yeah, okay, if we can use it. Why not simple array? Why not sorted array? Why not linked list? So we go through all this. I mean, I want you to think about this problem actually. And it turns out you can actually answer with just one variable. You remember the min, right? Because I am doing insert and min. So you remember min, and whenever a new element comes, compare it with the min, and if that is smaller, replace it, otherwise throw it away. So you have a constant time, constant space data structure, right? So we start with heavy duty balanced binary search tree, blah, 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 and all that. And then you end up with, so this gets a lot of kick, right? You can see a lot of smile here. Oh, okay. It goes for about 15-20 minutes coming up with various solutions. Now I say, okay, so, but suppose I also want to delete some element. Yeah, I didn't even store anything. So what is the big deal? I've deleted it, right? So this is how I go on. But then when you want to delete the min, what happens, right? Again, somebody bright will come and say, why don't we remember min and second min, right? This is a typical answer because I don't move on until I get this answer because I've done it so many times. Okay, great. Let's remember min and second min. Fantastic. Okay. But the min is deleted, second min goes, what happens? Okay, then you run through variance, invariance, maybe keep it sorted, insertion is a problem, all that, and then I throw in, okay, here is a heap, which is somewhere between an unsorted array and a sorted array, but Okay, so the general philosophy, so those are, I just wanted to give you a sample of these 3 lectures, right? First lecture where you have this 2 large arrays and you want to find the common entries and how do you introduce balanced binary search trees and heaps. So general philosophy is introduce concepts through problems, and algorithms is such a rich course for this that, every lecture, whether it's graph algorithms or minimum spanning tree, shortest path, I can throw in the problem and let's all come up with the solution. At some point we will, there will be a jump and they're learning something new. They will really appreciate heap after we go through this song and dance of, oh, let's try this, let's try this, let's try this, let's try this, and then say, oh, okay, great. Yeah, I mentioned about this correctness proofs. People have asked that, people who come to our institute who are trying to do PhD, really, we want them to know the proofs, practice the proofs and so on. But I think for the mass, I think they just need to be conscious of the fact that proofs are required. Okay, so now that's all I'm going to talk about algorithms. Okay. I'm just now going to just make some general proposals, which I have discussed with some of you. Professor Pathak mentioned yesterday that there are about 40 lakhs engineering students every year getting in, and I asked him how many computer science. He said about 40% of them, about 16 lakhs computer science students every year, out of which IITs and NITs and institutes like IISc will absorb some epsilon fraction, So 90% of the mass are in these colleges and universities, and I think the events like compute and our pedagogy and all things should focus on how do we improve this. And many of the lectures today were all along the same theme. So, and this discussion also happened yesterday that, each one is in their own silos. The institutes are in their own silos. The colleges bring up people from their own products. So one thing I wanted to point out is that One of the things that happens in IITs and other institutes, there is a lot of mobility across international, people coming in, going out, people going abroad kind of thing. So why not have such mobility between colleges and institutes? Okay. Right, so new education policy talks about autonomy. Many, eventually every university is going to be autonomous, and there's a panel discussion on autonomy in the afternoon. But, are colleges, university really ready to make use of the autonomy? So here are some concrete proposals, right? So one thing I would like to propose is that maybe facilitate for selected teachers from many of these colleges, universities to spend a few weeks every year at these institutes, right? There are already some precedents. So our institute has an associateship program by which people from colleges, universities can connect with somebody in the institute. All you need to ensure is that there is somebody willing to spend time with you. And then based on mutual convenience, you will visit the institute for about 2-3 weeks during your holidays, or about 2-3 years. And Science and Engineering Research Board recently came up with a program called TARE, Teaching Associate for Research Excellence. This specifically facilitates people from private universities, colleges to work with research institutes and make up some research proposals. And the requirements are reasonably minimal. You just have to visit the institute 90 days in a year or something like that. I think these are good programs, and I would really like to facilitate more movements across. Yeah, I've not really thought through some of these proposals. I may be completely, it's just open for a discussion, and many of this may not be in our control, but why not encourage sabbatical for faculty from institutes to spend at colleges? And I've heard that, people do go as director of the institute or something, but I'm saying more than that, right? Maybe, spend a year and some university and share the teaching and research, and I think that will have a good dynamics to improve quality in these colleges. Yesterday there have been some discussions on, in fact, Fatak also pointed out that if you want to be a teacher in a school, you really need to have a B.Ed degree, whereas for university teachers, PhD is enough. So, in fact, I would suggest, in fact, Sridhar was also talking about some master's program, an educational master's program. And I'm going to even say that make this a preferred degree for entry into these colleges than even PhD. Right? So I don't know, except for people who are going to be doing research lifetime, I'm not even sure PhD is necessary, because just unnecessarily mandating PhDs throws in so much ordinary journals and papers, and also institutes always wrestle about the quality and so on. But I think a good master's program would be good enough, and somebody really motivated can come back and do PhDs. Right? Yeah, because of the demand, I think there is a lot of pressure to produce PhDs, but instead I think if you just make this, many of this is not fashionable thing to say in this world where everybody says about research, but that doesn't bother me. I will throw it out anyway. Yeah, okay. So I think that's all I have. I'll stop here. Thank you.
Yeah, so, I'm Venkatesh Kamath. Yeah, so, one of the things that you're trying to do is, give enough time to the students to discover the solution. I think
Yeah.
But often the complaint from the teacher would be that there is not enough time.
That's not true.
Huh?
I have seen this.
So often they are more interested in covering the syllabus. So that's the reason why they directly go on to the solution rather than giving them enough time to. So what's your take on that?
I don't think it takes in more time. I think it is just a style of teaching rather than. It doesn't make it any slow. In fact, it may be.
So many a times what happens is, see, the freedom that you have, okay, I didn't cover the whole syllabus, but maybe whatever you have learned thoroughly, right?
So what does cover the syllabus mean?
Covered the syllabus in a sense that it has been discussed in the class. It has been discussed in the class, right? That's what the covering typically means. Okay, that's the colloquial word that's used.
No, I think this actually will facilitate, it will even speed up because I don't think it will really slow down.
Yeah. So actually, I think what Professor Kamath is saying is that, say in an algorithms course, there may be an expectation that every type of balance tree is covered. Okay, every data structure is covered to a great gory detail. And I think what you are advocating is
reduce that,
yeah. Right? And once you have implicitly reduced it without even thinking about it, and for a very good reason.
I am not offering a full course here, right? This is not. Still, this is like a 5-day, 10-day thing. So for a full course, I will cover it.
No. But I mean, I would not. When I teach a course in IIT on the same topic, I would say I'm going to talk about one balance search tree.
Yeah, exactly.
That's it. Yeah. And if you understand that thoroughly, that's good enough. I don't have to go through every search tree.
Yeah.
Okay. So that will open up time for discussion.
Yeah. So yeah, I think it suggests updating the outcome and.
Just a comment on the first bullet itself. The Educational Masters Program, by the way, I'm Hemant Pandey. It sounds like 1.5, 2 years or something, and then you're saying 70% on subject. So I mean, perhaps it might undermine their own education. So instead, could it be shorter? It could be more mass-produced if it focused on that pedagogy, assessment, research, and education technology.
Okay, that is open for discussions, but to me, this is the more important thing. This is the harder thing, that somehow say that you don't even need a PhD, but if you have a master, this master's from these institutes,
a shorter master's,
you
whatever.
get preference over a PhD from some other place.
Yeah.
I mean, that's harder to implement. I mean, I think.
I am Manish Kurekar. I just wanted to know, like, typically nowadays the class sizes are increasing like anything. So theory courses are better taught, in my opinion, when the class size is very small, like 30 students.
No, in these FDPs, I have done it with 100 teachers, 150, 120 teachers. So, yeah.
So that there is no issue.
I mean, I have the luxury of just giving some 6, 7 lectures. I have not done a full course, but yeah.
Good morning, sir. I'm Aruna. Thank you for your talk. Sir, actually, it was a very fundamental question. I was teaching in BITS Pilani Goa campus, and I pursued my PhD parallelly. Now I shifted to an affiliated college, which is affiliated to GTU. And previously also I worked in affiliated college to JNTU, Andhra Pradesh. So when I was working in BITS Pilani, I myself used to conduct open book exams, even open laptop. So as you mentioned, 90% of the percentage of students are from the affiliated colleges, other universities. Only 10% is from IITs and all. So I just want to know, like, the kind of approach what you have shared with us. It's really good, sir. As Professor Kamath also was telling about the syllabus limitation and all, and also the type of the questions that they are asking in the final exams is really, you feel so discouraging. You means they ask something like, explain the entity relationship diagram symbols with examples. So, I mean, what kind of initiatives that I can expect from the creamy institutions like IITs, NITs, and BITS?
Yeah, and that takes us to the whole harder question of assessment and autonomy and yeah. See, about this covering syllabus and so on, I was called in one college to, they said, oh, they've covered everything. There's one module they have difficulty covering and they wanted me to lecture on. And you won't believe what that lecture, I thought it will be like NP completeness. No, it was the big O, the initial thing. And I would not believe what have they learned in the rest of the course if they have not done this. So, and this teacher says, oh, we use PowerPoint, but still I didn't have time to cover. I see, okay, fine.
Thank you very much for such a good lecture. And first time I have found out somebody is resonating with the thought which I was continuously thinking about. UGC has said that 2021 will be mandatory. And my thought was what I have seen, because I go for the practical examination in many colleges of Delhi University. So what I have seen is this enforcement of API, we have already seen what has happened regarding these publication in so-called journals, and UGC coming out with a list of journals, then cancelling all those, then coming out with the care list, and we do not know what will happen even to that list. So this idea of this kind of degree is very good, and I would really request to all the who are sitting here to communicate this proposal to the government, because this is one of the points which continuously I'm thinking about. That enforcing the PhD degrees and publication and all, neither these teachers, they are neither becoming a good teacher nor they are becoming a good researcher.
Yep.
That will be my request to all the dignitaries.
So I think it is a good idea to have pedagogy. I think there is no doubt about that. But I think currently we are at a complete extreme point. So let me explain what I mean by that. Let's look at PhDs that come out of IITs even. Okay? If you ask many of these people to explain their work to non-specialists, non-specialist computer scientists, they would be at a complete loss. A huge number of them. So I think this is a basic requirement that should be fulfilled by the PhD granting institution without any thinking about pedagogy. Similarly, MTechs which come out of IITs have really poor communication skills. They came in with poor communication skills, they go out with poor communication skills. So it's not really a problem. I mean, if they were going out, if communication skills as a whole in the entire country were decent, we would not be in such a bad shape as far as pedagogy is concerned. Okay, so I think there is also a great requirement to generally improve communication skills.
Especially
who is somebody who is going into the industry needs communication skills as much as somebody who is going into teaching. They may be slightly different kinds of skills, but right now the communication skills that are present in graduates are really pitiful.
Thanks for your lecture, sir. I'm Shantanu. Given the scenario that you spoke of pedagogy, wouldn't it be prudent if we make this other way around, 70% on subjects and 30% on pedagogy and assessment?
As I said, I'm not holding on to this. This is open. Whatever, that just came to me as a
Would this program that you're proposing, master's program, will it have more focus on pedagogy, assessment and research expertise?
That is up for discussion. It could be 50-50, 60-40. But my more important point is this. This is a harder thing, that somehow make this a preferred entry degree for college teachers. even over a PhD from some other place. So give more value to this, and exposure in these institutes with an educational component is more important than the so-called PhD degree. Okay, so that is my thing. Yes, I mean, all of this, as I said, is up for discussion. Whether I shouldn't have probably put that 70-30, but this is just some number. Yeah.
Thank you.
I'm Venkatesh from IIIT Hyderabad. This is kind of an open question, and it relates to the second point that you put there. The question really, it also relates to the question that Abhiram was asking, or commenting on rather. How many of the PhDs that we are producing in the country in computer science are actually going into teaching professions? I think that question has to be examined, and I can tell you where I teach, most of the PhDs are actually going into the industry. The motivation to go and teach after a PhD is very, very low. So we can of course have a master's program, but we have to do something to motivate the PhD, saying, teaching is a noble profession, and in fact, many people who are supposed to who are doing a PhD, they should consider that as an option. I think they can't completely abandon the PhD track, is what I'm saying. Thanks.
Any other comments?
I totally agree with Professor regarding the communication aspect, because what I see, storytelling is something which is alien to our students starting from primary school to high school. I mean, they come to the engineering also. So that really reflects when especially startups pitch. I've seen that people tell first the thing which has to happen the last, and the last thing the first thing will go to the last. So there is now thinking of storytelling, whether we pitch for a business idea after coming out from PhDs and other things. So storytelling in fact has to be I think the other team in the back should bring it into their portfolio as a competency is to be added. And the next quick thing is, I was there in the IIT Delhi's industry day. Though the director of IIT Delhi made a very bold statement. He told instead of PhD dissertation, if a company, if a student can incubate a startup within IIT, that is sufficient for these things. So that is a great thing. And he also told people from the industry without even PhD can teach in IITs. He told a professor in practice. So after that meeting, I just sent a message to him. Immediately he responded saying that you come and meet the concerned faculty and you can be a professor. So I think there is a transformation that is happening in the higher education area. So I think all these changes now are very, very positive. That's what I see.
So, as you said, the communication is as essential in industry as in teachers. But the thing I think is, in industry you're pushed. You are evaluated continuously, and you can't survive without good communication. But whereas in a college, nobody would even notice, and you can survive for long. So I think it's all the more important to have good communication for these teaching jobs. Yeah.
Yeah. So I think we have to continue.
Thank you so much, sir. I would like to request Professor Madhav Mukund to please present Professor Venkatesh Raman a memento as a token of our appreciation.
So our next speaker is Bhaskar Raman from IIT Bombay, and he'll be talking about active learning in the area of networks.
Good. Can I use this water? Yeah, thanks.
We're just passing wherein you can just write your name if you're interested in the CS education workshop. There's going to be at 3 o'clock now.
Should I end on time? Ahead of time. Okay, so I will keep it as short as possible. It's a tough time sandwich between some good speakers and well, not quite between lunch. There is another speaker after me, right? Yeah. Okay, so that's saving grace. So good part of the talk is not specific to computer networks. It's about tools which we have developed and used for computer networks and also for other subjects. Two tools I'll be talking about, Bodhi and Safe. These are developed by our team at IIT Bombay. Work has been going on this since 2013. The talk is titled Interactive Teaching and Active Learning. So if you step back and think about how various things humans do have changed over the ages, starting from pre-industrialized age, things have changed, of course, tremendously. For example, in the domain of transportation, how we do long distance transportation especially, it's dramatically changed. Similarly, if you think about long distance communication, that also has changed from early days of using birds and smoke signals to telegraph to today information age, in fact misinformation age. So that's, things have changed dramatically. But some things have not changed. For example, how talks are delivered and listened to have not really changed. Which may be okay for this kind of a setting where many of the speakers are very well prepared and very well experienced and can think of Bollywood examples and Aadhaar based examples to illustrate importance of sorting and stuff like that. But for the median scenario, this is not suitable. In fact, if you see, the situation has become far worse because each one is in their own world because of what technology allows them to be. In this picture I have chosen in a lecture, each one is in their own world doing whatever. So we'll try and change that starting now. So the usual thing which is done is to ask you to put away your device, and that's doesn't usually work, so that's not what we'll do. We'll try and do a different approach, which is to use technology for better interaction. So I would actually like you to go ahead and do this. The purpose of this is to primarily to illustrate how this can be used as a teaching tool for better interaction and better learning, just to illustrate, and it will also illustrate how easy it is to get started with this. One thing I don't want you to be alarmed about, the app asks for few permissions. We're not doing anything with your data. I can explain what by the end of the talk you might appreciate some of the permissions which it's asking. So this works on both Android and iOS. There is a beta version also. Don't use the beta version. If your search shows up that, use the main version, which is a green lock icon as shown there. Huh? Oh, download is taking time? Okay, so fine, we'll go ahead then. You can switch to mobile network if that is faster. In fact, I switched to mobile network on my laptop because the Wi-Fi was getting too slow, which is an indication of people doing other things in the room. All right, so similarly, teaching also has not largely changed. These are some illustrative pictures. Of course, the background has changed because of technology, but the process of teaching largely has remained the same. Of course, you have some great teachers like the speakers we saw just now, who come up with great methods to teach, but the median scenario is that there is a teacher lecturing in front of a bunch of students, a large percentage of whom are mentally absent, even if physically present. And the problem again has grown worse because of scale. This is a problem which I have faced personally, and many of you also, I'm sure. Since I'm going to talk about a tool which is partly for evaluation, so I have put in a slide saying that evaluation also has remained pretty much the same. The use of technology in evaluation has pretty much remained the same, which is 2000-year-old paper technology. And given that things have not changed, we all face problems, especially when it comes to scale. Some of the questions from the previous sessions also pointed that out. How do you deal with scale? That's a really big problem. We have 100 plus core class sizes. My class strength is 120. Our core class sizes can easily reach several hundreds of students. With size comes lack of interaction as well as student variability, and finally it leads to poor attendance. Even in places where they enforce physical attendance, it is impossible to enforce mental attendance. This acts as a vicious loop, a negative feedback loop. It hurts the students' learning, this makes the teacher demotivated, and so on. And the long-term learning quality suffers because of this. So it's in this context that we put together these tools, Bodhi-tree and SAFE. Bodhi-tree is a learning management system, you can think of it that way. It grew more or less around the same time as these MOOC platforms. There is actually good amount of overlap with MOOC platforms. So I will mainly talk about the diff from the existing platforms. And SAFE is SAFE stands for Smart Authenticated Fast Exams. We will actually use it hopefully once you have downloaded. Okay, so Bodhi-tree, like I said, is a tool which we developed. It's a multimedia book platform. I will specifically talk about how we have used it for teaching network scores, our experience in using that, conducting flipped classes, and also use of SAFE platform. So this is a fun slide I like to show. Is a research study done by some researchers using a student as a volunteer student as an example. They measured the electrodermal activity, which is actually a measure of current on the skin, but it's supposed to be a measure of physiological and psychological activity and awareness. The graph shows y-axis is the activity measured, and the volunteer has labeled along the x-axis what activity he was doing during that particular time. The conclusion sticks out, right? What's the conclusion? Yeah, so the students is not active during lecture and also during TV. So TV makes us, Bollywood makes us remember through other means by attaching emotion that is difficult, if not impossible, for many technical subjects. So the point here is that real learning happens only through active participation of the student. And in this context, if you ask the question, what should be an ideal classroom and what should be the role of an ideal teacher, that is answered by the flipped teaching model. This is a picture taken from the Wikipedia page on flipped teaching. It essentially says that don't lecture. In classroom, in a typical traditional classroom, what happens is the teacher lectures in the class, and activity or homework or problem solving happens outside the class. In a flipped classroom, it's exactly reversed. Lecture is done outside the classroom. In fact, this is enabled by technology easily today because of video and internet and smartphones and so on. In fact, there is really no need to repeat yourself over and over again the same material. So we talked about covering portions in the previous talk somebody raised. That can be done by just through a recorded videos. You just explain the algorithm or ask them to read a textbook if you want to rely upon older technology. Right? So what should really happen is what Professor Venkatesh talked about, which is interaction, right? And problem solving. So the student should actually try to solve the problem, and hence discover the solution and discover the need for the solution, that is when real conceptual learning happens. So that's the philosophy of the flipped classroom. And Bodhi is essentially a tool which enables that. It's a multimedia book organized as chapters and sections. So these aspects are similar to a typical MOOC platform, but some aspects specifically related to interactivity and active learning. Some of them are unique, which I will show through a demo actually. So let me switch to the browser, hopefully it will work. Okay, so this is how the book looks. There are several chapters and several sections, and let's go, for example, in link layer. There are different sections in the networks topic. Maybe I'll switch. Maybe I'll show about this Ethernet switching. Mobile network is also a bit slow. Okay, so I'll actually switch to the student view. So the student sees in this section different videos. And the key aspect here is that of interactivity, which is not happening right now. Okay. Finally, okay. So as you can see here, this section has 3 videos, and as the video plays, there are quizzes, interactive quizzes, which will pop up in the platform. So for example, let me start playing this video. So the content is not important. So question pops up like this, and as you can see in the left hand side, there is questions inserted, like, at different instances. So this is like an interactive lecture. In fact, it's better than an interactive lecture, because even the best of professors in a class of 60 cannot get everyone to answer. Maybe you'll find that the same set of 5 or 6 students keep answering. However, in this platform, of course, it's restricted to objective questions. So my opinion is that objective questions are bad for evaluation purposes, but objective questions are great for teaching purposes, in many ways, in giving feedback, in guiding the student towards the answer. This is an aspect, this interactive questions as embedded part of the video, this is an aspect which has been appreciated over the years by our students. So this interactivity is there in some MOOC platforms, but it's not really uniform. For example, NPTEL, SWAYAM, even edX doesn't have it. edX is in the process of building it. Coursera has had it, but this interactivity is a aspect which we have built from day one on this platform. So going back to the presentation. Okay, so this is used as a flipped classroom interface by the instructor. You put out the videos, give a schedule for watching it, and in class there is activity. So what is the in-class activity? So that also I'll show using the platform. So in the platform we give several practice problems. Okay, so at the end of each, this is like problems at the end of a chapter in a book, and many of these are numeric. Some of them can be subjective, some of them can be objective, and the problem solving is what happens in the classroom. And as part of, so let me see if I can pull this up. This is my architecture course which I'm actually teaching this semester currently. So there is a scorecard which is like a friendly competition among students. In this course I don't have out of video quizzes, but there are in video quizzes, lots of them, and different students have attempted different levels that can be seen. Okay, so I've been showing the demo. So to summarize, Bodhi tree essentially supports interactive learning through these
in-video quizzes, and active learning by supporting a flipped classroom interface where the teacher has a very important role of helping the students as they solve practical problems, design problems and numerical problems and so on, supported through out-of-video quizzes. Couple of more aspects of Bodhi tree, which again are there in programming assignments is there in some MOOC platforms but not in all. So let me show that. So for example, in networks, so one of the programming problems which I tend to give is simulation of the Ethernet spanning tree protocol. So you don't have to know the spanning tree protocol. Essentially there is a graph of bridges and LAN segments, and there's a distributed algorithm which runs. The spanning tree protocol is the distributed algorithm, and students have to understand this and code it up. So you can specify programmatically the input, the network can be specified programmatically as an input to the program, and the expected output can be given in the system on Bodhi tree. So essentially the student has to write a program to simulate the spanning tree protocol, which requires understanding the spanning tree protocol, and the understanding can be tested by giving various test cases on the system. So that's the other aspect of Bodhi tree which supports active learning. The third aspect of Bodhi tree which also goes hand in hand with the active learning is that of lab reports. So in many institutes including ours, we have a lab course which is associated with the theory course for subjects like computer networks, and some of the lab activities which we do, let me show a specific example again from Bodhi tree. So if it takes time, I'll just talk through it. Essentially, labs like collecting a trace on a computer and explaining the trace, explaining the network trace collected to identify some simple things like what's the machine's IP address, to more complicated things like operation of ARP protocol, DHCP, operation of TCP sequence numbering. So various protocol aspects can be lab assignments can be formed in that context, and we have a interface to support lab reports, which is essentially an interface to submit lab reports. Okay, so for example, there are some instructions given to the students. The details of the instructions are not important. I just want to point out that just like in a paper pen lab report, there is a way to answer, there is a box to answer, and there's an interface for the TA to correct the subjective answer given by the student based on the instructions. So these are the ways in which this Bodhi tree tool supports active and interactive learning. I will quickly breeze through some of the learnings from using Bodhi tree over the years. The way I have organized using Bodhi tree is I specify to the students, so the student size since the time we started has grown from around 90 to now 120, 130. I divide them into 3 groups and tell them that each group has to come only once a week. So the in-class session gets reduced from 3 hours a week to 1 hour a week, and the remaining 2 hours which they save, they are supposed to watch the videos and come prepared to the class. So this allows a couple of flexibilities. One is for the student, they can get to watch the lecture video anytime they want, and for the teacher as well as student, it gives a lot more opportunity to interact during the class. So I have stopped lecturing in my class for a long time now. I just go around and interact with the students, so they have this set of problems open in front of them, and I can proudly claim that in this model, mental attendance is near 100%. Of course, some students do sleep because of lack of sleep, but that's okay. So one thing which we found is that initially when we started this model, if you ask students to watch the videos and come prepared for the class, you can expect what will happen. They won't come prepared. The median student won't come prepared. So maybe the top 15-20% of students will come prepared, but rest of the 80% will be unprepared. So the whole thing falls apart. So in order to fix this, we wanted to incorporate, quick quiz. That's one of the motivations for developing this SAFE platform, which is, so initial years when we used Bodhi-tree, we actually did paper pen quiz. Of course, that was unscalable, very laborious to handle, and so on. So then we thought, every student has a smartphone, why not use it for conducting quizzes and exams? And that was the origin of the SAFE platform. So this is the weekly plan for using Bodhi-tree. So the outcome of this, I will not get into the details because I'm running out of time. Students appreciate the flexibility and the personalized learning they get, as well as the conceptual learning which they get as part of solving problems. Okay, so we have run several courses using Bodhi-tree, and many colleges outside of IIT Bombay have also used, depending on individual interest of faculty, not institute-wide, of course. We conducted a student survey a couple of years back. So let me not go through the details of the survey. I'll just present some interesting aspects. Okay, so helpfulness of quiz within video was appreciated significantly by most of the students. The in-video quizzes, the feature which I showed. The questions outside the video, which is the tutorial problems, that was also uniformly appreciated. One significant change was that in terms of exam preparedness, students felt that they were much better prepared in this model of teaching because they were already used to solving lots of problems in class in the presence of the teacher. And overall score in comparison to the traditional model of teaching got a big thumbs up. So not only is the students and teachers' perspective of this model of teaching using this platform good, but also we evaluated the actual performance of students. So we took 2 semesters of the traditional mode of offering of computer networks and compared it with 2 semesters of flipped mode of offering by the same instructor, and hence exam difficulty was about the same. What we observed, I want you to focus on the last 2 columns here. The top students, the AA corresponds to the 10 out of 10 grade in our system. The number of top students is pretty much the same. So this model doesn't really help the top students so much. They are anyway going to perform well. What we observed was that the next few buckets, there was a significant jump in performance. So for example, the very next grade, AB, saw a significant jump from 11% only getting AB to 29% of the students getting AB with the same grade cutoff. Okay, so and this we found throughout in the medium grades. The number of students performing well in terms of conceptual understanding significantly improved. No, different batches, different years, yes. Different years, but the same instructor, and hence, different exam questions also, but one can expect that same instructor will maintain the exam difficulty level about the same. So we have also done similar study for the computer architecture course also, and there also there was a significant improvement in the median performance. Okay, so with that I will, so let's see if we have time for the quiz. Do we have, how much time do I have? Another 5 minutes. Okay, so in that case we'll do the quiz at the last. Okay, so we'll ignore this. All right. So I'll just talk about this SAFE platform. So The safe platform is captured in this slide, which is this is a notice stuck outside of our classrooms, which turn into exam rooms at the time of exams. It says that mobile phones are not permitted for obvious reasons. It can be used for cheating. I wanted to ask you how you handle the cheating part that I'll ask you later. This is an open handwritten notes exam. All my exams are open handwritten notes, and the students are using their mobile phones for answering the questions. Okay, so while the system violates this rule, no mobile phones in letter, in spirit, we go to great extent to enforce this, which is to prevent the phone from being used for cheating during the exam. So the phone can be used only for the exam during the exam. And the motivation, I already went through the first part, which is poor student participation in flipped classrooms, and hand in hand with that, attendance problems, student attendance problems. We also had these large admission tests which had to be conducted, pre-interview screening. That also was a need which we felt at that time. None of these is possible to handle at the scale, this scale using paper pen. And there are, of course, current online exam methods, but those are too heavyweight because you need a room set up with desktops and LAN cables and backup servers and backup power and so on. It doesn't scale. It's not suitable for conducting class level exams. So we wanted to achieve this with ease of setup, preserving cheating free operation, and third goal is also important, which is robustness. A lot of corner cases should be handled, like network failure and phone crashes and so on. So if you want to use a system for examination, corner case handling becomes very important. And all of this must be done at scale. So you will actually experience this. So I'm going to skip this diagram, okay, how it works. Ease of setup we achieve through bring your own device model. So this you will experience hopefully after you have installed the app. Each one of you is using your own device, same with the students. So it's very easy, no specific infrastructure required. In fact, the current model, we don't even need classroom Wi-Fi. We don't need mobile network also in the classroom. The second part of easy, so we largely support auto-graded objective questions. We also have support for subjective questions, but that's I won't talk about that here. So this is, the purpose of this is not to replace regular exams. It is to support regular exams. So for example, in my own courses I run, I assign a weightage of 10 to 15% for these quizzes, which I conduct every class. In the last 4 years, all of my classroom sessions have begun with a 5-minute quiz using this platform. Okay, cheating free, how we achieve, using a host of methods. You can talk to me about it if you're interested. Some of the techniques which we use are track the app focus. Of course, authentication is there. We have a logging and reporting mechanism to server which makes it robust to crashes and so on. So a whole bunch of mechanisms which I won't get into the details of now. Robustness we handle through periodic submissions and proper state maintenance. All of this is part of the technical aspects of how we do this. Scale we achieve by, partly by the fact that we generate very little traffic, and also partly because, in fact, we don't need any network at all during the critical stages of the exam, which is during exam start, we don't need internet. During exam end also, which is when you expect all the submissions to come in and hence cause a congestion either in the network or at the server. Even then, we don't need network at all, in the sense that we gracefully handle overload situations. I'm not going to go into the details of the features. There's a different set of different kinds of objective questions we support. We've used it over 5 years now. The product has matured significantly over the years, and which is the reason why I'm even attempting a live demo. Yeah, I'm about done. Okay. Okay, I will skip this safe feedback. So let's just go to this. So I will also take questions while you do this. Okay, so I will have to give you the password. So the way it works is, the first 3 steps are one-time steps. The only step to do during a class quiz is to type the quiz password, so which I am going to provide you right now. So you will see 3 quizzes. Since we didn't have time, I am going to run only one of them. Okay, which is quiz on SAFE itself using SAFE. All right. Okay, so this is a 8-minute quiz, I think. So if I start now, it will run for 8 minutes. Okay, so the password is shown on the screen here, ZJTY. Okay, that's the password you need. Register. There is a register screen in the front screen. That is G08123. It's not working.
This course is not available in your organization. It's not working for me. I work for others.
Okay, I think you are. I created a demo organization for this. So if you've already installed, then you will. Okay, for you. Huh? You also used earlier, is it? Quiz on SAFE using SAFE. The title of the quiz is this. Yeah. Yeah.
At the time of registration.
No, they don't have to.
But that's happening. That's why I think the screen is not coming.
Once you open the app, just press the Google login button and then press the register course button using this code.
So just wanted to check. So can other people use this, or is this also?
Other people are using it.
Okay.
Yeah.
Questions while we are quizzing?
So Bhaskar, I was just curious, they are listening to these video lectures within their hostel rooms or whatever, which does not have the formal kind of atmosphere of a regular classroom.
Yeah.
Does that in any way impact the quality of the learning, because you're sitting around in a lungi, playing music, and then playing the video in the background, as compared to sitting in a formal room where you have your peers around you? Does that atmosphere make a difference in the quality of their understanding of the material?
Like I said, the assessment we have done shows that the median quality improves. Okay, so maybe the lungi helps them feel more comfortable.
Insist on that even for the classrooms.
Hi, very interesting. So actually you said you won't talk about it. That's the subjective assessment part. So is it also done automatically, or is it checked by humans?
No. Yeah, we have an interface for the TA or the instructor to correct it. So the app works like, they have to write the answer on paper, write or draw or prove or whatever it is, like a regular paper pen exam, but they take a snap of it at the end of it and submit it from the app itself. And there's a manual interface there is an interface for manual grading. You look at the image and provide a grade.
Okay.
Okay, let's see if at least somebody has logged in.
I have some attempt.
Yeah?
I have some attempt.
Yeah, some people they want their grade.
Okay, good. At least 7 have submitted. All right, thank you. Sorry? Password, yeah. ZJTY. We should make a password-free version, but that's under the works.
Thank you so much,
I need
sir.
to give you the mic. Hold on.
I would like to request Professor Madhavan Mukund to please present Professor Bhaskar Raman with a memento as a token of our appreciation.
So the final speaker before lunch is Ram Rustagi from KSIT Bangalore, and he'll also talk about, I mean, although the previous talk was not really about networks, but this is, again, a talk about experiential learning in the area of networks.
A small announcement. Okay. Those who are yet to give their names for the CS education workshop and wish to do so, they are requested to kindly give their names at the registration desk.
Can I start? Good afternoon. I know I have a real problem what I face in the classroom. We are waiting for the lunch, 3 sessions done. How do I engage you next half an hour? So let's see how successful I am. And by my own definition, a successful teacher is the one who puts people to the sleep. So if you can get to sleep, I think I'll be successful. So I hope if you can fail me, let me look at that part. Few resources. I and co-authored with Vaas have been writing articles on experience and learning, which are available, published by ACCS, which is headquartered at ICA Bangalore. And then I probably follow a book by Cruz and Ross, mainly because more focus on concepts rather than the mathematics. And then slides is available at my own site, rpdusiki.com/talks. Those you want to look at, of course, I'll give to ACM, but you can look at those places as well. So we already talked about it background, but I'll give you a little bit more view of what I've seen. Why do I need this approach compared to what we have been seeing so far? And then why tools are important in real life, in the field. And essentially, what we don't teach in academics and what we need in industry is what I call is diagnostic and debunk capabilities. I have long span in the industry, about 25 years. Academia only 8 to 9 years. And what I see is industry, when I look at the people report to me, they just don't know how to debug, how to diagnose the problem. And these tools are very important, at least in the networking field, to figure out where do we go wrong, how to fix up things. And then to give the concepts, I'll basically give simple experiments. And my strong belief is whatever network course we cover, whether AICTE, whether my own university or something else, 75% number could be debated, 70, 80, whatever, can be realized real life with experiments. And I'll give you a few sample experiments that I conducted, do that, which makes people to realize. And then somebody and I probably at the end, a number of list of experiments which are done over the period, over the years, so you can go and look at it. So this represents probably what is a non-premier institute and colleges. We already have seen one is the people don't have confidence to look at. If I answer, will I turn out to be a fool? Can I do something about it? Fundamentals are weaker, as we've seen, talk in the algorithm course, like people can't sort even the numbers. And in fact, last semester I taught a algorithm course. I asked the people, can you know bubble sort? Yes, sir. Everybody gave me 2 for loop. Perfect. I got 10 students on the dais. They got, tell me your USN number. Gave a piece of paper, wrote their serial number, put them in random order. Ask a student, can you please follow bubble sort and sort the students using USN number? 80% students couldn't do it. They know the algorithm by heart, they write it, they pass it, but comes to applying it, blank. This is what happens. Same thing happens to prime number. The other challenges that I've seen, my faculty keeps giving marks. I keep asking, why do you award the marks? So simple answer is, sir, if you fail the student, I give low marks, we are accountable to management, we need to take extra classes, it becomes extra burden. So why should take extra burden? Let's pass it away, and that's what you do. Problem of copy paste is so severe. I did open book exam, even though I'm affiliated college, because my UTU never say you can't do open book internals. I have no control over external. Internal I can do. So internals I try to do open book. And I gave my previous question paper, previous answer sheets what I given, and it was a POP3 protocol using email. In the answer sheet, my username and password was ISC and pass it, what I taught earlier. In the question paper, I said username is CSE and KSIT. Answer sheet, there are only 3 emails in the list. My question had given 4 emails. 20% people copied ISC paste it username and same 3 emails what is in the answer sheet. They are so severe on copy pasting. It is so bad sometimes. When I say please use your USN number to evaluate, they write the other person's USN number in their own answer sheet. They can't even change USN numbers. Given these scenarios and the mathematical background, I ask people to convert this to binary, very simple problem when you deal with networking. I'm wondering where I'm going wrong. So they convert each digit by digit. They make 12 bits. I say, how can you have a byte in 12 bits? So answer I get is 0001, 0100, 0100, this is 144. This is the reality. I mean, I can laugh at myself, but the reality is you need to get into there and figure out. So given that other challenges which non-primary students don't face is most of students are day scholar. When they're out of the college, they're probably done, and they don't have access to the lab. They can't do much about it. So what is that I can do to engage them, to use them? They don't read textbook, forget reading textbook. They don't even know the textbook. And they believe in the dictum called TLDR, too long, don't read. This is what most of the stuff is, and that's what they basically go in. And it so happened I was doing a faculty interview. 2 people who did MTech with a specialization in computer networks. And my simple question, I was not getting it there. When I asked, sir, can you give me a simple example? TCP is connection oriented and UDP is connectionless. Yes, sir. Anything that connect physically is TCP, anything wireless is UDP because it's connectionless. I said, thank you, my interview is over. I don't know what to ask you guys. So challenge is how do I engage them and do experiments. So need to do some kind of a setup which is financially viable because colleges like me are very, very sensitive to the cost. And if the cost goes up, it becomes a problem. So my challenge is how to design the experiments which they can still use, financially viable, cover 75% of the concept, and still understand it and get interested. Looking at the ACM curricula 2013, all the subjects if you look at, they are at level of familiarity. So I'm saying, can my experiment give them next level of usage, forget about assessment part of it. And thing I do is, can you learn by experience? Primarily do it, and this is what we say, the adage, I hear, I forget, I read, I remember, I do, I probably understand. So my focus is, can I do simple things by learning? And that's my whole focus is. And yesterday we said, concept is only knowledge. If I do it, can I make to the skill? And simple example, I was talking to Vaas, the differentiation between, as saying, like, how do you map the problem, PhD, as you're saying. And I asked the class, I say, my toughest question in when we're sitting in the interviews, whatever you know, can you explain to a 10-year-old child or your 80-year-old grandfather, grandmother? If you can explain to them, that means you know the subject. If you can't explain, that means you don't know. Doesn't matter what you are. With also you deal with. Other thing, first time I taught, give assignment or mass copying, and people need to discuss. So can I make into opportunity? So any assignment I give is in a team of sorts. 2 to 3, 2 to 4. You get chance to discuss, understand, because that is the creative energy. Other thing I do, my assignments are typically not shared among the students because you have a heavy plagiarism. So I had to design questions. Maybe one question could share between 2 or 3 teams, but no more than that, I know it. So I design different questions. And sometimes my question papers are based on take last 2 digits of roll number. Based on that, design a bit mask, so you know you can't even copy. People still copy looking at others, but those cases are very rare. That happens. So I look at what basically things are. To me, internet is the one we use everyday basis. We can't live a life without it. In fact, when I'm working in a startup, because I keep moving between academia and industry now and then, and I used to joke that if I need to take reference from my CEO, I just kill his internet for 3 hours. He'll be dead. That kind of way dependent on internet. My daughter, my child, at school, if I need to take a revenge, I kill internet, they'll cry like hell. I don't give them food, they're still okay. But I cannot stop their internet as of now. That's the generation we're dealing with. So we know we're accessing internet. Can I use it to do things up? And that's what it is. Concept with the tools. I'm a good chef, but if I don't have a good knife, I don't know how to cut vegetables, I don't make it. Networks, tools are very important. And I'm looking at downloading heavy tools here and there. Basic tools available. If you're using Linux, they're basically built in. If Windows, they're available freely. I talk about basic tools, Vaas, Netcat, wget, a lot of browsers, but you don't know what developer tools are. If you can use them, at least you can study the entire HTTP protocol and probably give you some simple demo, the way it works out. NC is the best tool, and I am trying to deal with that. NC is the best tool I look at because it can work as a server, it can work as a client, it can work at TCP level, it can work at UDP level, and most of internet protocols are clear text based. So to make sure that people understand the protocols, you should be able to talk to server having any client. When I ask a student, how to access a web server? Only browser, no other way. I say, why can't I access through some other means? Sir, how can you access? When I get the protocol, as long as I follow HTTP protocol, I should be able to access. And then when show them using NC or something, they know that means something can be done. So make them do it, make them learn it, and then I look at the ping and other part of it. They still have issues there. So looking at my requirement, my challenge was to have a setup with minimal cost, with what they have got, and still cover also the topics. So assumption today is almost every student has the laptop. So that I take it for granted, or at least the department would have the lab running Ubuntu, something of that kind. So what is the extra I need? Just buy 2 simple L2 switches, 5-port D-Link or T-Link, whatever costs to $400 or $300, whatever it is, my RJ45 cables, and probably if you want little extra, you can buy USB to Wi-Fi adapter or USB to Ethernet, and total cost comes to about something like 1,000 rupees to 1,500 rupees if I were to buy just 2 switches, something of that kind, and that is a one-time cost. It's not a recurring cost every time you do and work with those. And with this team, the benefit of this is, even if, because I'm a day scholar, I'm at home, I have a laptop, I can call my friend, sit together, I still have access to make things work, and I can do things. That's the benefit this approach has taken. So simple example of my setups, 2 machines, 2 D-Link switches. I can connect to internet home or connect to Wi-Fi directly, whichever way it is, or I can do 1 switch, connect it, and I'll give you examples the way I do that. Yeah, you can use a mobile as a hotspot. I don't need something extra because every kid, every child has got mobile hotspot today. I can connect using Wi-Fi. Laptop has a Wi-Fi. I can connect it. This is the little tricky which goes little beyond, but assuming that I'm not buying a Cisco router, Juniper router that no college would buy. Take a given Linux machine or laptop. You have Ethernet interface. You have a Wi-Fi interface. Just use that machine. So if you have 3 machines, I can make 1 router. If you team of 4, you make 2 routers, and you can cover basic routing stuff using this setup. And that's what I do in reality. And I'll give you the examples. How do I deal with doing this? Few examples, then give you a list at the end. So first thing we look at the network layers. Everybody knows what the network layers are. And we start with so-called internet. So first time I look at how to engage. And we say you all know internet. we all know, say, www something. And just to engage, I said, look, when I went to do my master's at IC Bangalore, my folks at home told me to keep away from 3 Ws. We are always using 3 Ws today, but 3 Ws asked me to avoid was wine, wealth, and third I leave you to guess. So we'll look at ping Google. So can I engage all the 4 layers, what the layer means? They tell me, but what is the meaning of encapsulation? When I send a packet, can I look at which data, which byte belongs to which layer? I get blank faces. And that is where my tools basically help us out. So I can do ping, I can do chat, and if you do ping, I look at layer 2, layer 3. If I use NC, I can look layer 2, layer 3, and layer 4. But if I access Google or any college website, I look at all the 4 layers, layer 2, layer 3, layer 4, and layer 7, and you can see actual packet that happens, and that probably you see in this demo. So this is WARSARC capture. I'm not going to get into details of how to use WARSARC, but given that you have WARSARC, so if I look at this, my layer 7 details, and these are the packets, the layer 7, and then this get encapsulated with layer 4, and this is the layer 4 headers, so encompassing layer 7, then I have a layer 3 encompassing my layer 4, and then layer 2, so I can look at everything that goes in. So given that, if I'm using ping, you'll see only layer 2 and layer 3. If I'm using NC, you'll see only layer 2, 3, and 4. But if I use browser or anything else, I can see all the layers, so at least they understand what happens. The importance of WARSARC is a lot more bigger than, and I'll give few instances. Lastly, I was working with a startup again before joining KSIT, and my boss told me, Ram, I have an interface problem, my client is not working, and let me not give the names, but this is a bigger client in the US, 10 people looking at there and 10 people team in Noida, almost 3 weeks over, tons of email exchanges, protocol in my Java client works, C client doesn't work, something wrong. Then I told the team, can you give me WARSARC capture? I returned the code in the email, sir, what you're asking is waste. We already tried it out, it doesn't work, only gives IP addresses. I said, guys, you have been working for the last 3 weeks. You're not able to solve it, give me what I want. Then they gave me WARSARC capture. I analyzed it, and within half a day looking at it, all was needed was, how can I map the port number from, rather than 80 to something else, to determine the web protocol and figure out what was going wrong. Other simple example where I use is useful, prior to other company, I used to work with a smartphone company, and problem was unique. It's an Android phone, download the image. If I'm in the office, image upgrades work fine. If I'm in the data center testing, absolutely no issues. But the moment client uses at the home, it fails at precisely 2.1 gigabyte. Between 2.1 gigabyte to 2.2 gigabyte, but download fails. Total image is 2.5. Test setup, cloud center, office, works beautifully. I don't know what to do. Okay, the only choice is look at WARSARC capture. I had to ask my team to give me WARSARC capture at home. My dump was about 10 gigabyte. It took me about 2 days to look at it because I looked at all data and finally figure out the role was played by TCP 0 window size because my connectivity from home to the next point, the website load balancer was 2 Mbps. Whole thing was in cloud setup, that was 100 Mbps. And because load balancer was a split connection, so load balancer to the application server, TCP public gets full, they retry, after 12 retries, they're closing the connection, which doesn't happen in data center, it doesn't happen in office because my speed is high. Only at the home, problem happens. So tools are very, very important to understand. And I tell my class, if one thing you can learn from my whole semester, if you know how to use WARSARC, I think you're done. You don't need to understand format. That's the importance I give to the WARSARC tool. I'll give you the HTTP protocol, how simply you can do that. I just probably switch over. So you access something, look at the headers, you access, and you can see anything I click, I can do an access. You get an access, you get the response, but developer window you click, and you can actually see all the request header, response headers that goes in. And that means you can analyze looking at, so this is the real data because they're accessing. To make it interesting, I say them, you all passed from school, almost every school has a website now. Look at, analyze it, tell me how many images they are there, how many CSS files, do some analysis. Because they're old school, old memory works, they try to use it, and partially it works. And that's the assignment I give, because within my choice, I don't have too many things I do it. And then I ask them, there are different status codes that just now gave about 2 weeks ago. Can you give me status code? 50% people wrote a HTML page, status code 200, status code 201. I said, this is not what I wanted. You should know the protocol working, so you still need to understand the way things work out. I already talked about it, so let me. Again, the notion that web server can be accessed by a browser. I said browser does two things. One is download, and one is rendering. I can still download it without a browser, as long as follow the protocol. So use wget to test it out. And to illustrate how does wget work, to even the headers work, 301 redirect, I say, if you are really interested and if 200 milliseconds of delay is important for you, all of us has our web homepage as google.com. If you change it to www.google.com or better, www.google.co.in, that 200 milliseconds will help you. Because the moment you access google.com, first thing it does is it redirects to you status code 301 mode and makes a new access. You can understand by, we all use Google, so use the real life example that we do in daily life, can I correlate? And that's where I go to, and then you can understand it makes a new access. I'm not going to display that there, and then see what happens. So that way you can see, and you probably don't know if you look at trends, 75% web traffic today gets redirected at the first URL level. So if you want to get a better response, you probably look at. Next challenge was, as I said, TCP. I'm giving you one example from each player, then you can look at. I have a bigger challenge in ask anybody in the class what TCP is, just guaranteed delivery. And I have a tough time explaining difference between reliable delivery versus guaranteed delivery. And how do I demonstrate that? What is the reliable means or what is the guaranteed means? In fact, I tell them, I have a network which gives you, a network guarantees me that it will be in sequence delivery, it will be uncorrupted packet, it will be no lost packet. Can I still use UDP? People say yes. I should miss out one more thing. I never said my network cannot duplicate packet. So you still have a problem there. So understand the key concept. Same way when I do TCP streaming, what is it I need to explain? So my simple explanation is, let's say I need to supply water to you. I lay a fat pipe. At the end, whether I'm putting water through a bottle or through a bucket or through a mug, what you're getting is a drop by drop. Streaming is nothing but I'm getting byte by byte, and that's what streaming is. So can I really understand what streaming means? So my simple setup is connect two laptops with two switches. Right, one application client sends 100 bytes every 2 seconds using TCP connection. My client receives 60 bytes every 2 seconds and then displays it. So what my display would be? So first time I'll get A's. So client is sending 100 A's, 100 B's, 100 J's. I receive, I'll see first 60 A's. Then because it's streaming, nothing is lost. TCP is reliable. It's maintained on order delivery. I'll get 40 A's and 20 B's. And next I'll access third one. I'll get 60 B's and then 20 B's and 40 C's. And then you understand. And as a variation, I say, rather than making 60 byte, make it 10 byte or make it 1 byte or make it 300 byte and see what really happens. Using the same concept, how do I enable, imply you what reliability typically means? Same experiment, but variation is, because I'm doing every 2 seconds, starting around time 0, it will go up to 18 seconds. Let's say 7 seconds, I break my connection. And reason I need this is because if I were to connect directly, Technically, I can do directly, but the moment I break the wire, my network interface would go down. And because interface goes down, my application will also shut down. I don't want that to happen. I also need to mimic what happens in real life network. So this mimics my internet. Break the connectivity at 7 seconds. Restore after 12 seconds. And nothing else changed. Now server is 300 bytes. Just to give you a concept of streaming. Now when you read, what happens? So first 0, I get 100 bytes, 100 bytes. Now between 8 to 12 seconds, there will be no display. And that is what most of people says. Next packet, I'll see only the G's or H. But since it's a streaming protocol, it's a reliable protocol, and I should see all 300. So at 12 plus seconds, whenever you connect, you'll basically see all 300 bytes together, and then you're back to 100. You can also explain what the retransmission is. If you look at the client side wires are, you look at the server side wires are, at 8 seconds, it will transmit 100 bytes. At 10 seconds, it will transmit 200 bytes. At 12 seconds, it will transmit 300 bytes. All of them will fail, and next time it transmit, it will receive only one 300 byte single stream. That's where the TCP implemented streaming. So using simple experiment, you can explain them the streaming, you can explain them the retransmission, you can explain them what the recovery basically means I'm covering, and even the timeouts you can look at. If I don't get it, my timeout increases. I keep retransmitting, looking at those. Same setup to differentiate between UDP versus TCP. Same setup again, I just run UDP protocol. And we say UDP is message oriented, but how do I really see it? So again, I said 100 bytes, no change. I read 40 bytes. First answer is, I'll read 40 bytes. Next, I'll get remaining 60 bytes. No. It's a message delivery. I got it. Application delivered like I'm through the pipe and sending you bottles. You're receiving a bottle. Now, whether you read one, sip one drop or sip entire bottle is up to you. Pipe is not going to give you a next bottle. So next time, you'll get B's and C's. And if you don't read 100 bytes, you lose all these 60 bytes. So UDP delivered a message is up to applications to figure out what my write buffer is. Same experiment to look at what UDP packet loss is. I do same experiment, I do TCP, break at 7 seconds, restore at 12 seconds, and then what happens? First 3 up to 6 is fine. Now since UDP there is no retransmission, if you look at WireSAR, it will transmit at 8 seconds, 10 seconds, 12 seconds, but since there is no link, packet would be lost. There will be no receiver, and so till this 6 seconds, there will be no receiving, and then next I'll basically receive H. So I will not receive a packet E, F, and G, and that indicates UDP packet loss, what we really do there. So again, simple experiment, you can do that. Same thing I can do with IP subnetting, use a mobile phone hotspot, take 3 machines to connect, define their IP addresses for the VLAN side, connect them Ethernet because I need to, if I don't connect it, my interface would remain down. So connect only for connectivity part, assign the different addresses with different masks, and then, so this is longest prefix match. So if H1 has to ping this address 51, even though this network belongs to S2, packet would actually go to S3. And by defining the routing table with longest prefix match, you can actually demonstrate how the longest prefix match works. So point is, if you do with hand, you play with it, you certainly make a mistakes. But once you learn, do things, you bring a aha factor, look, I did learn something, that's what happens. We all teach about theory of layer 2 self-learning. We make a MAC table, port number, return visualization, can they really see what really happens? So using the same concept, again my basic setup, let's say I just send one packet, I will learn, get a response, I'm fine, no issues there. Now, I connect one more link. And let's say I'm sending a packet, a simple UDP packet. Now, how many packets my C would receive? Or C is sending only one UDP packet. How many packets will see HS? Normal answer is 1. Actually, because of this continuous, when I receive a packet, I send this out and repeat it back. I'll keep sending infinite number of continuous packet receiving, and that is what I call flooding. You do that, they understand flooding. And to make further curious, what happens if you do this? 5-port switch. This is what I call a broadcast store. Now what is happening here? Each packet I sent, I'm generating 2 packets. Each packet generating 2 packets. And if you see after 2-3 seconds, everything comes to a standstill. This is called broadcast store. The drawback I tell the students is, please do that limited setup. Because I've seen in PS, people try to connect 2 wireless jacks in the lab. And because we don't have a smart switch, no spanning tree runs, whole network comes down, and IT blasts me, what the hell you have done to my college network. So I need to live with those, but still better learning R&D doing this rather than saying, let's not do that. So in summary, what I'm basically saying, I've done these experiments over a number of workshops, probably across India, including Jammu to Andaman Nicobar to East, Augusta, and Bangalore, the most focus. When I deal with the students, they're interested, and even for the lunchtime, and some lunch is getting cold, people don't come out. They say, sir, let's do this, we'll take 10 more minutes. I have to pull a student to come out. Faculty, I have mixed experience. Half the time they come for certificate, they don't care about what you're teaching. They say, can I got certificate? Thank you. So I don't know how to solve that problem. Maybe you can correlate to it that what happens. And then, because of this approach, I can see the gleams on the face of the student, we learn something, and they appreciate. And because they have done it, they could correlate, they could work it out, and because they've done it, it is no more a try, no more roboting. They can see what a protocol means. In fact, if I need to go to assessment level, if I want to try it out, we can say, design our own protocol, write a wires are adapted to the protocol, and see your protocol dissection. Technically speaking, if you know Lua language, it'll probably be half a day job. But if you want to write the whole C, it will take you maybe a 1-month project. Again, depends. Like, it depends on creativity. Like people ask me, sir, what should I do for BTech projects? I tell them, even if you were to say, I'll write printf hello world, I'll justify it to be a full semester, 3 people BTech project. So how can you do this? A 10-minute job? Manaka, yes. All I'll say is, don't write heads include stdio.h. Now give me printf and work it out. That becomes probably 3 months. Then you know how the whole device driver is. You do what you want, I'll tell you what I need to do. You understand the whole system, and there's a much tougher project than doing a regular work. So same way you can be creative, doing whichever way you want to do that. So probably I'm just saying, when you do that, you learn. And I basically, my benefit is, I don't look at the feedback. When I see people don't come out at lunchtime, they still stay in the lab. In the evening, I'm supposed to close at 5. My lab assistant is waiting. But sir, 10 more minutes, I know I got my feedback. I don't need to get a paper feedback to know how good I am or what the good workshop is. And that's across the board. And then, but even again, when people go to the interviews, something what I said, one student wrote me, sir, I got a job in Google mainly because I could tell them how ARP works that nobody asked me. When you type google.com, what happens? Can you define the whole series of protocol? In fact, I asked, I can teach the entire network course by answering just one question. When you type google.com, what happens? Answer to that one question, I can cover the entire network course for the whole semester. Because they don't know everything else what you need to do. So people can correlate and they work with that. This is what I do. And then probably some people say it's interesting work. Some people say, never thought I'll do network, but now it's interesting there, something of that kind. So with that, I think my time is up. So probably my time is up, I'm stopping. What I'm trying to do is, I'm giving you key to unlock, search it out, find your own answers. And then probably list of experiments which I had done, defined over the period of time. I've given only 4 examples there, but tons of those. And anyone like to interested in, I can always help you out, figure out. Just be innovative, think through. Affiliated colleges have problems, but if you engage them, you will do a better job. Thank you. Those who want, they can ask me the questions, tea break, lunchtime, whatever, I'm here.
Yeah, so we can probably take a couple of questions before lunch, if anybody.
Wonderful talk. In fact, this is my domain. I had been breathing this for the last 40 years, and I have been teaching even this topic. So one of the thing, I'm seeing is the students, doesn't have the vocabulary of networking. They always talk about packets. So starting from layer 1 to level 7, we go frames, packets, then segments. So in spite of doing all these Wireshark based sniffing and all those things, they still mix up frames for segments for packets. So that's a basic issue. The next thing is take an Ethernet frame. I always ask, why this protocol is designed like this? Why destination address first? Why can't, source address first? So there is no opportunity given to them, to question, why the protocol is designed like this? Why not? Because the previous speakers told, they always take, this is the protocol and this is the way in which we work.
No, so I'll come to that.
Yeah. So that why not in a protocol? That's something which we need to really focus. And then the right networking vocabulary. That is something which need to be focused. And the other thing, the last point I just wanted to highlight was all the experiment setups are all based on layer 2, and then you mentioned Juniper routers are costly. Maybe 800 rupees broadband home router could be doing the layer 3.
But you cannot do playing with it. Changing configuration, running routing protocol may not be. So use a laptop to do that. I'm just saying.
Yeah, laptop or Linux.
That's all. Linux. So my router is not Juniper. It's the laptop router.
Oh yeah. Okay, thanks.
Yeah. So coming to your answer, Ethernet. In fact, I ask a question differently. Why it is that only in Ethernet, destination address is the first field, whereas you look at the IP layer, look at the transport layers, source address is the first field. And then probably get into deeper switching, which doesn't belong to the normal basic network course. It belongs to what is called a cut-through switching. And that's where you get into that. In cut-through switching, which goes in data center today, because I don't want to store the whole frame, today all we are doing is store on forward switching. And at the earlier time, performance was important. So rather than looking at the whole packet, can I look at the address and forward it out? So my destination address is the second field. I still look at 6 byte extra. Why sort of waste that time? And that's what goes in. Now coming to another question there, why it is that a minimum requirement of 64 byte for Ethernet packet, but there is no limit for any other protocol there. So you look at those fields, again something called the runtime, to look into propagation delay. An example I normally give is, let's say this room is too long, and the room is 300 meters long, and that I'm asking somebody, 2 people want to ask you a question. Somebody asked me in the front row, somebody asked me the question at the last row, how long the person at the first row should speak so that there is a collision there. So you need to know that speed of sound is 330 meters per second. It will take probably 1 second to go, 1 second to come back. So unless I speak in about 2 seconds, I won't know that there is a collision there. Same with a network, so get into those details. But I think that becomes a topic, so I can cover those advanced topics, not in the basic part. Sorry if I answered your question or no.
Hello sir, myself Amit. How about using GNS3 as an emulator to capture?
I said if you have no choices, simulators are good, but in my word, nothing to beat real life experience. You see real access, you use real internet every day, and computer network is one topic which actually makes it difficult because it's a combination of 2 disciplines, computing and communication. We say communication engineering, electronic ECE, we say computer science. Network is the one that covers kind of both. So it becomes, yes, you can use those things if you don't have access, but if I can see real things working, nothing like it. That's my gut feeling. So I believe in real working rather than simulators. If you can't do it in real life, then do simulator. If I need to teach you OSPF or bigger routing, I probably use simulators for those. But the Cisco packet tracer, GNS3, whatever, that is fine, but not really limited to real life.
Okay, thank you.
Thank you.
Thank you so much, sir. Now I would like to request Professor Mukund to please present Professor Rustagi a memento from our side as a token of our appreciation.
And don't run away, there's a surprise.
Thank you, sir.
Sorry for keeping you from lunch, but just a very quick announcement which I had promised Nildhara that I would do earlier, but as usual forgot, is that I wanted to bring to the attention of this audience that we will be conducting the IRIS symposium. And IRIS is a symposium for PhD students and get a sense of community within the Indian context. And this is being held annually from the last 2 decades or so. The last one was held in Cochin. The next one will be held in IIT Gandhinagar, and Professor Neeldhara Mishra, who is part of the computer science faculty, is spearheading that entire effort. So please encourage all your PhD students to participate in the symposium, and those PhD students who are here, please think of enrolling there. The submission website is up, and if you need any more details, just type on Google with Professor Ustagi's permission, IRIS. You'll also find a lot about the networks as well as about the IRIS symposium itself. Neeldhara, do you want to say anything else? Okay. Now that I've earned my lunch, let's break for it.
A couple of announcements. Kindly note that the participants have to move towards the entrance to board the bus at 3 as soon as the panel discussion gets over. The tea will be provided at DCST office building during the CS education workshop. Second announcement, the participants who have bought the tickets for the cruise will have to board from the DCST building and go directly to the jetty. Good afternoon, everyone. Today's panel discussion is on the topic autonomy as an enabler. Our moderator for today is Professor Viraj Kumar from IISc, Bengaluru.
Thank you so much. So perhaps we are preaching to the converted already. I'm just curious, how many people here are from institutions that are not autonomous? Yeah. So that is a smaller number, but anyway. So I'm really delighted. We have a very diverse set of panelists. So I will introduce them and then request them as I'm introducing them to come and seat themselves. We have 2 ladies and 2 gentlemen. Let's see if we end up with gender segregation or not. I leave it to the panelists to decide that. So first I will introduce Dr. Nadarajan. He's the head of the Department of Applied Mathematics and Computational Sciences at PSG College of Technology in Coimbatore. And he is coming from an autonomous government-aided private college. Dr. Nadarajan. Then we have 2 panelists from autonomous self-financed private colleges. Dr. Chitra Babu, who I understand is also an alumnus of PSG Tech. And she is the head of the Department of Computer Science and Engineering at SSN College of Engineering. And she's a very familiar face in ACM. She has served on the ACM India Education Council for the last 4 years. She's a member of the ACM India Executive Council, ACMW India Executive Council, and she's also the Secretary of I6C. Dr. Deepak Sharma is also a department head of computer engineering, and he's at KJ Somaiya College of Engineering in Mumbai. And he also serves as a member of the Syllabus Revision Committee at the University of Mumbai, so he brings that perspective as well. And Dr. Shraddha Kanwar is an old colleague of mine. We were colleagues in Rajasthan together. And although currently she is in a company, she is an academic through and through. So she leads the educational research efforts at an edtech company called iNurture. Okay, so our task is to discuss 2 broad themes, autonomy, the good stuff, and autonomy, the risky stuff, right? The potentially risky stuff. So as I said, I think many of us are from institutions that are autonomous, and we thought it would be good to begin by taking a look through these institutions here at some shining examples of how best to leverage autonomy. There are autonomous institutions, of course, that don't do much with autonomy, and then there are institutions that, because they don't have autonomy, do have their hands tied, although as we saw in the pre-lunch talk, you know, if you have enough motivation and enough expertise, there's amazing things you can do. So let me begin by asking Dr. Chitra first, who represents amongst the institutions here, the institution that most recently transitioned out of the affiliation system to autonomy, I believe in 2015, or you said, or was it more recent than that? When was the last year? So as recently as last year. So Dr. Chitra's views are very fresh on this. And so Dr. Chitra, I would like to begin with your views firstly on what autonomy has enabled SSN to achieve.
Thanks, Viraj. Yeah, so till last year, our college was affiliated to Anna University. And last year we got the autonomy. Even now we are affiliated to Anna University. He's correcting me. So, the thing is, actually, I will start with the curriculum. So in the curriculum earlier, either we can have a theory course or we can have a complete practical course, but we cannot have a integrated theory cum practical course. So that was not possible when we were non-autonomous. So when we became autonomous, so we wanted certain courses to be in this category, like theory cum practical courses. So it may be either because you cannot accommodate a full-fledged practical course in your curriculum because of credit restrictions, or the course may not need a full-fledged lab course. So in such cases, we wanted such kind of integrated theory cum practical courses, and we were able to do that. One example is earlier design and analysis of algorithms used to be a pure theory course. There was no associated lab. For data structures, there is an associated lab, but algorithms, there is no associated lab course. So that means they will never be able to actually implement those algorithms, or some things which were talked about in yesterday's that session, code shift session, and also they will never get to have a feel of how do they implement efficient solutions and all. So that is possible now, but we still are, our first batch is yet to enter into that fourth semester, which is when this course is coming. But currently in the third semester, they are doing such kind of a course, Unix and shell programming. And based on that feedback, I really have a very positive feedback from the both faculty as well as students, that earlier, suppose if it is a pure theory course and you are showing some demo, then the students are not that much attentive. But now that there is a lab component integrated with it, then they are really paying attention to that, and all that is, even though it is only actually a 2-credit course, 2 theory classes and 2 lab sessions in a week's time, but they are putting lots of effort and it is becoming a very effective course. Actually, they are learning all the shell commands, awk and everything in a very effective way. So that is one plus point. And also earlier, these kind of MOOC courses, NPTEL courses, the students have to take over and above their curriculum thing. They were not given any credits, but now at least 2 such courses can be substituted for either professional electives or open electives. So that is a plus. Now it is, that just at that time that transition was made for the regular university also. So actually that is there also, and these value-added courses also are a possibility. Like you can have a 15-hour course by some industry person coming in and teaching, and that will have a 1-credit thing over and above whatever credits you are accruing. So this is in terms of curriculum. In terms of assessment, there is I'm seeing a major plus. Especially, that's why I wanted to show a sample question paper, and that too in terms of a lab exam question paper. Earlier, when we were non-autonomous, we have to, the university will send a question paper, set of question papers for the end semester practical, and you have to choose those problems only. You cannot choose any problems which the teacher, if they want to give some tougher problems on some other thing, that is not at all possible. And as you can see, these problems are like very simple problems, and that too, there is no granularity at all. So here, there is only a and B, and both are very small programs, and for this, 100 marks are allocated. So 100 marks, most of the people will finish the lab exam in half an hour and then leave. So the students feel let down that throughout the semester, you are teaching so many hard things and so many difficult exercises, and finally this is the kind of question that comes in the end semester exam. So it's very difficult to motivate them to do hard problems at that point in time, or even if they are doing, then at the end they kind of feel very disappointed that these are the questions which are coming at the end. Can you show the other one? The autonomous thing. Yeah. Yeah, this one, yeah. So this is again a programming in C Lab's last semester's question paper. So here, if you see, this is actually one question. For one student, they will get this, all these 5 questions they have to write, and together it is adding to 100 marks. So basically, incrementally, so suppose they are doing something partially, they will get some credit, and you will be able to assess in terms of different concepts, and that is possible now. Instead of asking one very simple question and it is like a binary, if you get it, then you get the complete marks, or otherwise nothing. Of course, the later will never happen because it's such a easy problem, so all will solve. So here there is a possibility of giving some challenging questions, and also it can cover different concepts of C programming, the entire spectrum. So that way, we were able to make a huge difference in terms of setting the practical exam question papers. And of course, in assessment, in theory also we have now, earlier it used to be 20 marks for internal and 80 for external. Now we have 40 and 60. And in that 40, 30 marks are meant for this continuous assessment test. So 2 out of 3. Best 2 out of 3, but then you get that cushion of 10 marks. The teacher can devise their own assessment methods, like they can have a assignment or group project or quiz or whatever it is. In the beginning of the semester, they have to tell that this is what they are going to use for the 10 marks and then stick to that. So that way, there is a freedom for the teacher to assess. Even though it is 10 marks, that is also making a huge difference. I talked to all the faculty members, and it seemed to be really making the students serious about attending the classes, and attendance has improved, and everything has changed in a positive way.
Thank you. So we'll take questions towards the end. I just want to now bring in Shraddha into the conversation. So Shraddha, I think first it might be useful if you can briefly describe what iNurture does in this space, trying to link academia and industry. And then if you can just tell us your views, given that vantage point, how does a graduate from an institution that is not autonomous fare relative to, because it seems to me that what Chitra is describing is extremely restrictive, and we all know that at some point. And so are you seeing that graduates from institutions that are not autonomous are actually suffering in comparison? Just your views on that.
Thank you, Viraj. Well, what we do essentially at iNurture is to try and address the gap between industry and academia. So we work very closely with industries to understand what are the limitations in the curriculum that we are, having in the colleges and the universities, and then work backwards to design it. Yes, from the outcome-based, outcome-based education perspective as well, but also to bring in some credentials. So we call it, the pre-degree model, where the student graduates with a degree, but also acquires the necessary competencies which are relevant for the 21st century. And of course, the curriculum is the basic, the fundamental block that we are trying to look at. And if you talk about computer sciences or anything related to information technology, for instance, I think there is a lot of real-time action that is happening, and sometimes it becomes very difficult to have that dynamic approach and keep on sort of refurbishing the curriculum. But the intent is to do that, and in that context, when we interact with many university partners across India and internationally as well, now, I think it's very encouraging to see a lot of people coming up with that, what I was describing, Viraj, that intellectual valor. Yes, we can make a difference. Yes, we want to experiment. We want to do things differently. We want to be definitely making sure that the norms, etc., are respected. But we also want to rise above those standards and do something which probably presents the university or the college as a thought leader in that particular space. So from curriculum to the pedagogy, because I think what happens in the classroom is actually the the whole aspect of the shift that is going to take place in the way the students are learning and acquiring new skill sets. So that's a very, very important area. And there also the whole design, like ma'am was describing about assessments, for instance, the insistence on assessment for learning rather than just evaluating after the process has been completed and looking at the results is something we're trying to make a shift towards. So a lot of universities and colleges are encouraging. They want us to create frameworks which are based on those assessments, which in bits and pieces understand that, it's not just, for example, in computing, it probably might not just be about the linearity of the thought process or the imperative question making, but more about understanding the logic and, how that is applied. And for that, introducing computational thinking or problem solving or those elements, etc., are very, very essential. From an industry's perspective, we do find, to answer your question, a lot of interest in students who are individual performers. So that's very encouraging because our university's partners are not really, the IITs and the creme de la creme. So we have universities are doing extremely well. But when it comes to inducting students who have a certain competency, we do find during the hiring process that a lot of our students who are probably faring well as, having upskilled and cross-skilled competencies doing better and getting better packages. Whether it's an MTech in data sciences or a BTech in artificial intelligence or machine learning, blockchain, the whole aspect of industry looking forward towards getting people who have that individual brilliance and demonstration of learning evidence is something which we are finding it very encouraging over a period of time, although we were hearing a lot of it, like, Google and Adobe and all are hiring people irrespective of their academic affiliations. We are seeing that happen now in the last, at least in the last hiring cycle. If I have to give you an answer on differentiating between, the autonomous and very difficult to give, a statistical sort of reference, but just anecdotal, sort of understanding, yes, we do find a difference. Again, it depends upon the institution, how much of autonomy have they allowed and how are they themselves self-governing it. Because I believe autonomy is about higher responsibility and raising your own standards. So some of those colleges are doing exceptionally well and creating that value through their learning experience. But in some cases, there we find that it's just to, brand it and maybe it's not happening as it should happen.
Right. Thank you for that. I mean, at one level, I find it very encouraging that, companies are willing to look at students as individuals rather than chasing a brand, and I think that's increasingly the case. Having said that, if institutions are aligned to this more, through their DNA, that's much better. So we have, now I will switch over to Dr. Nadarajan. I'll get your slides up for you. But the next two panelists, Dr. Nadarajan and Dr. Deepak, will start also leading us into the second theme of our discussion, which is, as I said, some of the potential hurdles. So not only some of the good things, but also the risks of misusing autonomy. And one risk that we have discussed amongst the panelists that I would really like them to try and highlight is the concern that we may, over cater to the industry through our autonomy for the current jobs. Because once the student is out of the door, I've got my placement, she's got a high pay packet, I can put these wonderful numbers up. And so perhaps there's an incentive to lean over and sacrifice the long-term strengths and developing the long-term capabilities of the students in the interest of chasing those numbers and those metrics. So Dr. Nadarajan, please.
Thank you, Dr. Raviraj. Very good afternoon. I'm an academician because there is a joke. There is a joke about teachers. Mother is capable of making one child to sleep at any time, and teacher is capable of making many children to sleep at any time. That is an example of one-to-one mapping. This is an example of one-to-many mapping. So people talked about interactive teaching, active learning, so many things. So first agenda is people should not sleep. We should not make them to sleep, right? Okay. Anyhow, thank you so much, right? So PhD College of Technology is the first engineering college which became autonomous in 1978. Much before it became autonomous, they had the vision of introducing amazingly great programs. But I restrict to only computer science, BSc Applied Science program. When Tata and Sons Chairman Chandrasekhar is a BSc Applied Science graduate from not PhD College of Technology, CIT. So that was a vision of PhD Tech that they introduced in 1971. Because only 8 engineering colleges were there in Tamil Nadu, they thought about what there are other students who are eligible to enter into engineering college. Why can't we give an opportunity? Maths, physics, chemistry, and engineering. So that program is much tougher than what is that BE program, right? Okay, right. So when you come to what is that computer science, 83. Department of Electronics identified 14 institutions in the country to start MCA program. PhD is one among them. So we have been doing this. And in the meantime, we don't have that time what is that BE program. 85, PhD management thought about introducing a program, BSc Computer Technology, by bringing 2 great people in the country to frame the curriculum. One is Professor Rajaraman from IIC. The other is Professor C.R. Muthukrishnan from IIT Madras. Because he became a professor when he was very young, 30, he became professor. Right? So that was a vision actually. Much before BE Computer Science came, PhD Computer Technology. 85. 83 MCA, 85 BSc. And all are doing amazingly good. And over a period of time, teaching this, we found, right, 6 years is a very long period for a student to spent in computer science education. 3 years undergraduate, 3 years again MCA program. 1996, believe it, we submitted a proposal to AICT to start a 5-year integrated MCA. From PhD College of Technology, we sent a proposal. We can have a 5-year integrated MCA, which will be much more meaningful rather than having a 3-year undergraduate BCA or BSc Computer Science, then what is that MCA. It so happened it was not accepted. Right? It is a blessing in disguise for us. We have our own program in 97. It is MSc Software Engineering, 5-year integrated MSc Software Engineering. No other institutions are offered a program on software engineering in 1997. No other institution in the country thought about a program on software engineering. We introduced 97. First batch came out in 2002. That was the worst period, 2001 to .com burst, right? Amazingly horrible period actually, or what is that? But that time, only 30 intake. All the students got placement. And that time, the college woke up. Oh, there is a program which is doing much better than any of the other programs. This is how we started, the 5-year integrated MSc program. Many times people are having a complaint, whether it is, MSc or BE. I used to tell actually, what is the difference between these two? That is having 2 letters, this is having 3 letters. That BE is having a BE and this is having a MSc. Because certificate lost the power long back. Only knowledge is powerful. Because this is 2000 years back itself, Thiruvalluvar taught to distinguish between a certificate holder and a knowledge holder. Visionary, amazingly a great visionary. I am teaching object-oriented programming. I talk about abstraction and polymorphism connecting Thirukural. Every Kural is an example for polymorphism and amazingly good concepts of abstraction in Thirukural. Fantastic Kural. With one word he has played, right? Differentiating between certificate holders and knowledge holders. Kattarul. That means those who are having, people who are talking about 16 lakhs computer science graduates are coming out. Thiruvalluvar has not accepted them as, computer scientists. They are computer science degree holders. There is a difference between these two. He identifies, he defines Kattarul, Kattar Anaparuvar. Thiruvalluvar defines who is knowledge holder. Right? One who is able to talk about object-oriented programming or networks in a crowd which is compatible with networks. Right? Kattarul, Kattar Anapaduvar, Kattarmun, Katta Salasolvar. So we should be able to train, groom our students to talk about a subject. I teach 2 tough courses. One is stochastic models, the other is object-oriented programming. If you are not able to talk about the subject half an hour in a crowd which is compatible with the subject, don't tell that you studied under me. That is a commitment, right? So this degree, BSc, BE and MSc, lost a charm. Industries are now behind what is that, this program.
You have to keep an eye on the time.
Yeah,
also, so
yeah. Then in 2007, we started another program. Teachers are doing good, and the students are also amazingly great. We can provide still a better program, that is MSc Theoretical Computer Science. And I have to tell a story. We are connected with now Professor Venkatesh Raman, Madhavan and all. That time, I never heard about Professor Venkatesh Raman. First time when we, advertised for MSc Theoretical Computer Science, a boy from, DAV school, he met Professor Venkatesh Raman. He went to Math Science and showed the syllabus. He said, amazingly a fantastic syllabus. In the meantime, you won't believe, I met Professor Rajiv Motwani in Stanford in 99. He gave the book Randomized Algorithm to me. That time it was Latin and Greek for me. But we offered randomized algorithm and approximation algorithm in the course. He said that the curriculum is fantastic, but I have a concern whether faculty will be available to handle that course. We have proved we are doing amazingly good. Right? 2007, theoretical computer science. And after 1 decade, then 2015, for the first time in the country, after +2, we started a program on data science. But you see, in all the places, we took care of only one thing: make the program more science-centric, not tool-centric. Yesterday he asked about how mathematics is introduced, whether people are giving importance. Hidden Markov model is taught hiding Markov models. Right? Markov reinforcement learning, Markov decision process is taught suppressing what? Markov process and dynamic programming. So from where actually they will be able to understand all the curriculum. You look at our curriculum, it is available in our website. We started, the curriculum will be able to see 3 components: content, delivery, and evaluation. That we are doing amazingly. The last slide.
Sure. So somehow.
Yeah.
So this is the last slide?
Last but one. The PhD slide. The next one.
Next one.
Prior. The PhD is.
This one?
Prior to that.
Prior to that. This one?
Yeah, this slide actually. I talked about theoretical computer science, right? And they're all, some of them, when we started the program, we have only one line objective. Students should be absorbed by top-notch IT industries like Google, Facebook, Microsoft, etc., R&D divisions. Or somebody is interested to go for higher studies, there should be opportunity. The first batch student got a PhD. Sridhar, he passed out in 2012. Then Akshaya Mani also got PhD. Just recently she got PhD, and now she has joined the University of Waterloo for postgrad. The other girl, Vaishali, she just joined for PhD. I have to tell something about her. When she was a student, I think to some extent groomed by Venkatesh Raman also. When she was doing her final year, she didn't, Goldman Sachs came for campus interview. She didn't appear for the company. But Goldman Sachs conducted an All India, programming contest. She stood 4th. But their prize award and all for only first 3. She stood 4th. But these people were asking, why this girl has not appeared when we came to campus? That was a day 1 company. They continuously asking placement office, right? Why Vaishali didn't appear for, Goldman Sachs? Their stipend is 75,000 rupees, monthly stipend, right? But she said, no, I am not at all interested. I am going for academic. Now she is doing PhD, but no, there is no stipend, nothing. Now he got full scholarship. Okay, so, this is how about the success stories of our program.
So we really
management vision is
on.
only just management vision is each program is having only 40 intake. It is not more than 40. It is not like engineering program where you are having 60, then 20% lateral entry, 72, absolutely no, just 40. That is the reason why I have put in the title autonomy, vision and accountability. The vision is the management vision, accountability is how we execute things. Thanks for the opportunity.
So, sorry, can someone just help me with where this other set of slides have gone? I can't seem to find them. So someone here who, because I don't know where they've put the slides. So Dr. Deepak's slides, are they, I don't know, can you find them please? So I don't know where they put them. Can we just open up PowerPoint? Maybe it's, I don't know, it's on the, or Deepak, since we are unable to find this, do you think you can just, yeah, okay, so let's just do that. Okay, so similarly, Deepak, if you could discuss those two themes from the perspective of your institution.
Yeah, I'm Deepak Sharma. To sum up what my other panelists have said, I'll focus on limitations of affiliated systems, and then the challenges that we faced and how we overcome those challenges as our success story. So I'll sum up the limitations as one size fits all. In affiliated system, one size fits all. Whether you are a college in a remote place or a rural place or an urban place, wherever, whatever curriculum is there, it is across the entire university. You have minimum flexibility with respect to your examinations. Your own vision mission, you have to fit according to what curriculum you have got, what course outcomes and program outcomes you have got. There is limited transparency in your systems and processes because everything is handled at university level. So students are not aware about their exams, processes, papers, and so on. There is very limited scope to developing students' hobbies, sports, arts, and musics in affiliated system, as well as the revision frequency is very also very not frequent. So syllabus revision also takes very long time. So mostly we teach outdated technology to our students. With respect to examination, the focus is on theory end semester rather than evaluating their competencies. Of course, there is uniformity in uniformity is a problem because we cannot do differentiated teaching learning with respect to the student needs, and we cannot also do differentiated evaluation, again, with respect to the student needs. So that is what advantage we get with respect to autonomy. Again, there is limited use of tools. When you talk about examination in an affiliated system, like what you were saying, you're not supposed to use a lot of tools which are available, like for analytical, theoretical, project-based learnings, and so on. And the focus is basically on end product rather than on processes and logic development. So this is what we have tried to overcome by involving all stakeholders in our curriculum design. We also included industry in our subject boards and academic bodies. But what he rightly said, we have not carried away with what exactly industry wants, keeping our values intact so that we are not only catering to one type of industry, we are taking care of the entire spectrum of these needs. We also take into consideration the GATE syllabus. We also look at the higher studies requirements, and accordingly we include these additions in our curriculum. In overall governance, we involve our stakeholders. We use differentiated teaching learning methods depending on the student needs. For PW candidates, we also take differentiated exams depending upon what kind of students' requirements are. We have brought transparency into our processes. We are also looking now offering semester-long internships to the students so that they get actually to work in industry for 6 months and then get absorbed, and it is easy for them to work in the.
Just briefly elaborate for the benefit of everyone. So some of these.
So we'll just wait for this to settle down before we start.
there were more people in the bus, yeah? I think a whole bunch of people came just for a chai. What time is tea? 4. Okay, so tea is at 4, so I have you at least till 4. Yeah, I suppose those who are going to go for the cruise also have to wait, right, till 6. I'll definitely stop before that. Ready? Okay, yeah. Put it up. Okay. So, without much ado, let me start. So, I am Sridhar Iyer. I am a faculty at IIT Bombay for the past 20 years. I've been in computer science originally, and in the past 5 years, I've moved to education technology. And this is my team of students, Prajesh, Lakshmi, Deepthi, and Kavya. So what we have done is that all of them are working in computing education research as their topic. So each of them has picked one. For example, students have difficulty in correlating among UML diagrams. Okay, and they have built a tool for alleviating that problem. And they have done this in a rigorous education research methods, following the methods. So each of them will be presenting a demo. And I really don't have much work to do. In fact, yesterday somebody asked me that, okay, you're doing a workshop tomorrow and you have brought some students to assist you. So I said, no, that's not true. I'm assisting my students. They are actually going to be the ones who are doing the workshop. Okay? And the second point is that, it's a lot of material. So somebody was asking me in the bus that, okay, after this I'll be able to, I'll become an education researcher. So that's really not a realistic goal to attempt to achieve in 2 to 3 hours. So it usually, at least 2 weeks amount of time it takes. But what we will definitely do is try to identify, each of us, how many of us are teachers here? Okay, and others are intending to become teachers, right? So each of us will have some pet problem of our own, which we have observed in our class, saying, okay, my students are having difficulty either in this topic or acquiring something. So we'll try to work on how you can take your idea and do some research about that in order to be able to make some claims. Okay, so up to that level is what we will attempt to come. Okay, so with that, let me start. So, okay, let's... The customary advertisement about the department. People think that education technology is simply the use of digital devices such as smart boards and clickers. However, the discipline of education technology goes beyond such devices and includes the processes and science of how people learn in order to build tools to enhance the teaching learning experience. Our interdisciplinary program in education technology was started in 2010. Our faculty, students and staff work towards harnessing the science of how people learn in order to develop technology-enhanced learning systems.
The thrust areas of research in our educational technology program address both learning and teaching. We use emerging technologies such as augmented and virtual realities and wearable technologies to promote students' learning of concepts and thinking skills and teachers' practices of effective technology integration. Our research methods primarily involve a design-based research approach. We also use data analytics and physiological measurements using eye tracking, for example, to understand the processes of learning.
In our TLOPS project, we focus on understanding and fostering how students think and solve problems systematically. For this, we design learning environments using the latest technologies and also analyze and evaluate these learning environments. We focus on understanding how students develop thinking skills such as divergent thinking, convergent thinking, micro-macro thinking, feedback seeking, and also question posing, amongst other thinking skills.
Metal is an intervention to help students learn engineering estimation, such as estimating the power of a race car to reach maximum speed without motor burnout. In Metal, students build models of physical systems using simulations, and Metal guides them automatically with scaffolds such as reflection prompts and feedback. Our study...
Okay, so this is one type of systems that we are going to see as part of demo. So we'll stop with the department video, come back. Okay, there's one more site that we would like to share, and today in the morning, for example, we heard a lot of good ideas, best practices of teaching learning or ideas worth sharing with everybody else. And there was talk about ACM India should create one page where we'll put up all these ideas, collect these resources, people can contribute resources and people can share resources. So towards that end, Rajesh and others have already been maintaining a blog called the Computing Education Research at EdTech IIT Bombay. And this talks about what we do, what our activities are, what kind of environments we've built and so on. And Prajesh has actually volunteered to do this for ACM India. And I hope Viraj is going to take him up on his offer and get the thing going.
Let's thank Prajesh for offering.
Okay. So, coming to, sorry, IITB Computing Ed Research. Okay, so coming to the structure of today's workshop. So I will do the introduction and the not so important parts, and then can you go to the next slide? Oh, I have it. So we'll talk about some of the things that we have done, and then we'll do the case study. So each of them will present their system, and feel free to ask questions right then about how did you come up with this idea, why are you doing this. So that's what will actually draw out the answers of how the process of research that has gone behind creating these systems. And then there is one session which hopefully we'll be able to take up around 4:30, is where we work with your ideas. So that was the reason why we had circulated the form and asked people to fill that out, so that we can take a few ideas and then we'll try to work out that how can we take these ideas towards a system or towards some kind of a solution. So that's session 3, and in 4 we can try to summarize. Okay. So let's do one simple activity to introduce engineering education research. So we use a technique called think, pair, share. So think, pair, share is known to be a very effective classroom teaching technique. So in this, basically what, there are 3 scenarios shown. You don't have to read it right now. So what the question will be that initially each of you think by yourself as to what the answer to that question is, and then later on we will discuss and then we'll try to see that. Okay. So there are 3 scenarios, and what you are going to be asked to do is to compare between these 3 scenarios. So okay, let me do one thing. Let me post the question first. Okay, so the question is that Prof A, B and C are there, or whatever, X, Y and Z were there, and what we have to identify is who is the researcher in this, engineering education researcher. They may be a discipline researcher, okay, like I may be a machine learning researcher, but I may not be a education technology researcher. Yeah, so I may be a networking researcher. I was a networking researcher, but now I am no longer a networking researcher. So in that sense, okay. So, all right. So X uses notes, PowerPoint and tutorials to deliver lectures, and X believes that the way she was taught is the best way and continues teaching in a similar method. Clearly it's not X, right? So let's ignore X. Okay, so we only have to choose between Y and Z. Okay, so Y looks up for good practices in teaching and adopts them in the classroom, engages in focused discussion within the classroom. Z adopts the best practices, assesses the implementation, after the assessment makes improvements in them. Okay, so one moment, how many people think Y? Everybody thinks Z. Nobody thinks Y is worth. Yeah, somebody said Y? Okay, so this is also something that happens. It's the first time we're doing this particular activity. So sometimes the activity doesn't go as planned, right? So initially we thought we'll make everybody think about it and then go into discussion, but we've gone into the discussion mode directly, which is also fine. Okay, so okay, why is Z an engineering education researcher? Can we have some answers? What are the indicators? And an assessment is there. Okay. So this assesses the implementation. This seems to be the giveaway, right? So there is some assessment that this person is performing. I mean, we are not looking down upon Y. Y is also doing good, right? But we are saying that, okay, Z seems to be doing this, assesses the implementation, and then after the assessment, attempting to make an improvement in that. Okay, so that's kind of in the direction. There is a little bit of a surprise. Is there an answer? Okay. So I'm actually, okay, we didn't do that. Okay. So yeah, we would have done all this activity elaborately. In a way, we can just skip it because it will also save us some time. Okay. So the surprise is that there are actually 4 levels of engineering education researchers. Okay. This is a very standard level. And each of us as instructors, we fit into one of these levels or we fit into different levels for different topics. Okay. So let me take you through them. So level 0 is teachers taught. Who's that in the X, Y, and Z? X was level 0, right? Level 1 is effective teacher. Yeah, come. Okay. Teach using accepted teaching theories and practices. Okay. That was Y, right? See, also the word accepted teaching theories is very important even at level 1. Okay. Because there are, like we conduct these faculty development workshops and many people say that, look, I can see on my student's face that my technique is working. Okay, seeing on your student's face, while is valid as an intuitive feedback mechanism, is not valid as a scientific feedback mechanism. So you have to collect that information a little more systematically. So if you look at this, Z that we saw is actually a scholarly teacher who does the assessment of performance and makes improvements. Okay, so that's where we are. And then here's the surprise. There are 2 more levels to go. Okay? So most of us are, here for some topics, here for some other topics, and we kind of keep going back and forth depending upon how passionate you are about that subject, right? So if I'm very passionate, so for example, before I moved to education technology, I was kind of between level 2 and level 3. Right? I used to assess performance. I say, oh, this is not working. Like Professor Rastogi showed in the morning, I used to say, okay, let's do Wireshark, let's do this. Keep trying different things. Okay, so assess his performance, makes improvements. And then you say, okay, let's try to systematically find out, like what Professor Bhaskar Raman showed in the morning, that okay, with Bodhi tree there was some improvement, the averages went up, the median grades went up. Without Bodhi tree, this is what happened. So that is the next level. Okay, and then the engineering education researcher actually, which not too many of us need to become either, actually conduct this educational research in a very systematic manner, with as much scientific rigor as any other discipline would have, right? And they publish these archival papers and deal with the why or the how of learning. Okay. So the goal of today's workshop is to we'll give you a flavor of what goes into level 4. Okay, but getting to level 4 is not a goal. Okay. We'll attempt to get to level 3 as to what kind of experiments can be done. So different research methods are required to be at these different levels. Okay. So for example, at level 3, what the research method that is most commonly used is called action research. Okay, which some people who have participated in the T4E conference, they might be familiar with. So it's like you do an intervention in your classroom, you find out what is working, you do something systematic, and you report those results. So those would fall in level 3, and that is what is a good goal for us to take as a initial effort. At level 4, we have to do these design-based research cycles and so on. So I'll just quickly give you a flavor of that, and we'll jump into the demos. Okay. So what's the answer now? There. Yeah. So the best one is still level 3, right? So when this person, after making the assessing of the implementation, actually does the experimentation, then they move to level 4, and then see, essentially the point is when you start investigating as to why is this learning happening. So my intervention worked. Okay. So what? Right? Why did it work? What is the process that's going on? What is the mental models that students are creating? So when you start looking into that, that's when we get to level 5, level 4. Sorry. Okay. So I'll just quickly now give you some glimpses of what we have done at IIT Bombay in terms of CS education research, and then we'll jump into the demos. Okay. So the first thing that we looked at was large classroom strategies. So looking at CS 101, and this actually looks like my class. So we did a whole, it's a huge auditorium, 450-seater auditorium, and the key problem was that students' engagement with content has to be maintained, right? I mean, you don't want to only talk to the front benches, you want to be able to engage everybody. And the easiest way to do that is to use these well-known active learning techniques. So two of them that are very popular are think, pair, share and peer instruction. Okay, peer instruction is like when you do a multiple choice quiz, you ask people to vote, and then people discuss, and then they come back. Okay. So all of these techniques, while they are well known, it was not known as to are they effective in large classes, how do you engage the entire class, and so on. So that's what we did, and we found that using these techniques we can actually sustain student engagement at 80% level. Okay, and everybody kind of knows that if 80% of your students are getting 80% of what you're saying, you're doing a great job, right? Okay, so quick question. At what level is this work? Level 2 is level 1, 2. Yeah, so it's actually 1.5. Yeah. So when we are doing up to this point, then we are like 1.5. But then when we actually go back and we try to do a very rigorous look at how much engagement. For example, where did this number come from? Okay, how did we find out that 80% engagement is happening? In a classroom of 450 students. There is feedback forms, yes, that is one way. And sorry? Analysis of results, analysis of learning results, and more importantly, what we did was classroom observations. Okay, so not this batch, but the previous batch of students. They actually came to class and we had an observation protocol. So observation protocol basically means that, okay, I am given to observe this group, and in my observation protocol, I have saying, okay, what are they doing? Are they, kind of thinking? Are they, playing with their phone? So what is that group of people doing? So, and every 10 seconds you kind of take a look at, what are these guys doing? And you kind of put a check on, okay, this is the activity that's happening in the group, this, that. So, and then from that data, you actually try to infer, are they actually doing what they're supposed to do, or are they talking about something else? What's going on? So when we did that, that's when we got from level 2 to level 3. So it was still not level 4. Okay, it was still at, we did engage in educational experimentation, we shared our results and so on. Then later we moved on beyond that. Okay, this is actually slightly tangential to this. Yeah, sure. Sure.
Is relevant because even though I'm looking at the slides, so the person who is observing may feel I'm giving attention, but it is just physical attention and not the mental. May not be mental.
Sure. So this is a very valid point, and the question is, if I'm just looking at it, does looking means comprehending, and does comprehending also mean understanding, right? So all those questions are there,
Now, the thing is that what we were trying to observe here was, are they doing this activity? So it was not like, so are they talking to each other? And if they are talking to each other, are they on task or are they off task? Okay. And also to answer your question, so when you are looking at slides, again there are markers. So all of these things, so that's the point I'm trying to make. So all of these things have been very systematically studied. For example, some markers are, okay, what is the, are the eyebrows getting raised occasionally? And we also use these techniques sometimes in the MOOCs. Okay, so when we have online courses, we want to, and we have an eye tracker sitting there, we want to find out, are students watching my videos or not? Or are they just playing the videos and sitting somewhere else? So there are a lot of facial codes. So that's called, there's a facial, what is it called? FACS. Facial coding system. I forget what the A stands for. Yeah? Anyway, teachers are doing that informally. In a class of 450. Yeah? That's the key. Alright, in a class of 30, yes, I know exactly who's sleeping. Okay. Yeah. So that's why. So we use statistical method. So it's not like, so this number 80 is a statistical number. It's not like I sampled every student in the classroom for the entire duration of the time. So you do some random assignment saying that, okay, yesterday we were observing here, tomorrow we'll observe there. And then the first thing to do is to actually check your protocol. So these observations were done over 13 classes. Okay, the first 8 classes, we just used it to refine our protocol. Saying that, okay, are we paying attention to the right things? Should we observe at 10 seconds or should it be 15 seconds? Okay, how often should we collect data? See, like what Professor Haritsa mentioned in the morning, or was it somebody else? If it is garbage in, then it's garbage out, right? So it's the data which is, we have to ensure that we are collecting valid data. So that's what we had to do, and with the later 5 is when we actually came up with conclusions on, is engagement happening, what shows engagement and so on. Save your voice.
Initially, you dismissed this teacher saying that I can see my students, I can read from their faces whether they're paying attention or not. But when it becomes a bigger class, you're accepting that technique, though you do it in a scientific way. What are you saying, that this is also one of the methods that goes into bringing this 83%, or are you saying this is the only method you use to get the 83%?
So okay, let me make a finer distinction. So when a teacher looks at the class and says that, okay, I know, okay, though that group of people have tuned out, this group of people are very excited. Okay, so we are doing intuitive reasoning. Okay, we're not following any protocol. We're not doing an observation protocol. And here, what they're doing is that this is very specific to this particular technique. It's not for the entire duration of the class. When that activity is happening, that's when the observation is happening, right? So there's a slight difference between the two. Okay, so I spent far more time on this thing than I intended to, but so I'll skip the next one. So this is some tools for assisting instructors. Yeah, so this is the main one. So this is the designing and developing environments for various skills, so content knowledge and thinking skills. What these are, I'll actually show as a demo rather than tell you about it. Okay, so this is the broad methodological approach which each of them will now present about their own work. Okay, so it begins with saying that, what is my problem? Okay. So one problem is that students learn UML diagrams in isolation and they are unable to make sense of how these are connected with each other. So how do the sequence diagram and the class diagram, how do they relate with each other? So that is Prajish's problem. He will talk about design comprehension. And how does he go about it? He looks at what is the literature that supports the learning of this topic. And he also looks at analysis of experts and norms. So this is a very key thing. When we talk about the 4th level of engineering education research. So there is a fairly involved novice study. So you give novices a problem and you observe what are they doing with it. Where are the difficulties? Where are the problems? And then you do the same with experts, and from the experts, you actually infer, saying that, oh look, if we build something into our environment which helps novices do some X, they can move towards becoming experts. Okay? So all of this, I know that I'm talking in the abstract, and we'll concretize it in a moment. Okay, so having done that, after the analysis of novice and experts, we actually extract what is required. Where is the problem in this learning? How do experts approach it? Then we say that we conjecture something called the learning pathway, which basically means that if I make students do A followed by B followed by C, then the chances are that they will be able to demonstrate that they have understood design comprehension. And having conjectured a learning pathway, then we say, okay, now let me build an environment. So none of them start building their environment till the third year of their PhDs. Okay, so till 3 years, even though it's a technology institute, for 3 years they're just trying to understand where is the problem, what do I need to do to solve the problem. And only in the third year they start actually building a system, because now they've understood. And third year they build the system, fourth year they do the experiments, and fifth year they're out. Okay, so that's the model. Yeah, so then we do the testing, analyze the data, is the desired learning happening? And this is the key point. This is what actually differentiates the engineering education researcher from the scholarly teacher. Okay, is they extend the theory of what exactly is the learning mechanism, what's happening in the student's mind when they are going through this process. So these are called local learning theories. Okay, and how does my design support this? And this entire cycle, so this cycle is actually called design-based research, and this cycle repeats 3 times. Okay, so the first, yeah.
Sir, if you give an abstract answer, then also we do. Can we believe these observations on engagement with student as far as their facial expressions are concerned? Can we believe that these are correct? This one. Second one, are these acceptable when we claim these in our technical papers? And the third one, can we categorize this into cognitive behavioral science?
Alright, so we are actually going back to the previous point. I should not have mentioned facial expressions, so I realize I have made a blunder by saying that. Okay, okay, let me try to do this using an analogy. Okay, so there are statistical methods, right? I mean, we compute averages, then we calculate pre-test, post-test, what is the gain. Okay, so we apply, standardized techniques. Okay, so facial expressions also have standardized techniques. Okay. If you are using those standardized techniques, then your results are believable. If you are saying, I looked at the student, I found this, it is still valid, but only as anecdotal evidence. Okay, so then you are at level 2, little bit between 2.5, let's say. Okay, because you are still doing anecdotal evidence. So when you are using rigorous instruments, so these are called instruments. So when you are using instruments, now how is an instrument developed? It's like any other instrument. Okay, so you have to first develop the instrument, then you have to check for validity. What does validity mean? So if I have an instrument which is measuring, let's say it's an ammeter or something. Is it showing the right value when the current is, whatever, 1 amp? Is it showing 1 amp consistently? The same kind of validity has to be done for even these facial observation instruments. Okay. Then there is a notion of reliability. What does reliability mean? If I use the instrument and you use the instrument, do we both get the same value? Okay. These are all fairly nuanced and very interesting ideas to think about. Like if you take a scientific, any other, engineering instrument, take an ammeter, the example that I said, it doesn't care who's using it. It's going to give whatever value it gives. I mean, if it has an error, it has an error, same error for everyone, right? But if you take an observation protocol as an instrument, so you might say, oh, this indicates the student is bored, I might say, no, it does not indicate that the student is bored, it's something else. Okay, so do you and I interpret the same thing from that instrument? That's called reliability. Okay, so validity, so if you are using valid and reliable instruments for observations, then the work is publishable at level. And mind you, I'm not saying that any of the earlier levels are useless. I think it is perfectly fine to be at level 1. Okay. There is no need, I mean, as long as you're not at level 0. Right? Sorry. Yeah.
Is there any for a faculty to maintain a class strength? Like in the sense, 450 facial reading, or normally I used to tell, eyes are good example for L value and R value. You can read as well as write. Right? So, is there any threshold? Like, beyond this, it is not at all, meaningful to teach in a class. Like, so you can give lectures, that is different. Right? But when you teach a class, beyond this strength, it will not be meaningful.
Yeah, so the accepted definition of a large class is, let's say around 100. Okay. So it really doesn't matter whether my class is 100 or 400. Okay. The same methods will work. Especially so all these earlier methods that I talked about, they are scalable. Okay, so this think, pair, share, peer instruction. Why are they scalable? Because people are not talking to the instructor. They are talking to each other. So when you have pairs, it doesn't matter whether there are 50 pairs in your classroom or whether there are 400 pairs in your classroom. So it scales at that level. For an order of magnitude, it can scale. Okay, when you go beyond 1000, then you don't have classrooms of that size, and then you are going into online, you are going to blended learning. Okay, like flipped classroom, you are using methods like that. Okay, so that's a totally different story. But in a face-to-face classroom, these methods, like at least these two which we use very commonly, and actually there are, can you bring up the resources website? Department. Yeah, and we have actually resources which help teachers to go to teaching resources. Yeah, so if you go to our departmental website, so there's a talk. So there's a this is a video of my talk on how you can actually use think, pair, share in your classroom very effectively, irrespective of whether you are teaching 30 students or whether you are teaching 300 students. Okay, and there is also a constructor which will help you to design those activities for your own topic. We haven't done this workshop in a while. And then correspondingly, there is another one for implementing peer instruction. How do you implement peer instruction? What are the different types of topics for which this is a good thing to use, this is a good technique to use? Okay, so that's a totally different workshop. I mean, that itself is a half-day workshop to go through work with these constructors and design it for your class. Okay. So coming back to the theme of today's workshop. Yeah, I think my part is done. So this is the broad idea. Okay? So you start with a problem. So there is a problem analysis phase, and you do the problem analysis by looking at literature as well as conducting studies. Okay, so these studies are actually the hardest ones, and each of them spends almost a year just doing these studies. And then after the problem analysis phase, this is the solution design phase. You design the initial solution, you see whether it's working, you carry out small pilot studies. No, you don't take your solution directly to a classroom of 50 students. So you try it out with 1 or 2 students, you try to see what changes need to be done. Then you do the reflection on is the learning actually happening, what do I need to change in my system, identify is my theory working out, and then this iteration you carry out 3 times, 2 to 3 times, before you can say that okay, I've reached some kind of saturation in my study, and that's when you are ready to write a thesis. Okay, all of them are. Deepti is actually finished her thesis, and she is going to be defending 2 weeks from now, and the others are close to finishing. Okay, I think I've talked about all this. We can leave this. That's it, right? All right, my job is done. Now I'll hand over to Prajesh. Lakshmi, sorry.
Hello, welcome all. I'm Lakshmi. Okay, so this is just coming up. So I'm going to start with the case studies that we are all going to be presenting, me, Prajesh, Deepthi and Kavya. So I work in the teaching learning of software conceptual design. So a little background about me. For about 6 years I was in the IT software industry, and then I moved for 3 years. I was an instructor, I was a college teacher at one of the Mumbai suburban colleges, private engineering college. I used to teach software engineering, operating systems and computer programming. So I'll start with this problem. So suppose this problem is given to any of your student. Let's say you are all software engineering instructors, and this problem is given to your student. They have to create a conceptual design for this mood-based music player, and these are the requirements. It needs to detect mood, it needs to automatically create a playlist, and all those things. Okay. So what do I mean by software conceptual design? Let me make that outright clear. I mean that it should be a description which is implementation independent, which means that it's something that is not in a programming language, and it should support analysis and exploration. So it should have some kind of a flexible way where they can explore and represent their ideas. So when I do that, so now when you see this orange, I mean you just got a flavor from Sir's slides. So when you see an orange slide, it means that it's activity. So what I would want you to do is, for about a minute, think individually. You have given this problem to one of your students. You've given them about 1.5 hours time. Yeah? And can you predict how will be your students' approach towards to this task? I mean, what will you see at the end of 1.5 hours? Or what would the approach that they would take? So can you individually think, and maybe if you want to write it down, I would insist that you write it down so that you have something that you can refer to when you move to the next part of the activity. So we'll wait for about, yeah. So this is the question. Yeah, so each one of you have given this question to your student. So what I want you to predict is how would the student solve this design problem? And at the end of 1.5 hours, what would you see? Both of these. If you could, anyone you could take, or if you're able to predict both, that's also great. So what is the approach that the student would take, and what would you see at the end of 1.5 hours? So maybe a minute we would spend. Yeah, sure. Yeah, so individually you just think, and you, yeah. No. I want you to predict what the student will do, and at the end of 1.5 hours, what will you see? So what happens is, like, as instructors or as practitioners and as teachers, you would have to wear, and also now as an edtech researcher, the difficulty would be that, you'll have to wear 2 hats. One is the teacher hat, and one would be the researcher hat. Okay, hat. So I'll just talk about the next. So can we close this activity? No? Because we have...
Yeah. So what we do is in our workshops, we keep doing this. We keep interrupting each other and changing the flow of the thing dynamically. So that's what I'm going to do. I'm giving you a heads up on that. So see, some of you are thinking about how you will solve the problem. Okay, that's also valid. We need that answer also. So you are the expert in this case. And how you will solve the problem, how will you approach this problem? That is the first thing. How do you think your student who is doing the software engineering course or has just finished the software engineering course, how that student will approach the problem? Okay, that's the comparison which we are trying to make. Got the point? So we'll now go into the discussion.
So now what I would want you to do is, pair. Look to the person to your left or your right, find a pair, and then create like a table, sort of like this, where you can, like sir said, can you think how will you solve the problem, and compare it how would your student would have solved the problem. So if you can look left, right, find a pair, and then come up with one answer, like few entries of the table.
So that's because it is there.
Is the real answer coming from my student?
You actually asked them this?
Yeah. Is the answer coming from the students?
No, the username for authentication.
I'm just giving this student.
Parameters to mapping, parameters, combination of parameters. Group of parameters to move. एक parameter असले mood है असली then उस पे set of
All that we work
So, back to the workshop. So here's again one meta level comment. So what we are doing currently is the think, pair, share activity. Okay, and initially you all thought individually, then you are off, somebody looks here, somebody sees WhatsApp, then my students say, okay, ho gaya. Now that topic discussion is over, now we come back to the main topic. So this is an activity which scales to 450 students.
So can we move to the next phase? Yeah. So if you're done with this, so the next phase is the sharing phase. Now, what I'm going to do is like only collating answers. So now the floor is open to all.
Table by table. Each table can say one item.
From expert point of view. Okay. So from expert point of view, we will detect the mood using biometric means like facial recognition and other things. And from novice software designer approach, I think my students will ask for the moods like 1, 2, 3, 4, like he's happy, sad, or something like that.
We can have some list of moods from the expert column. List of moods, and then we should also have some characterization of the songs. That list is already ready based on the mood. So like in which mood, which type of songs can be played.
Or we can have an algorithm to detect the mood in the expert mode.
We can have a list of songs which are expert software. We can have list of songs that are specifically catering to that particular mood according to these lyrics.
other column. So that's what we are attacking.
I have. Actually, if it is student or the noise software designer, then their thinking will be more centric to the implementation. Means like they will be thinking, okay, how can I write program and then which technology and what kind of database, something like that. And if it is expert, it will be more in-depth thinking of like research-oriented kind of. Yeah. So maybe the mood, how one parameter is facial recognition of the mood. So there are different ways to recognize the mood, maybe the EDA value or the facial or the anything else as well. And whereas the, as already rightly said, students may take as happy, sad and all as the 1, 2, 3, 4 and they might not be thinking about that. Then
I mean, this problem happened to me, but the students really, this is something, I asked the same question, what do you do? They simply said 3 steps, using machine learning, identify the mood. From the list database, we know which music to be played, play the mood.
From the expert side, we just discussed that. From the expert side, we probably, it's a software designing, so probably we would start thinking about what are initially the requirements. So what is it that we have to do and what is it that we have? So what is it that we have to do has to be clarified. So mood, what do you mean by mood? Does it mean facial recognition, voice recognition, words that they may use? What are these? And then music, how do you categorize music? And basically gather requirements and then get into the analysis and then the design and so on.
And also one more point there is about authentication. We don't know what is being authenticated.
Authentication can be done on the basis of facial expert.
So expert, I think we have the facial recognition is already talked to. Can you tell what your students have? See, what we want to address are the difficulties that students have. That's more important.
Authentication.
Yeah. So basically, first things comes is when you talk about music, mood based, they will be inspired from something like Spotify or Sound. Okay. So you will start seeing the application directly. It will be mobile based because the Spotify is the main application which is being used. So another thing is the validation of the use cases of the application, where how you're going to use them. That won't be that will be missed by nowadays software developer, but it,
what do you mean by validation of use cases?
use cases.
Specifically, that use cases should be spelled right. If it is not there, how to proceed? That is what they talk about requirements gathering. That is put in the form of use cases.
I also want to add one more thing. In the brief experience that I've had in the industry, so from the expert point of view, experts focus on the top-down approach. So first of all, they divide the system into subcomponents, and then they decide that what a particular subcomponent would do and how all the subcomponents would connect with each other. From the novice point of view, like if I consider myself, I'll first go about how, like, what sort of target audience I'm approaching. So first of all, I look at what the UI screens should look like, and how would the system flow with each other, and where can I seek the inspiration from?
Thank you.
Actually, the expert, we will look at a top-down approach, whereas those students are going to do a bottom-up approach. Basically, they will directly jump into the data structures, then the algorithms, a table, with indexes as the mood, and then they will list all the musics, corresponding to the rows, and they will pick up some standard facial recognition algorithm, that is there which they have studied. But when it comes to expert, we will look at multiple options on facial recognition. And then we will also go through a structured requirement architecture and process where we identify the actor, we identify the sequence diagram of the messages which flow, and then we even challenge what is this authentication is all about. And then we will also look at the user interaction, UX aspect. But whereas the students, they don't get into, they always get into the inner aspect, and then they wanted to start, from the bottom up. That's how the whole thing goes.
Information search.
Being the last, we most of the points have been shared, but from the novice part, most of the students, they, like as he rightly said, they will pick out from something which is already there, like a playlist which is already there. They'll at the most put different genres like sad and romantic and all those. So they'll already have pre-programmed lists, and they enjoy working on authentication. So the first thing they'll attack and do is a nice user interface with login name and password. They'll spend a lot of time trying to kind of authenticate these users. They'll do an excellent job with that. And then of course it's just mapping of the mood with the playlist that they already have, and depending on the hits or the pattern, if it's already there, they will start playing it. So that is we focused more on how the novice would look at it.
So let me add a better comment here about my students. So when they started building their systems, they also focused on authentication to quite a bit, right? So and see, all these answers that you have given, this is actually validating Lakshmi's studies. So what you have actually done, as she goes ahead, we'll see that what she has found out by a formal analysis of novice studies and what the literature says. But largely what you are saying is validated in literature.
This is my software manager experience coming in as an expert. We are always saying what to play. If I can't identify the mood, do I still need to play? What my system should do if I can't detect? We never addressing that. And there's a major problem that happens in software.
Failure handling. So I would, the next slide, interestingly, if you look at the next slide, so when we went to Tata Consultancy Services, the research division at Pune, we also kind of found the similar kind of like, they will search for information, they would, they would only look at how to detect mood, like someone was saying the bottom down approach, only look at one problem and like completely try to solve that problem. Whereas if you see, they said this expert would have a complete view of the system. Similar kind of things that we got from when we responses when we went there. So now what I'll actually tell you is the results from the study that Sir was talking about that we conducted. And if we look at the two main results for that there is this difficulty of fixation. So when I mean by fixation, it is that they get attached to a specific functionality or a specific component that they would have searched. Okay, they would search for information, like he said, they would look at Spotify, and so they would get attached to a specific functionality or a specific component. If they found like, this machine learning algorithm is really good and this is the machine learning algorithm that comes up in their search, they would just get attached to it and they would just completely go with the same thing to design their, to solve their problem. The other thing that was there, even if they have bottom-down approach, some people are talking about the bottom-down approach. What would happen is, when you're talking about the bottom-down approach, you will have to integrate the different pieces at some point in time. What really happens with novices is that when integrating, there is a breakdown that you see there. Like they would solve a problem, a sub-problem. They would have certain components which actually they are orthogonal to the other problem. Let's say, for example, in my study, I found out one of the students had written that they would use a webcam. But the functionality that they wanted was that the mood-based music player could be used while they travel. So they would use a specific webcam. So this lack of integration was also found. And there were other, category of difficulties that we found. Someone said information search. They said information search. And also this idea of, like someone said, they would do a top-down, but actually the experts would do a mixed approach. They would go breadth-wise, then they would actually switch to a specific sub-problem, solve it completely, know when to switch back to the breadth. So these are the kind of strategies that the experts would use. And the other thing is this cognitive processes. I think you will hear this a lot more when many of my colleagues also speak about that this cognitive processes such as simulation. Yeah. Okay. So cognitive process is a mental, let's say, when I say cognitive processes, it's a task that you would do mentally in your mental models. Like Sir spoke about mental models that students have. So when you execute a task mentally and you really based on the knowledge structures that you already have gained, and that is referred to as a cognitive process. Example, in software design, okay, when you're solving a software design, you either could become, you're all experts here, you could either become the system itself, because I know many of them who do system programming, they think in terms of the code. So when they think, when they close their eyes, they could actually believe that they are the code and how it executes. Or the other way is that you could be the end user. If I'm an end user, what will all I need? So this is mental simulation. Okay? So that is an example of a cognitive process that you are able to do. Yeah.
So that means what is happening is students, novices, they start with how aspect. Because they don't start with the what aspect. That's the biggest challenge. But as Professor told, 3 years you are taken through the problem, and only from the 4th year you are getting into the solution. The current approach of all the graduates in the colleges, what I see, as soon as the problem is given, without any questioning on the problem, they start with the solution.
Yeah.
So that's the challenge we have, which we need to change.
Yeah. So even let's say that is from literature, it is known as the problem formulation. And it's noticed that experts do problem formulation, spend a lot of time in problem formulation. It is a known thing in design literature as well as any engineering problem solving literature also. So what you're trying to say is that, yeah. So, okay. So the next question is, so the novice cognitive process was that, like someone said, I mean, Venkresh sir was telling me, they would do an information search. So when you do an information search, what happened with the novices was that they just did an information search, and they used the result as is. They couldn't apply whatever they have taken the information from the search to their problem. So
again, just to quickly give some context, now that we know that novices mostly do this, what we need to do is build a system. It could even be classroom instruction, some system, some learning environment, which gets them to start moving towards this. So this is the target, and this is the current state. So that's what the rest of Lakshmi's talk. And a lot of work goes in behind. How did we find fixation? A lot of video analytics has to be done. Maybe you want to just.
Yeah. So So the next question you should be asking is, how did I find this? So there comes the next study. So we did a learner needs analysis study. So we did a learner needs analysis study. So it was a qualitative study. So what did I do? I took many 4th year computer engineering students. I gave this similar problem. There was mood-based music player, fingerprint ATM system. So similar problems like this. And I gave them about 1.5 hours to solve this problem. So what did I do when they were solving this problem is I did a video recording, and also they were given a computer to work with. Like today morning, professor from ISC was talking about, he gives an open book test. So I gave them the computer to work, because that's how people work in the real world. So I gave them a computer to work. So when they were working in the computer, there was a screen capture that happened. And also some, we tend to use some notebook, pad. So all this was given. And so I had 3 streams of data. One was my screen capture, one was my video data, and also the artifacts that I had. So I applied this qualitative coding methodology known as activity coding to create a merged timeline of what had really happened. Because now you understand there are 3 data sources, 3 different data sources. So I'll have to really now interplay these 3 different data sources to get one stream of a data source. So that is an activity coding methodology. I'll talk about coding just a little further. It's not the coding that we are so intuitively used to. Then after this, I applied the deductive coding mechanism. So what is it that they're doing in each of this stream that I have based on this function behavior structure framework, which I'll again talk about. And then I applied a linkograph analysis method. So I had like a huge set of actions that they had done on function, behavior and structure. And how are these actions related? Because an action cannot happen in isolation. It has to have a relation to either previous or to, the preceding ones. So I did the linkograph analysis. So one of this was the screen, so this is how the student worked. There was a video recording, there was a laptop, and what they wrote. And I did this. And so in qualitative research, coding is actually how you define the data that you're analyzing about. So what is that data that you're analyzing about? You give a name to it. And that is code. They are called codes. So that's why I put it up here. So it's not the coding that we do.
So basically right now, as a student, when we are trying, you told 3 modes, right? So I usually don't write on paper. Okay, and it's all mentally happening. I'm searching from one tab, I get some information, next tab opens, I'm searching that, next tab opens, I'm searching that. And most of that, it's happening mentally. How did you record something like that?
So what I had given them before the task is a good question. Thank you. Maybe I forgot to mention. So before the task, I told them that, so please take me through your process, make it as explicit whenever you want to, think about it, write down. The other thing was, as a researcher and an observer, I was present there. So if they're staring at the system, if they're still looking up, which means they're thinking, or I don't know if you're thinking. So I would, for about 15 minutes, I would ask them, what are you thinking about? Is it okay if I interrupt you? Can you please write down if you're thinking about something? So these are the kind of things that I did as an observer. Yeah, so there is also the other protocol. There's another.
Feel that you would have lost some data in between that communication, like the person thinking and noting down on the paper, that might happen.
Yeah, that might have happened. So there is another method also to do it. It's called the think aloud protocol. So before you start the task, you tell them that, please explicitly mention openly what you're thinking. So one of the participants, incidentally you said you're very quiet, one of the participants was going on talking. I think this will move like this, now this has to come. I say that, I can use the Aadhaar API like this, the Aadhaar API would have these as the parameters. So he was actually thinking about the whole thing, he was going on talking. So that was a person like this, but for people who are very quiet, one is, the approach is like, I interrupt them, and the other one is talk about think aloud. There's one more thing of, there's another way that you do is you let them be as they are. Then afterwards what you do is you capture the video, you do a stimulated recall. Okay, you show them the video that and you pause at certain points. What were you doing here? Can you please say why you were doing this? So it's called a stimulated recall. So there is another way also to do it. So this is how we got the results. So this took me, like Sir said, about a year to come up with these results. So
what we do is we just quickly take a look at the solution and then we break it.
So with these difficulties, as you know, you cannot get a comprehensive and cohesive solution. So also the motivation that conceptual design is important. It's an important phase. Like she said, you can't directly jump to implementation. Also, most of the software teaching learning tools or what are available are directed towards methodologies, or they're directed towards project management. So in my PhD, I'm addressing the problem of teaching learning of comprehensive and concept software conceptual design using the function behavior structure framework. So before I go to my demo, I want to talk a little about what is this function behavior structure design framework. So it's a pretty old framework in the sense it's available in design, like you can see, from a very long time. So people have been using this framework in mechanical engineering, people have been using this design framework, let's say in civil engineering. But what is FPS in software design? So F actually is called a function. It is the capabilities of a proposed solution. Structure are the components and the concepts. And behaviors indicate the interaction between these components and concepts that are actually achieving the functionality. So now if you think of in terms of UML diagrams, which are the basic standard representation mechanism available to us, you can think of use cases as a view, which is only talking about the functional view. Then there are class diagrams and component diagrams, which are only at the structural view. And there are interaction and sequence diagram at the behavior view. So what is available to undergraduate learners are these views in isolation. So to be able to integrate all of them and to come up with the conceptual design, they're having difficulties. That's why they fixate towards either of them, and there is this lack of integration. So with this framework, So with this framework, they construct a FPS graph. So these are the activities, set of activities that are there in my learning environment. So I'll just briefly touch upon how we came with these activities. So again, I had conducted two pilots with students. So what I did with each pilot is gave them a set of activities. Then I saw what were the difficulties in those activities that they had. Then went back and redesigned my set of activities, gave them again to a couple of students. So this kind of iterative thing that we did to come up with these set of activities. And this is how my system looks like. It's called Think and Link, because you have to think about function, structure and behavior and link them. Yeah, it's available online.
So what does it do?
So the system is available on this page. So if you go to this page, you can get to the system. So what do the learners do in this? So the learners are made to create a FPS graph for two sets of problems. So initially they're given a FPS graph. They are taught what is function, behavior and structure. I mean they learn actually. They learn what is this function, behavior, structure, how to create functions, how to link them to structures and behaviors. So they're taken through gradually. Like if you see, there are three phases: introduction, induction and ideation. So introduction, they are introduced to the graph. There are a set of questions which take them through to learn what each of these are and what are the, so you have, so in introduction, there are these phases that they go through. So like I said, there is a design problem, then they are given an FPS graph. So this is an example of FPS graph. And the worksheet. So there are, so in the graph there is some kind of interaction that we give them. So we realized that in the studies that we did, we realized that giving a static graph really, they're unable to, look at the graph. So this kind of a visualization in terms of color coding and interaction helps them intuitively to grasp what is F, P, and S. And so these are the questions. So these questions help them to gradually take them through understanding what is a FPS graph, how to create and connect function, behavior and structure design elements. So what happens in induction is, now they edit the same graph. So they are taken through the process of how to edit this graph, how to add, how to connect. They don't stop at editing. We also give them an evaluation where they self-evaluate their FPS graph based on criteria. And at every point we also have UML diagrams. So UML diagrams tell them from the FPS graph, how can they go to these UML diagrams? So how can they reach there? And in ideation, what we do is, this is an interesting part. In ideation, for their final year engineering project, we ask them to state their problem and create the FPS graph. So this is where in most of the studies that I see, they're very thrilled, because given this, they're able to apply it to their final year engineering project. And when they do this in their final year, I see that most of them actually edit the problem. So when they are in the, okay, let it come up. When they are at the ideation phase, they set their final year engineering problem and they create a FPS graph. So in this phase is when they are extremely thrilled to be able to do this activity, because they see that, they understand their final year project much better. So that is the kind of results, indicative results that I'm getting, is that we are able to elaborate our final year engineering project a little more better. We are able to understand our final year engineering problem a little more better. So there are a bunch of scaffolds. So
let me add a comment. Let this slide be there. So if you look at so if you look at this, so there is something that happens on the left hand side. Okay, so all of these are carefully thought out. For example, what comes on the left hand side is called an agent, and there is a lot of literature which says that some personalized agent, when they come, then the students are able to relate. Like what we saw yesterday in the CC 2020 thing, that there is knowledge and there is skill and there is disposition. So the disposition also has to be taken care of by these agents. And the other thing that you find is, there are all these questions that keep coming up. Okay, it asks the student, okay, what are you going to do? Then it asks, why are you doing this? So the purpose of this, again, is based in theory. The theory is that there is cognition, which is how we do things, and then there is metacognition, which is what we think about how we do things. Okay, and it is known that we have to be able to take our learning to the metacognition level. Okay, so it's like basically saying that, okay, you did some activity, then the instructor asks, okay, why did you do that? So the asking of why did you do that helps you to reflect and think about, okay, how do I abstract this? Suppose you are given a new problem. How will you apply what you learned from this problem into that problem? So whenever we are asking questions of that sort in our class, what we are actually doing is we are helping students go from the cognition to the metacognition level. So all of these things are actually hidden, and if Lakshmi were to talk about her system in detail, that itself is a half-day thing. So we'll stop with that part here. And what is the next slide? This is how she did her studies. She found a bunch of results. Luckily for her, the results are like saying that her system is doing well, and the industry is also saying that, yeah, it's a useful thing. Like, in fact, Venki was mentioning that all their entry-level people, Venki is from TCS, so all their entry-level people, they would like them to be put through such a system. So hopefully Lakshmi will graduate on time. Okay, with that we will break for tea and then come back and take a look at some of the other systems. Sure.
So in your, all this observation, did you observe students asking questions? Because we are talking some 5 lines of requirement. Additional questions, by which, they implicit, there are a lot of implicit requirements, in problems. So unless the students ask those questions to, us as the person who is giving the problem, those implicit requirements will not come out. So have they done that? That is number one thing. And one of the things I have always seen in students is, everything, they will write, very neatly on a paper. But they don't know the actual art of, taking quick notes through diagrams, because when requirements comes, it need to be captured quickly in this thing. So by verbal lines, you may not be able to capture all these things. You need to quickly, depict in pictures with arrows and all those things, So that is that sort of stuff happening among these students. These are 2 questions to you.
So I'll answer the second question first. So the idea also is that in our novice study we found that, like you rightly said, they just wrote reams and reams of solution details. Like I have like each of the student writing like 3-4 pages of just the solution details. So the idea that these are students who go through software engineering course, UML is taught to them, they have this language available to them, but they did not utilize it because of its formality or whatever. I am not going to that. Yeah, you are right, but process. So what happened really was it actually did not use any tool, as well as you draw the UML on the you can draw it, but actually I didn't see that happening in the final year engineering student. So everything is verbal. You're right. So my idea is to give FBS graph as actually like a language also available to them. So now I can think in terms of function, behavior, and structure, and now I'm able to map it to the UML. Is what was my solution idea also.
What I feel like there might be one parameter, sufficient number of case studies might not have been taken while teaching the subject, that's why the thinking process might not have been. Is it only your tool which is giving that kind of amount, like everything we are doing, or is it prerequisite sufficient number of cases studies? It's like case studies are not taken while teaching the subjects.
No. See, okay, so I have two parts to your question. One is sufficient number of cases. So even if you had like, an n number of cases done, you had an experience of, going through it. I'm really not sure how much of abstraction of that, like sir said, of, why this reflection, if you didn't do, then this process of, oh, I need to create a UML diagram of use cases, class diagram, that wouldn't really happen is my what I believe. But the other angle that you're trying to say that, that is my solution, the only solution. It's just one of the solutions.
Just to add to that point. So a lot of times the students are actually learning for the test, right? So if you say, okay, if you give a very nice cut and write problem saying, okay, draw the sequence diagram for XYZ, beautiful one you'll get. Okay, for their own projects, the connection that, look, I should draw a sequence diagram, I know how to draw a sequence diagram, that connection is missing. Because that's what these systems, all our systems,
they should know that all these things that they learn, these are all tools available, like a carpenter, no? There's a chisel, all these things are available. Let me architect, or let me sculpt, a particular product out of it.
That's exactly.
There only the first question I wanted to ask. Did they ask you questions, to elicit, more and more requirements? Because normally, there is a tendency is, once a question is asked by a teacher, you cannot cross-question the teacher. But that doesn't happen in the industry. Industry, you need to understand the customer, his user scenario. There could be hundreds of questions, implicit requirements which are there, which has to come out. Otherwise, you will make a product and it will not be used by the customer. So that simulation is true.
The attempt is not use the software process as one part. Just one very short question. We can take it at the My question was, did you capture any conversations that the student had with anyone about the problem? Or was the student simply working alone on this?
So the task given to the student was they were working alone on this. It was an individual task. They were working alone. I agree that there is this aspect of collaboration and there is a lot of that's how they do it in the industry and there is this aspect of it. But then the constructs become too many constructs when you talk about collaboration, and then I'll have to think about what are the distributed cognitive processes, what is the cognitive process that is happening across the two individuals, what are the cognitive process happening individually, becomes a lot of constructs. So
this is really, so the short answer is it's in the future work chapter. Good. I'm extending that answer.
Thanks.
All right, let's go.
So we are starting the next session. Come. Okay, so in Lakshmi's example, what we looked at was software design. Now what we will look at is an analysis problem. Okay. So again, the same context of software. Now instead of having to design something, we have to analyze something. So that's the context in which Brajesh's work is.
Okay, hi, good afternoon. I know it's Evening, Yoga. Yeah, so I think after Lakshmi's case study, I think you must be overwhelmed. So what I'll try to do is give a flavor of how I approach my problem and how I identified what learners find difficult, and then try to design something which will help them, do software design comprehension. So my broad research goal is to help my coming to it. Yeah, so I'm a 5th year PhD student working under Professor Sridhar Iyer, and my broad research goal is to help students comprehend software design. Yeah.
I'm not saying that you are my student. What is your background? What are you
So, prior to starting my PhD, I did an MTech in computer science, and after that I worked in industry for some time, and then I was a CS instructor in an engineering college in Mumbai. So all these places, I gained motivation from all these places, and that's where I am now today. So, so in the industry, I was working as a software developer, and what I saw there is, unlike what problems are given to students in the classroom, design something from scratch. But when I entered the industry, what I realized is that from day one, I have to start working on an already given design, right? There is an existing code base, there is an existing design, and I, as the junior most member, would have to maybe fix bugs, add a new feature to an already existing design. So all this made me, I had to comprehend a given design. And while I was working as a CS instructor after that, I realized that students were not doing enough of such activities. Given a large code base or given a lot of design diagrams, are they able to actually understand it? So what I found out was that, as instructors, we are not training students to do this, and which is a very important skill which they require in industry. And so then I looked at existing solutions, I looked at literature to see what they have to say about teaching learning of software design comprehension. And what I found out is that there is a lot of work being done in program comprehension. So given a program, how can you help students understand the program? But similar work was not being done in the area of software design comprehension. So, and I also did some literature review on what difficulties students face. So now, before that, I would like to, start by setting and giving an example. So let's say this is a list of requirements for a door locking system, for example. So maybe you can just spend a minute reading each of these requirements. So basically it's requirements for what happens when the lock option is set, when the unlock option is set, and some registration and so on. So corresponding to these requirements, now the design can be certain class diagrams, certain sequence diagrams, and the comprehension task is, does the design satisfy the given requirements? So for example, this is the class diagram for that door locking system. It contains classes. Each class has some variables, some member functions, and for different functionalities, for example, for the lock functionality, this is a sequence diagram. You see that there are interactions between different objects, they pass messages and so on. So we'll just move on to an activity. So all of you most of you are instructors, so can you think of some difficulties which students have when you give them these requirements and you give them, so this is just an example. So consider that there are like this sequence this class diagram and like 4 to 5 sequence diagrams, some use case diagrams. So a combination or multiple design diagrams are given to them, and they have to understand or make sense of all this information. So what do you think are difficulties which students can face? Yes.
How to identify classes is a big problem. How to identify classes is a very challenging problem.
Okay.
And normally, most of the time, people used to say nouns could be identified. Right? When you come to DBMS, right, you have a conceptual design. There, you have a requirements, you capture all the entities, ER diagram, at least slightly smooth. But here, that is the reason in the previous session also we asked about what is the process, right? You have something, for that you draw some diagram. I would appreciate the class diagram. So how you have only use cases, am I correct?
No.
No,
So
previously.
Previously, yeah.
Before drawing class diagram, some input is available.
Right.
Am I correct? What is the input available? That is
So the input available are requirements and all the design, all the design diagrams.
Input available is generic word. It is in form of some, what is that, specific quantity, right? You have to quantify. Instead of telling input available, in what form it is available.
Okay.
That form is very important. Okay. That is taken further to the class level. You have to appreciate in what form available. You cannot have a software to capture all the classes. You cannot automate.
Right.
Am I correct?
Yes, yes.
So before that, something is required, some input form is available. From that, we could draw what is that, a class diagram. So what is available? What is the form available? From that, you are going for class diagram. These students are not that comfortable.
Right.
They cannot correlate as well. They cannot correlate between two different kind of diagrams, like from class, what should be the sequence, what should be the end, the sequence and all. Like, so completeness is missing many times.
Also, no. The thing is, before correlating, before classifying as classes, I feel they don't understand the importance of the design diagrams. Okay, because I don't see the point to sit down and draw with the scale, the boxes and lines, and connect like this is happening there. I would rather have a pen and draw a rough diagram. Okay, so I really don't see the importance.
So it is only spent as compared to UML diagram. I'm not telling that UML diagrams are much better.
Your requirements are already specified, isn't it?
And the design diagram.
No, like after the requirements are specified, usually then we go for the use case diagram. And then we elaborate the use cases. Because once you elaborate the use case in a very detailed manner, then you can understand the class diagram. Because students, students will
design. Okay, we are doing analysis. So you are given a bunch of diagrams, and you are given a question that do these diagrams satisfy this requirement?
But for that, that requirement has to be elaborated.
That is done.
Yeah.
That is what you showed in the earlier slide. So now, given this, what do you think students will have difficulty?
So when they join the industry, right? So they join an already existing project.
Yeah, that is there. The maintenance work mostly, all the people they do that.
Maintenance, or they have to add new features and all. So all of this is already given. They are not designing a new system from scratch. So given a system.
So you need reverse engineering.
Not reverse, not exactly reverse engineering.
Just addition of some functionality or some kind of.
Adding some functionality for already existing.
Your maintenance activity.
It is software maintenance only.
Classes, when they take these courses, they don't used to draw this kind of diagram. For example, in database course, if you ask them, they directly jump to the table description without drawing the ER diagram. So once an ER diagram is given to them, they will not be, probably that is the biggest problem.
First of all, I think they wouldn't know where to start. They're given a bunch of diagrams. They wouldn't know where to start, where to jump to. And also it would look very complicated, so a lot of them might get psyched out also.
This actually happened. Okay, so I think Since you said analysis, I think one needs to clarify what is it that they're analyzing. So you said there's requirements, some design is being given. So naturally the question is, what does it mean to say that the design satisfies the requirements? So that is not, that question is missing, right?
Sequence diagram. That's given. So this sequence diagram I'm giving to the student, and I say that check this diagram.
Yeah, but do they know what check means?
Yeah. So check this diagram to see whether go back. One more back. To see whether this happens properly. That's the question. Okay. So now the question is, what do you think they will do when they are given this task? Okay, so for example, when user chooses unlock option and enters the correct passcode, the door should unlock. Now again, let's go to the diagram. So if you're, as an expert, you'll kind of run through this and see that, okay, it's happening there, it's not happening here, and is that particular variable there in the class? All those things you'll do as an expert, right? Just like we did for the previous topic. What will the student do? What do you think the student will do? These very interesting observations we got. Okay. Very insightful observations. So I'll let Brajesh go ahead with that.
Yeah, can't wait. It's too suspenseful.
In this case, the sequence diagram is giving life for use case.
Yes, yes.
Giving life for use case. This is the sequence diagram.
Right. So
they can use case. From that you draw what is the sequence diagram.
Right. So you as an expert can clearly tell that, but what we have found and what literature tells is that what my literature review says that many of the points which you all said, like they are not able to correlate, they are not able to identify connections. So all this is true, and many people have done studies, and so someone said they don't understand what is the point of drawing these diagrams. So students don't know what is the purpose of creating these different diagrams. They have difficulties in linking these diagrams. What is the relationship between a use case diagram and the point exactly what you said. They are not able to link it to sequence diagrams. So studies have been done and people have seen that students are not able to do this. And someone said about consistency, completeness, there is missing information. So, and there are some things which are there in one diagram which is inconsistent with some other diagram and so on. So these are difficulties which students face, which we have found from literature. And similar to what Lakshmi did, I also conducted a novice study where students were given the same problem, and we captured what they were doing on video, we analyzed what they wrote on the sheet, we conducted interviews with them, and we followed a very rigorous analysis. I'm not going into the details as Lakshmi already mentioned that. So two main results, what we found out was that students, they were not able to imagine scenarios, where the design breaks. As opposed to, we conducted this study with experts as well. The first thing which experts do is try to see where the system breaks. Okay, this is the requirement, this is the design. Let me see where the system is breaking. For which scenarios is the requirement getting violated? But students, they look for confirmatory evidence and they just accept the design as it is. So that is one interesting result which we got. And the second thing is, they do not think of, variables. So by variables I mean, next. So there are different diagrams, right? So when something happens in the sequence diagram, some variables change, right? When a function is called in the sequence diagram, some variables in the class diagram change, right? So students are not able to simulate such changes in the design, which experts are able to do. So for example, you see something, so some function gets called here, and correspondingly some changes happen in the class, in the objects which are created. Students are not able to simulate these things, which experts are able to do. So these are...
One more very interesting thing which we observed, and this we did not know ourselves before we did this study, was that students run away to add features. Okay, so they have been given this diagram, they have been given this requirement, they have been asked to check whether this diagram satisfies that requirement. Did anybody ask you to add features? Okay, everybody is adding features. Oh, you know, we can do this. Can you give an example of?
Yeah, so some people said, okay, I think we have to add some more authentication, you know. We have to check the, you know, the passport should be more than 4 digits and all of that. So we have to introduce some biometric feature and so on. So we were not expecting this, you know, because what we predicted was that students will stick to the problem which is given. So this is not wrong, you know, adding new features and all is not wrong. But what we felt was that they were focusing on, you know, adding features as opposed to checking whether this design satisfies the requirement or not.
Just a quick question on that.
Yeah, sure.
The process is iterative and incremental.
Yes.
Right?
Yes.
That means you can add features.
Yes. That I agree with. I'm not saying adding features is wrong. Yeah.
So is it possible, I'm just thinking aloud here, is it possible that they started adding features as in response to your trying to get, maybe they felt that there were not enough things in the design to satisfy the given requirements. So they were actually adding features to fill that gap.
Not really. So see, as an expert, as an expert, when you are given a verification task, what do? You do a verification task. You don't do a design task. Right? Very clear, yeah. Very specific requirements are there, and it's a very clearly a verification task, right? So they can't make the distinction between the verification task and the design task.
So one quick question. This is at Tier 2 colleges or?
Tier 2 colleges.
Yeah. The biggest challenge I am seeing there is now most of these people go through some literatures like electronics for you or various things. So they know some standard projects. So any problem that you give, this is like, you know, there is a neighbor of mine who is very good in drawing, you know, what you call, you know, some sort of lamp or something. And then he went to a competition where he was given a port. And he drew the lamp, you know, in the competition. So that means, you know, they synthesize from what is there in their memory. That's why the sugar coating and all happens, because they want to put all such things as possible, no? What do you know?
Yeah. So, and I think another reason is that the kind of questions we give them in the exam and how they are taught is, you know, this is, you have to design this. So design as and much, like add as many things as you want in the design. So I think that's how we are training them. But when they enter the industry, we have to realize that they also have to understand and comprehend designs. And that's one gap which we are finding. So based on the results, what we found out was that, you know, in order for students to think deeply about the design, they have to think of different scenarios where the system can break and think of the relationship between different diagrams by thinking of variables and how are these variables changing and so on. So the pedagogy, or how can we train students to do this? To think deeply about the design, to think of scenarios, to think of data variable change of variables. So we have come up with this pedagogy. So what it does is, a scenario is presented to the learner, and this learner has to construct something like a state diagram where these variables are taken from the class diagram and these events are functions which are taken from the sequence diagram. And at each state they have to simulate, you know, what are the change of variables based on the event which is there in the transition. So for example, for a scenario like this, when the door is initially locked and the user selects the unlock option and enters the correct passcode, the door unlocks. So by implicitly telling students to create something like a state diagram. What we are trying to do, what we are trying to instill in them is to firstly think about which variables are relevant. Then what we are telling them is to identify relevant messages from the sequence diagram, right, which are these. And based on these functions or messages which are being called, how are the values of variables changing? So for example, if I select the option unlock, this option selected initially was null, but a function is being called which changes the value to unlock. And finally, when the door unlocks, the value of lock should change from true to false. So in the process of them constructing the state diagram, what they are actually trying to do is, what we are trying to make them do is think deeply about the design, think about the connections between the class diagram and the sequence diagram, and think of different scenarios in the design.
Where do you draw a line between a developer and a tester in the scenario? Okay, where do you draw? Because the scenario, whatever you have told, is that the students couldn't actually think of the scenarios where the system breaks. But that's something, when we look at a beginner level, it's a tester level job. Okay, so as a developer, where do you see, do I need to learn something like this?
So
as a student.
Yeah, so
I won't think of this because my job is to list down the features and I have to develop it. And it goes to the tester has to test it because I'm in that mindset of doing it. So where do you draw that line, that until what point I should think, and after that, that tester can take over?
So the thing is, you can't clearly draw that line, right? You as a developer, it is your responsibility to test your code as well. So we are not thinking about programming at the programming level now. So we are still in the design phase, right? So even before you give your design to a developer, you have to ensure that your design is correct, right? Otherwise the same errors percolate to the code and then the tester has to test it out, right? So we are at the level of design, right? We are not entered programming yet. Yeah.
So I guess the distinction is between do you want to be an engineer or do you want to be a coder?
No, yeah, actually, clerk.
Yeah, or clerk, okay.
Yeah.
Or coolie, or whatever the word is these days.
No, that's
so, it's really about that.
And what's happening, these engineers, they have got the constructive, thing only people are interested. The destructive aspect, because that's what tester does. So both the mindset should be there in every engineer. Then only your products will come out.
So in the interest of time, we are going to pass the mic to those who have not spoken so far. Okay? Yeah.
I think you should make it clear that this tool is used for the teachers who are teaching a software engineering course. Then the entire questions will be gone, I guess.
Yeah. So now that we have thought of this pedagogy to address the difficulties in the previous slide, so so what we have designed is a learning environment called Verisim. So Verisim is a web-based self-learning TEL environment which trains learners to apply this design tracing pedagogy. So we, to summarize what we did, we identified learner difficulties, and based on these difficulties we thought of a pedagogy which we drew from various from various sources, why is this pedagogy important and so on. And then we designed a technology enhanced learning environment. So I'm not going into the details of everything in the learning environment, but broadly there are like 3 stages. So the first stage is the problem understanding stage, where learners are introduced to the requirements and the design diagrams of the same problem, or an automated door locking system. And the second stage is the heart of the learning environment, which helps learners trace scenarios in the design using this design tracing pedagogy. And finally, after they have understood the requirements, the design diagrams, they trace different scenarios, finally they reflect on what they learned. So they answer some subjective questions and think about how it will be useful for them in the future. So, and how we are teaching them is, gradually taking them through different challenges. So, first we will give them a filled state diagram. Okay, so that is challenge 1, where they will explore the model. A scenario is given, a state diagram is given, they will just explore the model. Then we will give them an incorrect state diagram, and in challenge 2 they have to correct that state diagram. Then we'll give them an incomplete state diagram, they have to complete it, and finally they have to construct the state diagram from scratch. Present. So I'll just give you an example of how we are doing this in the learning environment. So as you can see, the challenges are there on this side. So a learner starts from the first challenge, where you see that the state diagram is already given, the class diagram is there, the sequence diagrams are there. So a learner gets a quick introduction about what do these states mean, and what do these transitions mean, and so on. And then there is a feature called run. So what happens in run is, when I click on run, a particular part of the scenario is highlighted, that particular state is highlighted, and corresponding changes in the sequence diagram and the class diagram are highlighted. So learners, as they so-called run the state diagram, they are able to see that the sequence diagram, the class diagram, all of them are interconnected, and how changes in the state diagram based on the scenario execution is causing changes in the class and the sequence diagram. So, so this is the first challenge. So they are just being introduced to what is a state diagram, and based on that they solve some reflection questions which test their basic understanding of class diagrams and sequence diagrams and so on. So after they have explored the state diagram model, then the second challenge is we are giving them an incorrect model, okay, and so there are some errors in the state diagram over here, and we want learners to explore what is the error, okay, and so one learner can start, they will directly click on run, for example. So this scenario is related to the unlock sequence diagram. They click on run and they see that this turns red, and which indicates that there is an error in that state. Some of these variables, something is wrong. So based on this, they then go to the edit button and they edit the states. So for example, they see that there is some error here. So they edit the state, and based on the scenario, so they realize that lock should actually be true, because in the initial state the door is actually locked. And then they can run it again and see that, okay, that state is fine, but there is some error here, and so on. So in this iterative process of fixing this state diagram, what we are trying to help them understand is that they are thinking deeply about variables in the class diagram, what is the relationship between these variables and what is happening in the sequence diagram, and so on. I won't get into the details of the other challenges. In the third challenge, the model is incomplete. So the state diagram doesn't have any of the variables, So as you can see, none of the variables are there. So they have to firstly think of which variables are relevant from the class diagram, then try to initialize the values of the variables, and for that given scenario, how are these variables changing? Yeah, so I'll skip this. So this is our learning environment where we are making learners trace different scenarios and trying to understand what are the values of variables for each scenario. Yes, so the diagrams are entered beforehand. So students do not have to construct the diagrams. As we saw in the example, the diagrams are already given to them and they have to trace these scenarios. Yeah, so in the fourth challenge, they have to construct on their own. Maybe I can. Yeah. So the states aren't given, nothing is given, so they just get an the scenario is only given. Yeah. So that is the goal, but right now we have just added it for one problem, but in the future we want to create an authoring tool where teachers can add, different diagrams and then any problem statement. Exactly. So now that we designed this, now we have to actually analyze, or we have to evaluate what type of learning is happening. So so this is a study plan. So this is the study plan which I am trying to follow. So what we do is we go to colleges. Okay, we request for a workshop kind of thing where we allow learners to interact with this learning environment, and then we analyze. We do analysis on the given data. So for example, we
had a very interesting surprise in the previous workshop that Prajesh conducted. So he had planned for 30 learners. Which college was it? Father Agnells in Mumbai. And 90 learners showed up. So he was left with the problem of plenty.
Yeah, so this is like an example of how we conduct studies in colleges. So what we do is we introduce, the purpose of the workshop, and yeah. So then we give them something called a pre-test, where before they start interacting with my learning environment, we give them a test which tests them on what we want them to see if there is any improvement or not. So for example, in this case, we give them a test of a problem similar to what we saw in the door locking system. So we give them designs, we give them requirements, and we ask them, does the design satisfy the requirements? So that is given before they start interacting with Verisim. So after they finish the pre-test, then the intervention is given to them. After they work with the intervention, then a post-test with the similar kind of problem in the pre-test is given. And then they fill a feedback form, and then we conduct interviews with them to get their perception of what they learned. How did they find the learning environment? Do you think it is useful for them, and so on.
What did the post-test do?
Yeah, so the analysis is still ongoing. So, but what we hope to see is that in the pre-test they were not able to identify these, whether they are able to satisfy the design diagrams or not. But maybe in the post-test they are able to. So we really don't know if that is happening. So one way to measure, if our tool is effective is the point which you said. Compare their post-test and pre-test, right? If there is significant improvement in the post-test, that gives some indication that my tool is effective. The second type of analysis is we can infer some things from the learner's perception itself. We conduct interviews with them and then we ask them, okay, how did you find the learning environment? How did you go about solving the task? Before the intervention, you did something. After the intervention, did your process of doing that change? What are useful features in the learning environment? So all this type of analysis gives us insights on their perception of what they learn, which is also useful. And the third type of analysis which can be done, this is the lab study which we did with around 95 students. And before that, as Sir had mentioned, we do some pilot studies as well. We do 2 rounds, so we did 2 rounds with 5 students and we were trying to see what are their perceptions of design tracing. So the third type of analysis which can be done is using learning analytics. So for example, in Verisim all learner actions are logged. So when they click on run, when they edit the state diagram, when they add data variables, so all these clicks and interactions are logged by the environment. So for this study, there are around 6,000 log entries. And so for example, this is an example of a log entry which contains fields like data action type. Did I click on add a variable, delete a variable, edit a variable? The variable is from which class? And what are the values in each state? So based on what they, how they solve the state diagram, so we assign a score to them. So we assign a score. So if all the values in all the states are correct, so for example, they get a full like 100%. So based on the correct values and events in each state, we assign a score. And that score is reflected here. And we have many other messages and other entries as well. So what we want to do is, using this, we can analyze important things like, it can help us answer questions like, what are different strategies which learners use? Some learners can, they might run, see what is the error, fix it, run, then fix the error in the second state, run, fix, and so on. Some people might, edit all the states, correct everything and then run. Some people might be repeatedly adding incorrect variables and so on. So based on these patterns and strategies, we can classify them into efficient and inefficient strategies. And so these will give us insights on how learners are doing design tracing. So for example, the pre-test and the post-test will just tell us that yes, maybe there is an improvement, but how are they actually doing this can be answered by using analytics, and how features are helping learners trace scenarios and so on. Yeah. So that's about it.
Yeah, so I'll just take 1 or 2 questions on this before we go to the next one.
For the software engineering, there is an rational rows is one software where we have to input the various attributes like the user and use case diagram. So whenever you put all these requirements, we will get all the things, use case diagram, activity diagram, and all the diagrams, so you can see it. But what is the difference in that scenario and in your tool? That is the question.
So that's a very good question. So firstly, rational rows and all is a tool, right? And so we are not claiming that we are a tool where we can where learners can input, design diagrams and so on. Ours is a teaching learning tool. So there are different features like, you know, what you saw, the run button, they are able to edit state diagrams, so there is a agent which gives feedback and so on. So through these different features, learners are actually trying to understand the relationship between the class and the sequence diagram, for example. But in the case of rational rows, the requirements are given and they have to design everything from scratch.
Test cases also. They are having their test cases also.
They are having their test cases also, yeah.
Test and post cases.
Okay.
In your two rows, you are saying the same thing is available.
So we are going to do that offline. Okay, because I don't want people's mind to switch to the cruise yet. So before that happens, I have two more to talk about. Yeah.
Hello everyone, good evening. I am Deepthi Reddy and I have submitted my thesis and I will be defending shortly. So my work is on teaching learning of expand reduce skills in software design in the context of data structure. So let me introduce myself. I'm also teaching as a college teacher in an engineering college affiliated to Mumbai University. And I've been teaching for 14 years and mostly I've taught data structure course. So I've seen that after teaching data structure course, at the end when you give students a problem, a real life problem, and ask them to use appropriate data structure to solve this particular problem, like you don't see that the skills getting transferred. The content which you teach, you don't see that the skills of choosing appropriate data structure to a given problem, those skills are not getting transferred. So there is a need to explicitly teach those skills to them. So that is my research problem during my PhD. So coming to the problem which I am giving to students to solve and to make them learn these skills. So if a problem posed is to design a library record keeping system, so the problem is very broad and it's like you're solving a real life problem. So how experts solve this problem from various literature in problem solving and expert studies. Just to illustrate, this diagram is shown. So experts' approach is they work on problem space and solution space. Like in problem space, they will draw some diagrams like state transition diagram or use case diagrams or entity relationship diagrams and understand, analyze the problem and break this problem into sub-problems. And for each sub-problem, they'll think of alternative design options, think of criteria, do quick trade-off analysis and select the solution. So this is how experts follow. But when our students, when we give the same problem to our students, like already stated by Lakshmi, and you all also discovered the same set of problems that students face, they will be concentrating on one of the very obvious function, like search for a book in library. And they may not think the dynamics involved in the system. So actually this thinking of the problem space as a whole is missing. So this diagram part is missing in students' mind. They will think on one functionality and write the algorithm for solving that particular one functionality and think of a data structure which is easy for them to implement, and using that data structure they will represent the solution and done. So the solution is usually incomplete. It cannot be converted into a complete system. So coming from literature point of view, doing some analysis, literature analysis, we found out that experts actually expand and reduce both problem space and solution space. So in problem space, they think of a problem as a whole before actually decomposing the problem into sub-problems or functions. And in that process, later on, for each sub-problem, they will try to think of all alternative solutions and do a quick trade-off analysis based on some feasibility criteria or any criteria which they have already come across and select the solution. So obviously students are not doing all this, so they are not even able to justify why they have selected a particular data structure. So to teach these expand reduce skills to students, I went through 3 cycles of DBR. Already what is DBR? was told to you, so I assume that you all remember. So in first cycle of DBR, the goal was to understand the problems that are faced by novice in applying ER skills. So we did some exploratory studies, and the pedagogy, like we developed a initial prototype where the prompts were given to students to apply this ER skill systematically. And the drawing tools were also given to them, that you draw this particular diagram before in the problem space. And in solution space also you draw some diagrams so that you explore all the possible solutions, components before you formulate the problem. So the exploratory study was done with almost 100 students, and like it was a 2-year study. And we found that prompts are not very effective in triggering their thinking towards the expected level. So if we say just think of alternative solutions, they don't know how to think. So more help is needed. So in second cycle of DBR, we did more analysis from literature. We did in-depth analysis to find out how to make them think. So not just giving them cognitive tools and prompts is not helping, definitely. So we gave them examples or similar case studies. Similar problem, how experts will solve, it was given as a case study in each and every step. So by seeing that case study, the student thinking direction, like they were able to think now, okay, this is how I need to apply my thinking, and this is how I need to solve the problem. And also, this is a cognitive process of doing something. But even experts are involved in metacognitive level. So what I'm doing, they are constantly assessing and are constantly improving the solution in that assessment point. So we also make students assess whatever they are doing by using self-assessment techniques. So in the study we found, again the experimental pre-post study, that example was helping them to solve the problem, but they were not able to evaluate themselves. So self-assessment was not very much effective. They were either overestimating or underestimating what they are doing. So in third DBR cycle, we thought of improving or working on this self-assessment part, the metacognitive part. So the features that we added more were, we made a system generate the feedback. So based on the entities that the students have identified, based on the responses that the students are giving, system will do a preliminary check, whether all the entities are included or not, whether all the alternatives are explored or not, and then give a feedback. Okay, see, this is where you can improve, or this is what you have missed. So system is generating a feedback. Now students know, okay. So from expert, if a feedback is coming, students start thinking, okay, I missed something, so I need to check. So to check, again we are giving some peers, what their peers have done. Go and check in the system itself. So they know that, okay, this person, my friend has added this particular component which I have missed, so they may add it again. So again, with this third iteration, we did a study and we found results were good.
So here again one more meta comment, which is a takeaway, that when you are solving your problem and you are building your own tool, initially, I mean with my previous batch of students, we used to actually wait till we got this before we did this. And then only we realized that as soon as you built the most basic system, you need to go and test it out. So this we would do in other domains, right? Like when you're building a game, you immediately go and do some play testing. But in this case, we thought like, look, no, we have to think a lot, put a lot of scaffolds, put the whole thing into it and then go and test. So this is a very nice way she has summarized how the number of stars increase from one cycle to the other. So it's not necessary to finish constructing your entire system before you go and test it out with learners.
Okay, so this activity we thought of doing, but I'll skip it. Demo. So this is a third version of the system in which we are targeting to teach expand reduce skills to second year engineering students who have completed data structures course. So after students log into the system, the problem to be solved is posed. So they read the problem, and when they click on start problem solving, then the structured way of solving is shown on the left hand side of the screen. So understand the problem, formulate the problem, then generate solutions, think of the criteria, evaluate the solutions against those criteria, and select and justify. So this is how they are drawing the system, the library system in form of entity and interaction, seeing what their peers have done, and based on the feedback they will include data, functionalities that the system should achieve. So the feedback is given by the system. Okay, good, you have identified some entities, but you have missed some of them, so please go and check, or check what your peers have done, come back and again change the answer. So the feedback was definitely helping students to think of what they have missed or assess their competences, go back and change. So that was the important part of learning that was happening through this system. So these are some diagrams for expanding problem space or solution space, which allows them, which gives them the affordance to visualize the whole system, or to think of the alternatives. So just to show how we have analyzed the data, like we give them pre-test, do the intervention, give them post-test. So we have analyzed pre-test, post-test scores using the rubric. So all these expandative skills are listed on the first column. And then we see if there is gain, learning gain from pre-test to post-test using some statistical tests. So one was t-test and the other was effect size. So if the p-value is below 0.05, then it shows that there is significant learning gain from pre to post.
How it will works on breadth first search and depth first search?
Depth first search and
Breadth first search.
different topic, you mean?
No, it is a data structure part.
Huh.
So
Actually, we are not teaching any concept over here. We are giving them a problem, any real life problem.
This is the problem. That you want to design a breadth first search and depth first search by giving some inputs, or any other example like activity networks or activity diagram or topological sorting and everything.
So if breadth first search or depth first search is applicable for the given problem, they have to just give the name that this particular algorithm will be used to solve this problem. They may not be implementing it.
So alternately, if your goal is for them to learn how to do BFS, DFS, then you have to construct a scenario where the need for that, that action is felt. So that's a different. So again, just like Rajesh mentioned, authoring interfaces are being built, not yet there. So you will have to construct a scenario, corresponding where they'll feel that okay, should I do BFS here? Should I do DFS? And then you take them through the same expand reduce phases. That's the idea. Okay. So in the interest of time, we'll not do questions now, and we'll go ahead with the last one. It's a slightly different topic from software design. So I thought we should get a flavor of not just software design all the time. So Kavya.
Hi, my name is Kavya, and I am interested in seeing how students develop troubleshooting skills in the context of computer networks. I have never been a formal teacher, but I wanted to be a teacher, and whenever I was preparing for exams, I was envisioning, okay, when I'm teaching this topic, I would teach it this way. So that's how I came into ET department. And networking was an interesting subject, so it turned out that I ended up with this research topic. Most of you would probably agree with this definition of troubleshooting, that it is a process which ranges from identification of problem symptoms to resolving what the error is. But this troubleshooting as a process is found to be difficult for novices because there are multiple things going on. If you take the example of a computer network, the students would have to know how each of the devices in the network is working, what are the ideal or desired behavior of the network, and what is the exact deviation from the desired behavior, etc. So it is not learned by just teaching some tools and by showing that you know how to use this feature or how to use this feature. It is known that students will not learn this process. And also for novices, domain knowledge is not always sufficient. Experts might come up with, oh, you know, I was working with this system and a similar error showed up that day. So probably here again the error is because the server is configured in such way. So students don't have such type of experiences, so it is hard for them to troubleshoot. So I'll go ahead with an example for the presentation. Let's think of this small network which has a terminal, router and a server connected to it. And whenever a user in the terminal tries to access some website which is hosted in this network, the desired behavior is that the network should be shown in the browser screen. But let us assume now that the behavior is the terminal browser screen displays something like hostname unresolved. So in order to structurally troubleshoot it, what you should do is you should know that the desired behavior is a result of interaction between this and this structure and function of the network here. By function, what I mean is in order for this desired behavior to show up, each of these systems should implement the functions that they are responsible for. The terminal should send a request, the router should forward it to the correct port, and the server should send the correct response. Those are the functions, and in order to implement these functions, each of those devices should be configured in a correct manner. For example, the IP addresses, the routing table entries should all be correct. So an expert would connect these in an instance to predict or imagine this desired behavior. Or you know, if this is what the desired behavior is, then these things should be, the values of these things should be these, and then first this thing happens, next this thing happens, and so on. So expert would identify and connect these things. This is known as problem space understanding. So what devices are there in your network, how are they behaving, what is their function, etc. are thinking in this way or understanding this is called problem space understanding. Now after this understanding is there, then you can come up with many plausible causes for the error. You know, I will start with here, I think the connection or the internet connection is not working. Or it might also be the reason that the website itself is down. So these are called hypotheses, the plausible causes that you come up with. And then you pick one hypothesis, let's pick the first one, and then see how to investigate further using that hypothesis. If the hypothesis says that internet connection is down, then I can probably go and check other websites or other means of testing internet, maybe ping something and see if the internet is working properly. So this process is called designing and running some tests to verify whether your hypothesis is correct or incorrect. And after you run a test, then you can analyze the result. Let's say if some other website is accessible, then it means that there is no problem with the internet. So I can discard this hypothesis and move on to next hypothesis. This is sort of the structural troubleshooting that I'm trying to teach.
So just to give you an idea, so if you ask maybe even your own sysad in your college or department, when you tell them this, the first thing they'll do is they'll open a configuration window, they'll change some configurations, okay, without any hypothesis, right? That's what novices do. I mean, by sysad, I mean the entry-level sysads in your, I mean, we are all familiar with that, right? They'll change this, they'll go plug that, they'll go do this. Why are you doing all this? There's no conception of problem space understanding, there is no hypothesis. And getting students to realize that, these are things that we have to do before we start actually messing with what is the configuration, what to change. That's the key thing of Kavya's work.
Read only. Sorry? Read only it should be.
On this one.
Yeah. So, yeah. I think I have explained this already, what you do in each of these. And I'm going to skip this activity. So I again did a novice study with to understand what difficulties are faced by students when they are given a network troubleshooting problem like this. And there were 5 students who had already gone through computer networking course. They were familiar with packet tracer in their practicals, and I gave them one problem similar to this and allowed them to use internet. They were allowed to use Google search to do any search they wanted to do, or they were allowed to install any software and analyze packets, whatever they wanted to do. And then I recorded their screen capture and my audio conversations with them, and coded and analyzed what were they doing at any point. And these are some of the results that I found, not all. The first thing is, it is hard for novices to think at multiple levels of details. At one point, they were thinking about, let's say, packet forwarding by router, and then the next point they were switching to a switch which was there in the network, and they were confused between how a router works and how a switch works. And it is difficult for novices to simulate the desired behavior like experts do. And n number of time I found that the students were sort of trailing off. They started with one thing, and then they found out that, oh, you know, I can change something in this router here and I'll go and see what will happen. And they would go off that way without actually restoring to the initial stage with the first experiment that they were doing. So, yeah. So with these difficulties, what I'm going to do now is to give you a glimpse of how we take these difficulties and come up with the interesting learning environments we saw, the 3 interesting learning environments. So we start with what are known as learning objectives. For each of those sub-skills is what I say: problem space understanding, hypothesis generation, and all. I have a specific and measurable thing. What students need to do in order to say that they have understood the problem space. The students will be able to identify information at different levels. That is the objective I have for problem space understanding activity. And then the difficulty which was related to that stage was they were having insufficient domain knowledge. They were not able to simulate expert-like behavior. And from expert literature, this is again troubleshooting literature from related domains. Like I went and studied how troubleshooting experts in electrical systems, how mechanical system experts would actually go and troubleshoot the systems. So they were simulating the desired behavior. And then I went and searched in the literature related to problem solving, which is similar to troubleshooting. For example, there are inquiry-based systems which are designed for high school students to teach hypothesis testing, or you know, we all used to do this practical in our 11th and 12th. You had to write the aim, hypothesis, and how you collect data. So there are systems to teach kids such things. So I went and searched the literature for that, and there are some guidelines there, how you can alleviate such difficulties. So we mapped this. I started with what I wanted to do, and I knew what difficulty was being faced. And expert literature sort of gave me again what I want to do or what experts are doing, and what affordances in technology I can exploit to make students develop this. So this is how I mapped, and then each features of the systems were designed. So this is one feature to make them understand the desired behavior of the network. So in my novice study, what I did was I tried to explain them the whole desired behavior, but I found that even at that level it was difficult to them. So here I have actually broken down understanding into 4 subtasks. In the first task, it broadly asks them what are the transactions that happen at broad level when you are accessing a website. the first request goes to DNS server and then IP address comes back. Then HTTP request goes to the web server and then HTTP response comes back. Those are the 4 statements there, which are in a jumbled manner. So the students have to identify the sequence of activities that are happening in the correct order, and then feedback is given in the form of a short video, which is sort of reinforcing their knowledge. It is showing them how the transaction happens in a packet tracer simulator. After that, we are going into a little bit detail of each of the devices. If you are considering the DNS server, what are the main functions of the DNS server, what it should do? It gets a response, it has a DNS table, it should have an A record mapping the website URL and IP address, so it should send the corresponding IP address for the website URL it has got. So that thing again, it is a jumbled statement activity which they have to sort in the correct order. So there are statements at very broad level, what transaction should happen, and then there are statements with respect to each of the devices. This is how they are going to understand the system. And the next activity is now to juxtapose the correct behavior which they have understood and then the faulty behavior. Here they are given a bunch of statements. Some of them are shown by the correct system, that is the system without any error, and some of those statements are shown by the erroneous system. And there are 2 bins, baskets below. So they have to drag and drop which behavior belongs to which of those systems. And again, the system will give them response as in depending on what the things they have put in the basket. Yeah. So now I have these 2 features, and like sir was saying a while ago, you don't need full system to do your first testing. I can go with these 2 features and do an experiment. For example, I can have this conjecture or hypothesis to start with. Based on the literature I have read and the system, I have a conjecture that after using these 2 features, understand and juxtapose, students will be able to identify and connect information related to the network at multiple layers. Now what I'll do is, I'll again find some 4 or 5 students and then give them a network troubleshooting problem in simulator, and then ask them to use, I will be like an moderator or observer there, and I'll ask them to, when I find that they are stuck at some point, why don't you go and do this activity and then come back and do the problem solving activity. That is how I'll find out that when the students are stuck something and I show that this, when I give this hint, that actually helps them in problem solving. That is how I do the testing of my system in parts.
Yeah. Okay, so let me now tell you one, okay, yeah, you can finish with the class. So let me now tell you one secret. So I gave them a very high level requirement saying that this is a workshop that we need to conduct, you guys have to take whatever you are working on and you need to create this workshop. And they've done a wonderful job, I'm really proud of them. So it's not typical that usually you're worried about your own problem. My thesis, where's my thesis going? And now here they are, they've put it together to synthesize how this education research is to be done. And even these slides I'm seeing for the first time, and I hope they made sense to you. And I think we are bang on 6 o'clock. Okay. So if there are any queries, feel free to write to us. We can talk offline also outside. Can you put up that compute web page again? Oh, okay, it's there here. Okay, yeah. So this is the one, computing, IITB Computing Ed Research, and all these systems are there. I know that you were not able to absorb the details of all these systems, what features are there, so on and so forth. But you can go there to play with these systems. Authoring interface will soon be there. All right, thank you very much.
Yeah, I think on behalf of the organizer, we do the task of giving the mementos. Okay. Hey, but there is somebody's mobile. Somebody has left the mobile, but you'll have to verify. How do I know that it's yours? So, sir has not been. Sir is last. Yes. All the four. So anyway, this was a very request which came in very at the last minute, but in spite of that, I think we being pulled up very good. You look at your team next, that's on tomorrow.
That's a different thing.
So there is another workshop that we are doing on book. Okay, so there is another team after a year which is arriving tomorrow morning, and they are going to do a 2-day workshop on student-centric book. That's going to be done in our studio. But he's the common person.
So, and why we are doing this is that this is the only way to scale up the manpower resources. If I keep going and doing the workshop myself, we'll do 5 workshops a year. But now, and we have how many alumni now? 12. We have 12, 15 alumni. So all of us put together, I think we are doing how many? About 50 workshops a year. So that's the level at which we have been able to ramp up, primarily because we have great students.
So there is a request, we have one photograph to participate in. Maybe we can have it outside, just in front of the bus.